Give the folks a final minute. All right, let's begin. My name is Gordon Guidofavi, and I am a consulting systems engineer over at Nokia, focusing on data center fabrics. But more importantly, I am a developer of Container Lab, and I have been helping out maintain it a bit as well. So what is Container Lab and what can it do for you? This is the sort of question that I aim to answer today, and hopefully you will learn quite a bit about this tool. So you probably used a network virtualization tool before, like GNS3, EVE-NG, or perhaps CML. What does Container Lab offer compared to these tools? And I'll let you in a little secret. Container Lab did not do anything really groundbreaking here. Network virtualization has been a thing for a long time now, and these network labbing tools, they all sort of solve the same issue, but the Container Lab does it a bit differently than the others. So what do we use these virtual network labs for, really? You can learn a lot using these tools. You can also test a lot using these tools, and you can also simulate something that you would not be otherwise be able to simulate. So for example, you would be able to learn for your certification exams with a new network OS that you wouldn't otherwise have access to. You would be able to test a new protocol or even a new release of a vendor's network OS. And you would be able to simulate a network that you otherwise would not be able to. You don't have the capacity for it. And most importantly, all of these things can be done in a safe way, in a way that you can just reset back to the starting point without causing issues to your network or even having to reset any physical infrastructure back to a starting state. So what does Container Lab really do here for us when it comes to these three different main goals? Container Lab gives us a very simple framework for creating and managing container topologies. These are topologies of arbitrary number of containers and then arbitrary number of links between these containers. I know I'm starting to sound like graph theory here, but don't worry, I won't go into that part. And the thing is, Container Lab has multi-vendor support because by default, it's designed to be vendor neutral. And it also provides you with VM-based routers, more on that a bit later. And it gives you also additional tools that we will use during this little tutorial later today. For example, you are able to use scaled topology generation. You can just say, I want a spine leaf fabric that has 4 spines and 8 leaves, and it will generate it for you. So you don't have to do all the hard work yourself. And it also has a quite wide lab catalog, and you will see why it's so easy to share Container Labs in just a moment. And with this, Container Lab delivers a unique lab as code experience. And finally, the best part is that Container Lab really runs anywhere where Docker can be installed or any comparable container runtime. So when we look at how DevOps does tasks nowadays, when they spin up a new infrastructure, they don't do it manually. They don't go, okay, I create a virtual machine, I install PostgreSQL on top of that, I make sure that the SSH config is correct and do these steps one by one, and then repeat these every time that they want to actually create a database server, but rather they will use some form of infrastructure as code tool, which allows you to define infrastructure as a form of, say, a flat file or some form of flat representation of your infrastructure. And you give this to your tool, And that tool will do something to make that infrastructure appear out of nowhere. And these descriptions can either be imperative, so it's a list of steps, but nowadays the more preferred format is a descriptive or declarative form of infrastructure description. And in that case, what the infrastructure as code tool does is that it receives information of what should exist, not how it should be created. And the infrastructure as code tool will figure it out in the background how to get the infrastructure into the state that the description file describes it as. And Container Lab is a very similar approach. You give it a topology, a flat topology file, which describes the topology. It doesn't tell you how to create these Docker containers one by one, because Container Lab knows already how to do that. So you only need to describe your topology. You describe the nodes and the links in your topology, and Container Lab will create that virtual topology for you. And why is this great that we are using these flat description files? Because you can just edit the text file, and that's your entire lab. That's the state of your lab. That's the entire description of your lab. And the thing is, that means you can easily collaborate with others. You can easily make changes to this text file and keep track of the changes in this topology by just doing a git commit. So it's very easy to version control this type of infrastructure description or topology description. And finally, it's super easy to share. For it's just a git push on your side and a git pull on the other user's side to get that same lab. And Container Lab has been an open source tool that's been existing for 5 years. And it's not just a tool, really. It's an entire community. As you can see, the Container Lab community has over 140 open source contributors, and it supports over 35 network OSs, which wouldn't be possible without open source contributions. For we are just a small core team of developers. We wouldn't be able to possibly support all these network OSs ourselves. But thanks to the community, we can. And it's not just us at Nokia who use Container Lab, and not just our customers, but also many other vendors use it as part of their trainings and also their examples as well. We recently had a vendor come to us and tell us, hey, we're releasing a new containerized network OS, and we would like to have day zero support. So on the very same day of the release, we want this to be already in Container Lab. And we help them get that support in as fast as possible. So that was a very, very pleasant surprise for us that a vendor comes to us and we don't have to go to the vendor. And what is supported with Container Lab? So Container Lab, as its name suggests, it supports mainly containerized network OSs, but containerized network OSs, there are not that many out there, right? Nowadays, that's not really true anymore. As you can see, most of the big vendors have some form of containerized offering of their network OSs. The nice thing about these containerized network OSs is that they are much faster to spin up, and also they have a much smaller footprint because you're not running an entire virtual machine, but you're just running a few processes on top of a container, which is essentially a very lightweight way of separating different namespaces inside a Linux system. And they are also much easier to emulate on non-x86 systems. So for example, if you might have a MacBook that's nowadays you can only buy it as an ARM system, most network OSs you wouldn't be able to run on it because it's x86, right? But with containerized versions, it's just yet another x86 process to run on Rosetta, right? Same thing applies really for Linux, because on Linux there's also x86 to ARM translation layers, and the same sort of benefit applies there as well. And really, the current trend with that we see is that all the vendors are moving towards a containerized form of their network OSs. Of course, with containers, it's not just about network OSs, but also different forms of software. So, for example, any sort of server that you might run, Linux or server application, for example, Netbox, Grafana, Peering Manager, these exist already in containerized formats. So, including them in your topology is just a matter of putting yet another container in the topology. And this also means we can very easily use, for example, FRR, OpenBGP, or even BERT on these inside these topologies. And it's a very, very lightweight. You don't need to spin up an entire new Linux VM to host an FRR instance. And the really nice thing about this is that you can not only simulate your network, but really your entire network infrastructure, because your network infrastructure is not just about routers and switches, but all of the supporting infrastructure as well. All the network services, for example, DNS, DHCP, all your monitoring stacks, all your automation stacks, you would be able to put these directly into a container lab topology as well. And finally, I do have to acknowledge that VM-based network OSs are still here and they are going nowhere. So we had to come up with a solution to actually get these into Container Lab, right? And the thing is, with a VM-based network OS, all you really need to do is just spin up a VM and then do some plumbing with the interfaces. So that's what we do with a project called VRNet Lab. VRNet Lab allows you to essentially package up a virtual machine into a container. And also VRNet Lab will do also some initial setup steps for you. So for example, for network OSs where you might have to do a login through the serial console and apply some configuration before you're able to SSH in, VRNet Lab automatically does that for you in conjunction with Container Lab. So actually getting started with Container Lab, and this is not the workshop part yet, just wanted to make that clear. So the way to use Container Lab is really to install some form of containerization runtime. For example, Docker. You're going to have the best time with Docker, generally with Container Lab, and install Container Lab itself. Container Lab is written in Golang, and it comes shipped as a single binary, so you don't need to install any other additional libraries or anything like that. It's a statically compiled binary that you can run on. It's pre-portable, so you can even download it from GitHub if you want to. We have pre-built binaries. And that's really nice compared to, say, other network virtualization or network labbing tools where you are generally expected to install an entire VM image or an entire set of software suites in order to be able to run it. Then you get a lab file, a lab topology. The lab topologies are usually, you make it yourself, or you can even choose to look on any, say, Git-based website on the internet, like GitHub or GitLab, and look for a topology that you want to run. And then you can deploy the topology with a single command. I promise you that. It's a single command. Then you interact with your network. Your network will be up and running, and you can interact with the nodes in it. Finally, you either save your work or you can just destroy what you created, an entire container topology, yet again with a single command. And as you can see here, installing Container Lab is really just a matter of running a single command. I know curl pipe bash is frowned upon in some parts, but also this is your barrier of entry, a curl pipe bash. And that's all you need to do. And it will even pre-install Docker for you, the correct version of Docker, and also additional tools like Git. So you can really go from fresh install to Container Lab host within seconds. And you can not only run Container Lab on Linux, but also, of course, Windows and Mac OS based machines as well. The way that you would do this with Windows is using WSL2. So in the end, you're really using Linux because you don't really get containerization that easily on other OSs. And with Mac OS, you would need to use a VM tool like Colima or OrbStack to actually start a Linux VM for you. And then you need to get some container images to use in your topology. For example, with our SR Linux, which is our data center network operating system, it's a matter of just doing a Docker pull or letting Container Lab do the Docker pulling for you. With containerized software, generally, you would look in public container registries or your own private registries. With other containerized network OSs, generally the workflow is to get the container image from the vendor and then import it into Docker. And then finally, with VM-based network OSs, you would get the VM image, you would package it up with VRNetLab, and finally, you would be able to use that as a container image. And to actually get started with writing a topology, you just need to write a topology, really. What you see here is a very, very simple topology that runs a single node of FRR. As you can see in this topology, inside the nodes section, we have a router 1. That's the name of the node. The kind of the node here is Linux, which essentially means in Container Lab parlance like a generic container. The reason why you need to define a kind is because network OSs generally have these startup steps that you need to take before you're able to just connect to them and use them. So Container Lab has sort of these setup steps for all the network OSs that it supports. So for example, if you're running Junos, you would be probably writing here Juniper _ vJunos router, or if you're running SR Linux, you would be using kind Nokia _ SR Linux. And finally, we have the image that tells Container Lab what image to actually use for running this node. As you can see here, it's in the format of image name, image version. So you can even run multiple versions of the same image in the same topology. So if you want to test, for example, like a version migration, you would be able to do that with Container Lab. It's just a matter of specifying the two different versions in the topology. Now, a single node is not very, very exciting. You can do that yourself, probably. You can set up that single Docker container and it exists. It's nice, but you can't really do much with it. So this is, for example, a topology where we have two nodes, one called FRR and the other one called SRL. And these two nodes are connected through a link called, on the SR Linux side, it's Ethernet 1/1, and on the FRR side, it's ETH1. And the way that this endpoint is described is by creating a new section called links. And the endpoints part here is where you define each pair of endpoints in your network that you want to connect. Of course, if you wish to, you can connect the same node back to itself, but I figured that this would make for a better example. So this is not really the most minimal example. And the thing is, these endpoints that you see here, on the FRR side, you see ETH1, which is, you would expect that. ETH0, by the way, just as a pro tip, is generally the management interface for most Container Lab nodes, unless you use the specific network OS that has its own specific naming. In that case, you can use the network OS's own naming conventions inside Container Lab. So for example, this Ethernet 1/1 that I use here will get mapped internally to an interface alias that Linux can actually ingest, because, spoiler alert, one of the characters that you cannot use in Linux interface names, yet they are ubiquitous in network OSs, is the /. So we had to do some exciting fixes to get that working in the end. So, as I mentioned, deploying a container topology is a matter of running a single command, which is, surprise, surprise, container lab deploy, and you supply the topology file as an argument. Alternatively, if you only have a single topology file ending with .clab.yaml, then it will automatically find it and deploy that. And we see here in this output that we see the names of the nodes, the kind and the image used for each nodes, the state. It's always a good idea to pay attention to the state, that everything is in running state, because if something is in an exited state, that means something went wrong and that container could not be properly started. And finally, we have an IPv4 and 6 address that is auto-generated for management. You can also specify what subnets you want to assign these from, of course. And these are automatically assigned by Container Lab and set up inside the container as well. And to actually connect, you either do an SSH. Most network OSs support SSH-based connections, and some even support automatic importing of your public keys, so you don't even need to enter a password, you're already in. Or in case of, for example, FRR or other Linux containers, you would generally use Docker exec to get into the container and to run commands. For example, here we run btysh, which starts the FRR CLI. Now, I know that I'm talking about the CLI tool here, and some people prefer GUIs, and that's perfectly fine. So we came up with a GUI. Thanks to one of my very talented colleagues, Florian Schwartz, we are now able to run Container Lab with a GUI. This GUI exists as a Visual Studio Code extension, and it allows you to use the topology editor, a visual topology editor, and topology viewer, where you can see the status of the topology. For example, you see that up there on the image, that spider web of green lines, those are links, and the bluish nodes are the nodes. And it also allows you to manage your SSH sessions. So you can just say, I want to SSH to every single node, and it will give you tabs for each node that you can switch to and interact with each of these nodes. And it supports most features of Container Lab. So you can, for example, set up link impairments even in this GUI editor. And it has this support for software called EdgeShark. EdgeShark essentially allows you to do remote PCAP captures directly into Wireshark. So even if this entire topology is running in a different country, you can just right-click on a node and say capture, and it will spawn a Wireshark on your desktop. Alternatively, if you don't want to run Wireshark on your desktop, or you are in an environment where you're not able to run Wireshark, you can even ask this extension to run Wireshark in VNC on the host itself, and you will just get a VNC window as a tab inside Visual Studio Code. So this is a really, really cool solution. And another solution I wanted to present was made by Kian Gribi and Tom Stromer at the Ostschweizer Fachhochschule as part of their bachelor's thesis. They were successful and indeed became engineers, so congrats to them. And this is specifically designed for the management of university network labs with predefined roles for teacher and students who can create the topologies, and the students can clone these topologies. You have full node access via web-based terminals, so you don't even need to have SSH on your client. And you can preset up when each lab should be created for a class, for example, and when it should be deleted when the class ends. And of course, I also recognize that the CLI is not the best tool if you say want something for programmability. You don't want to be bit banging CLI commands. You want a proper programming interface to work with if you're working with Container Lab. So we came up with the API server, which gives you a REST API on top of Container Lab that allows you to create topologies, work with topologies, even does SSH proxying. So it's, if you ask it nicely, it will create a port where you can just connect to. It will proxy that connection directly to a node, and it allows you to expose the SSH ports of those nodes. It has RBAC based on Linux users built in, and it also allows you to essentially run labs in parallel with others without stepping on each other's toes. And you can even stream log files, which is really cool. And this is really, really cool if you want to use this in, for example, a CI/CD pipeline. So one example I came up here with when I was thinking about how this would work is a small CI/CD pipeline, where, for example, you create a pull request with a diff that creates a diff in your network configuration. That creates automatically a CI/CD pipeline and starts it, which would deploy this lab with the changed configuration. It would run tests against this lab, for example, reachability, making sure that a specific route is present on a specific router, making sure that LSPs are created and seen on the other side of the network, and so on. And then you can get essentially the actual diff from the network, like what it would actually look like when it was actually applied on a network OS. For example, if you duplicate the same configuration in network OS, that will result in no effective changes in reality. And this would allow you to filter that out. And you would also get the test results as well, of course. These test results would be checked by, for example, a senior engineer. And if everything is all right, every test passes, and the senior engineer gives a thumbs up, it automatically gets merged and deployed to the network. So just as an idea of what you can do with this Container Lab API server. Another really cool stuff I found on the internet was this tool called NRX. It's a community project by NetReplica, and it turns your netbox documented network into a runnable Container Lab topology, which is really cool, to be honest with you. And of course, sometimes the scale of a single host is not enough. You want to run a really big lab. And as we know, vertical scaling is much more expensive than horizontal scaling. So we thought, hey, there's Kubernetes. It allows you to run containers across a cluster of systems, right? So why not use that? So Kubernetes was born, and you can use Kubernetes to use the same topologies as you would run on Kubernetes, and these pods would get scheduled on different Kubernetes hosts. And the same way that you would have the Container Lab wire up the topology inside your host, the same way it gets wired up between these Kubernetes nodes as well. And of course, I cannot leave you without showing you a bit of exciting labs we put together for the community. For example, some EVPN, multi-vendor goodness, or a telemetry lab that uses streaming telemetry. But also, I want to highlight that it's not just us making these Container Lab topologies, but the community as well. For example, there's a full CCIE service provider lab that takes you through every single section of the CCIE SP exam, and touches on each of these sections with a different topology. And this is some really great learning resource. I mentioned NRX. There's also a very cool example topology for that. I think it even runs Netbox inside another container lab. I'm not sure about that. We have some cool labs from the SFlow people where you can try out SFlow-based real-time telemetry. And we have a open source routing interoperability lab with FR, BERT, and relatively new routing daemon, open source routing daemon called Holo. And I also think that some of you might have made your own container lab topologies as well. And if it's not a secret, then I encourage you to share it. It's really easy to share it on, for example, GitHub. It's a matter of git push. And if you add the CLab topo topic to your repo, then it's even easier to find for other community members. And really, it's a group effort to share the knowledge inside the community. And a really easy way to do that is just make a topology out of it, configure the thing you want to show off, and git push. In the future of Container Lab, I also wanted to touch on the development process a bit, because Container Lab is an ever-evolving open source community software. And really, we're open for contributions, and there's plenty of things that need to be done. For example, some things that I always wanted to add, but I didn't have enough time, for example, is topology and node reconciliation, which would enable you to add new links or even nodes or remove them on the fly in already deployed topologies. This is one of the small drawbacks of Container Lab, is if you change the topology, for example, you add a new node, you need to redeploy it. But generally, it should be as easy as doing a Container Lab redeploy in most cases without losing your progress. And now, I also wanted to mention that Container Lab, of course, runs with Docker, and a bunch of these network OSs, especially the containerized ones, they ask for a lot of privileges. So right now, everything runs as a privileged container. I already did some work on enabling sudo-less operations with Container Lab, but it would be nice to run containers as non-privileged unless they are absolutely needed to be privileged. For example, if the vendor doesn't support it any other way. Better multi-tenancy support would be nice to have to prevent multi-user systems accidentally, for example, deleting each other's topologies, because there are not enough safeguards against that right now. Of course, I acknowledge that Docker is one solution for container run, is one solution for making a container runtime, but there's also Podman. But Podman also has some minor feature parity issues with when it comes to Container Lab. So it would be nice if somebody could step up and maintain this. And of course, we have a nice documentation at containerlab.dev, and we have a very, very active community on Discord where you can connect with the developers and users alike, share something cool you made, or if you have any questions, then you can ask it here and get an answer within hours. It's really, really cool and super active community. So quick questions before we go into the workshop part. And also, please remember to use the mic setup and state your name and affiliations. If any questions, perhaps from the online audience? No? All right. Then we are going to get on with workshopping. So, can I see a show of hands? Who's going to need a virtual machine to participate in this interactive lab? Because there is an interactive lab part, if anyone wishes to participate. That's 1, 2, 3, 4. So my lovely assistant, Stefan sadly is currently unaffiliated. So if anyone knows any roles that might require a brilliant full stack software engineer, please let him or me know, because it would be nice to get him affiliated somewhere again. So those who have already gotten their papers, the virtual machines are not running yet, but they will be in a moment. I just need to get a good head count. Yes? Can we get... yeah, you're good.
Hello? Okay. Urban Sotolnik, also unaffiliated. I'm a bit too quick with this question, but are there any Linux distros where the bash script doesn't work?
Say again?
Is there any Linux distros where the bash doesn't work for the bash script? So Art also has it on AUR.
So great question. Thank you. I wanted to touch on this during the workshop. The thing is that we have a limited amount of distros that we support right now. I think the list is like anything Debian based, essentially APT based. We have support for DNF or RPM based distros. So that would be Fedora or Red Hat or CentOS or Rocky. And for those running NixOS, please build it from source, because right now there is no maintainer and the automatic update of the package stopped. I'm working on resolving that. All right, how many did you give away? Okay, but what's the next number?
They're not sorted, but
okay, then I'll just... All right. So, for those, let's just give it a moment so everyone has access to their virtual machines, and then we'll head on with the actual workshop. So, as I mentioned in the description, if you're using your own laptop, then please make sure that you're running Linux or you have a Linux VM with at least 2 gigabytes of RAM available. I would recommend an Ubuntu 24.04 because that's really the lowest barrier of entry. But if you have any other Linux distribution, that's all right too, as long as it's not too old. If you have at least Linux kernel 5.4 running, then you're good. Meanwhile, can I get a show of hands here? Who is already using Container Lab? All right, it's a nice number of hands. And who has already published a topology? Do we have any folks here who has already published their own topology on GitHub? All right. Hopefully, this presentation will get you motivated on actually, if you have the ability to, of course, publishing your topologies, because of course, it's always nice to share with others. So all 50 VMs are created. Let me just, yep. So the DNS entries were created just now.
Sorry, an interruption. Yeah, the issue is that the TTL of the SOA record is half an hour. So if the DNS names were created right now, we all have cached the negative answer, and it will take half an hour before we get the A records.
All right. You might want to clear your DNS caches.
Okay, maybe I can try to clear the resolver of this meeting. Hopefully it will not break the whole meeting.
Fingers crossed. Otherwise, maybe try to set up like your DNS server to be something other than the local one. All right, I'm actually starting to see some of the records pop up, but I might be, just using the non-local DNS. That's why. All right. Has anyone managed to successfully connect so far? Okay, I see one hand. Two hands. Very good. Also, if you would like to use the GUI of Container Lab, I would suggest you install Visual Studio Code on your own laptop. If you want to do some Wiresharking, then again, it would be nice to install it on your laptop, but nowadays you can just use the built-in Wireshark client with VNC.
Urban Svodolnik, is there a test topology that you would recommend so we can check if everything works?
Yes, I will be mentioning the test topology in just a moment. And this is the command that will all be running and installing Container Lab with. This also applies to the VMs because the VMs are freshly installed, so they will not have Container Lab running on it. You can find this command on containerlab.dev, and you can look in the quick start or quick install tab there. Is there anyone who is having issues connecting to the VM that was provided to them? One hand, okay. Maybe I'll just take a quick peek. Where was that? Oh, sorry. All right, you might have to set the DNS server on your connection to be public server. And I haven't provided you with credentials unless you have a paper. Yeah. Out of curiosity, does anyone have number 50 on their paper? ID number 50. All right, then I'll use that myself. All right. I'll give it a minute and then we'll continue on working. Has anyone managed to install Container Lab yet using this command over here? Right, I see some hands. Yeah. All right. So I hope everyone managed to sort out their connections to the virtual machines. And I encourage you all to, again, install Container Lab using this command over here, if you haven't already. And CLab version should give you a nice version output. Now, to actually test your container lab setup, I have put together a very quick topology. You can deploy this topology using the container lab deploy -t, and then you enter that little URL over there. It's a GitHub repository, and container lab supports actually just directly cloning from GitHub and other Git-based websites or Git hosting websites. So you can really just provide the URL. You don't even need to clone it beforehand. And this little hello world contains two small Linux images that are interconnected with a single link with /31 addressing on it. Rather, it's a /24. It's a point-to-point link. And once you're done deploying this topology, you should be able to do a ping using the docker exec command from host 1 to host 2. And it should ping. And let me see some hands if you managed to get the ping working. Okay. Great. So those who have already deployed this have probably, managed to. So who here has deployed their first container lab topology just now? Just out of curiosity. Okay. I see some hands over here. It's always very nice to see new users of the container lab. And that statistic I showed earlier about the number of downloads, you just helped us a bit. You bumped that number by 1. And once you're done testing the topology, you can use the clab destroy, container lab destroy command to actually get rid of the topology, to clean it up. And you just need to provide the same URL. What I wanted to mention, I didn't explicitly call this out, it was on the slide. If you already have Container Lab installed, please make sure that you're running the latest version, because we will be using a command later on that had a recent bug fix to it. You can easily upgrade Container Lab if you have an older installation of it by doing a clab or Container Lab version upgrade. This is a command, by the way. Quick check on who managed to deploy this hello world topology. Yeah. Okay, very good. Anyone still having some issues with connecting or installing Container Lab? Okay, then the next one. So we'll be working with this topology today. You don't have to type this out, don't worry, I'll give you a link to it. But just let's stop for a moment and quickly look at it. Oh, apologies. This is the hello world topology. So this is how it looks like in the inside. What we do is we create two nodes, and we use the IP address add command to actually create the IPs inside this hello world topology. And then finally, we connect the two ETH1 interfaces. The reason why you can have two ETH1 interfaces, because again, every single container has its own network namespace. So these two are separate, and each one has their own ETH1 from their own perspective. So these two do not collide. And as you can see in the image, I didn't specify a version. If there is no version specified, then latest is implied. This is like a Docker thing. And the exec command that we use here allows you to execute commands inside the container directly after a deployment. So before the control is given back to you by container lab deploy, but after the container has been created. And as a note, container lab generally does not provide any data plane configuration out of the box, and this is left to the user. Nowadays, this has changed a tiny bit in the last few weeks when the IPv4 and IPv6 parameters were introduced for certain network operating systems, but normally container lab does not intend to do any data plane configuration. It's just configuring the management plane for these topologies by default, and anything else is an extra you add yourself on top. And now, actual lab topology for today will be two FRR containers and two client containers. I picked FRR because I figured most folks would be most familiar with that CLI, but it's very quick to learn. And for those who are working with VMs, you will have an ID on the paper, which is the actual instance ID. For those who are not working with a container today, I will ask you to take a number from my lovely assistant Stefan's little cup over here. This will be your instance ID, and this instance ID will determine your IP prefix. So please put your hand up if you're working on your own laptop and you would like to participate in this exercise. Again, the number you get or your instance ID is going to be your seat number or your ID, and it will be substituted in wherever you see the letter X. And just as a preview of what you will be working with today, this is how this topology looks like in its container lab topology format. So you see here you have R1 and R2, which are both FRR containers. You have some binds in there. These binds let you actually mount files inside the container. Normally with network OSs, like ones that are provided by vendors, generally there's a proprietary way of supplying these configurations. So for that, we have come up with the startup configuration or startup config value. And you can provide a file to that or an actual text, and that will be loaded inside the container. However, since FRR is not really a network operating system, there is no support for providing it with startup configuration to a startup config variable, but rather we just bind the file, we just mount that file inside the container at the /etc/frr/frr.conf. And one thing I wanted to highlight here is that you see that colon colon RW at the end. That means it's a read-write mount. Normally, it's a read-only mount, so the container cannot change the file that has been mounted inside it. However, in this case, we deliberately mounted it with read-write. And these environment variables that you see inside here, they can be used inside topology and startup configuration files, so you can parameterize your topology. So for example, here, that's how we set the ID. In your own specific, the version that you will clone, this will be a bit different because I decided to take a different approach to ensure that there is no way for this to be, like stuck as 99, for example, if you don't set it. And now the actual workshop begins. In that we will start working with the workshop topology. So first you will have to clone this RIPE91 workshop repository from GitHub and enter the resulting directory. And before we do anything with this topology, we will have to prepare it so that the configurations and the topology itself will be using your ID, so your IP prefixes will be correct. And for that, you have to export the ID environment variable using the export ID equals and then the number of your instance, or the one that Stefan gave you earlier. And then you need to run the prepare.sh shell script. And following that, you can actually do the deployment using the container lab deploy command.
So it seems that Quay.io is giving bad gateway 502 HTTP error when pulling the FRR container.
Okay.
So
Parts of the internet infrastructure are
that's
failing
sort of
all
like
around
a
us.
live demo thing.
Yeah, sadly, I do not run Quay.io, and I think that this might be a problem for others as well. The which URL? For Quay.io? Idea. So for the later part of workshop, if you're participating from your own laptop, you will have to connect through the legacy network, which means no v6 translation. There will be a good reason for this. But maybe connect to that and see if that works. Yes, so we just discussed that. So can you try connecting to the legacy network? Oh, okay, then it's really for real down. Okay. Okay, well, let me see if I can find an alternate FRR image. Hang on. This is, I tested this yesterday. Crazy. Of course. getting their own status page says it's operational. Okay, what I will do, okay, I have a,
Sorry, can I make a suggestion to use RAR free router? That seems to be working.
which one?
The RAR free router,
The what?
the RAR RARE router.
Ah,
That image is also working, and it's probably similar enough to free range routing.
what I will do is I will let you download the image of the FRR. Yeah. Anyway. Okay. Okay. I will be editing this slide. Hang on. How can I do that? Hang on. Okay. So I am presenting yet again. So you see below task 0 that little wget and docker load. That will allow you to actually load this Cray.io image. And hopefully the Cray.io guys and the Red Hat guys will figure out what's causing this outage real soon. And if you load this image, this is sort of the output that you're supposed to see. Hang on. There we go. See. So you should see this sort of
So that FRRTGZ file is 403 forbidden.
okay, then I will fix that for you. Just a moment. Try now. Still. Oh. Forbidden. Okay, let me. Okay, I see the issue. Okay, now it should work. Okay, thank you very much for the heads up. All right, so it's quick aside. Hopefully, everything is sorted out now. Sorry, it only has like a gigabit uplink. Oh boy. Let me see if I can host it someplace faster. Actually, what I will do is I will go onto my own The issue is that we're using, like there's a lot of private in config that, yeah, I think it's specific to, some parts are specific to the FRR. All right, so faster place probably. Is anyone still downloading it? Hands, perhaps? Okay, there's one. So let me just, you can also do this. Second option at the top, SCP from the VMs and cloud egress fees be damned. but I guess those will be paid. So if you're still downloading it and you need a password, I will just go over there and give you one of these sheets so you can see what the password is.
Slides, you forgot to state the name of the container lab workshop to rename it.
Okay, so I'll keep an eye out for that. But you managed to spawn it. Okay, very good. Okay, so after you're done with the this, of course, make sure to run the prepare.sh and do the deploy. And as I mentioned, if you don't specify the topology to deploy, and there's only one clab.yaml file in there, then you'll be able to deploy it without providing it. All right, so hopefully data side is done. And just one thing, you should be able to do this ping, but this is going to be ripe lab instead of ripe workshop in the Docker exec. This was changed to make it a bit shorter. All right. We'll also jump on over to my instance and follow along. So. Again, I apologize for the little aside we had to do. I did not expect to be doing this on the floor here. Yeah. All right, so we have deployed our lab topology, and ripe lab. Yes, exactly. So that should be substituted. But you should be able to see the nodes' names in the output of the container lab deploy, and it's I figure it's easier to copy from there. All right, so we have deployed this, and just as a recap on how to connect with these different nodes. The FR nodes, you will be using the Docker exec, insert the node name there, vtysh command. You will also need to give it a -i and a -t to Docker exec to allocate you an interactive TTY. And to the other client nodes, you'll be able to connect both with Docker exec, or if you prefer, use SSH as well with admin at node name here, because Container Lab pre-populates both your hosts file and also your SSH config to allow you to easily connect to these nodes. And the password will be multi-tool, where the O's are replaced by zeros. And now we're going to start with workshop task number 1, which is going to be a very quick and dirty OSPF configuration. I hope everyone remembers how to do that. So we are going to be working on R1 and C1. R2 and C2 are already pre-configured, and our task is to configure R1 and C1. What we'll have to configure is some interface addressing, as you see here on the slides, ETH1 and ETH2. And You will also need to, of course, configure the loopback interface. And we need to configure OSPF. The router ID should be the loopback address. We are only using area 0 here, so no need to get fancy with this. And ETH2 and LO are passive interfaces, but if you prefer to, that's an optional task. And finally, we also need to configure C1. C1 is a regular Linux client, so we will need to use the IP tool to actually address those interfaces. To address the interface ETH1 and create a static route to 10/8 via R1, so 10.x.1.1. And if you ever get stuck with the task, you can look inside the directory. There will be a directory called .solved, and that will be split into 4 different tasks. And if you need to figure out if you want to figure out like how to solve the task without looking on the internet, you can also look in there to find the solution if you're stuck. And the way to verify your work would be to check the OSPF neighbors. You should be able to see R2 there. You should be able to also see the OSPF routes, the 10.x.2, which lives on the R2 router, should also be visible as propagated by OSPF. And pinging should work from C1 to C2 as soon as you set up the OSPF between R1 and R2, and also set up the interface addressing and the static route on C1. And this is meant to be sort of like an individual task, but if you need any help, I'm more than happy to come down there and help you. Just jumping back to the previous slide so you can see the tasks. Is anyone perhaps already done with this task? Or is anyone stuck with it, perhaps?
Try to escalate to this password doesn't work.
Let me see.
Did you try something else?
No, I tried that. It's multi-tool with 2 zeros.
Oh, it's an L.
Yeah, it's an L.
Sorry.
Yeah. And again, as a reminder, show IP OSPF neighbor and show IP route OSPF should give you some nice outputs if you're done with configuring OSPF with FRR. So I will also start solving this by myself over here. Let's see. You're able to see this, right? All right. So first we need to configure ETH1. So we enter configure terminal to get into the configuration, and we do interface ETH1. Here I will do IP address 10.50, so that's my X over here, dot 0.1/8, 0.128/31. I will go into ETH2. I will configure that with 10.50, so that's my X again, .1.1/24. And we're going to the loopback interface and configure IP address 10.50.0.1/32. Right, so that's the interface configuration. And now we need to configure OSPF. So, as I mentioned, the router ID should be the loopback address, so 10.50.0.1. And we will only have area 0, but we will be, I personally like to use the interface-based configuration for OSPF. So I will go back into ETH1. It's going to be IP OSPF area 0 and IP OSPF network point-to-point. This is not needed, it's just going to increase the convergence time. And as we mentioned, ETH2 I'm pressing the wrong button, should be passive, and it should be, again, area 0, and we repeat this with the loopback interface. And now if we do show IP OSPF neighbor, we will see the neighborship has been built between this and R2, which is 10.50.0.2. And if we do show IP route OSPF, you see this OSPF route being distributed here, this 10.50.2.0, which comes from here, which is from the client subnet of R2. And now the other task, which is to connect to the C1 router, and we'll be using the admin username, and we'll be using the multi-tool with zeros instead of O's to get in. And we just need to add the 10.x.1.2/24 onto the added ETH1 interface. We will do this with sudo. And we'll also add that route I was talking about, 10.000/8 via 10.50.1.1. And I again forgot to add. It's a bit difficult when I can only see the terminal over there from this angle. And now we should be able to, as I mentioned here, ping the other client. So drum roll, please. Oh, I can also look there. Perfect. And it works. So we got this out of the way. We can move on to task 2, which is going to be expanding the topology. For those who are still working on task 1, please take a look inside the solved folder for the solution for task 1. So we can use the write command to actually save our work to this mounted configuration. As I mentioned, we mounted it read-write, so we should be able to actually write to this on the disk of the host. And if we check it, the owner will be changed to root. So use the sudo cat command or sudo ch own it back to yourself. And you will see that it has changed. We need to go through these hoops because FRR is not really first party or first party citizen on the list of containerized network OSs in Container Lab yet. For other network OSs, the Container Lab has a built-in save command that will save the running configuration of the node to the host's disk. And as task 2, let's expand that topology. Once you're done with saving your work, we'll destroy the lab with clab destroy. We'll also make sure, once we are done with destroying this lab, that we not only save the work we've done on R1, but also the one on C1. As I mentioned, this is a regular Linux machine, so we'll have to add the exact commands required to set the interface address and the route. And you can just peek at the C2 configuration in the topology to figure out how to do that. And our next task is to add this new node, R3, which is also going to be running FRR. And its ETH1 is connecting to R1's ETH3. It's a bit hard to see on this screen, I know. So let me just increase that. All right. Hang on. Sorry. So now you can see at the bottom there that it's going to be between R3 ETH1 and R1 ETH3. Now, in the interest of time, I'm going to quickly show you how this is done here on this little terminal. So here we see the riplab.clab.yaml file. Going to enter that with my favorite editor, Nano. If you have a different favorite editor, you can also install it yourself. I picked Nano because why not? It's the easiest one to use for most people who are not versed with CLI editors. We can see here that we have this R1 and R3 parts. These are the routers. And we have C1 and C2 over here. So now, in order to get the client configuration, I'm just going to yank this exec part. Going to paste it under C1, and I'm going to change the link addressing, of course, to 1.2, and we'll be going through the gateway 1.1. Now, for R2, I'm going to take this entire block. I'm going to paste it again. So I have now two R2s. We'll just change this to R3. And we'll change the config over here from r2.conf to r3.conf. Now, this file does not exist on the disk yet, so that's the next thing we're going to fix. you can see here that we have in this config folder the FRR daemons file, which is shared between the two routers, and the vtysh.conf, which is shared as well. And each of them will have an individual configuration, R1 and R2.conf. So I'll just take R2.conf and copy it over to R3.conf. And I'm going to edit this because, of course, these in R3 are going to be completely different. So I'm just going to take this entire thing and just delete it. Right? So now we have a blank slate for R3. And of course, we need to connect R1 and R3 as well. That's the last part of this task. I'm going to go back into riplab.clab.yaml, go all the way to the bottom. This is where the endpoints, endpoint pairs are listed, which form the links inside the topology. So I know that I'm going to connect R3 ETH1 with R1 ETH3. Going to save this again. And in the end, if I do a CLab destroy now, it will tell me that R3 doesn't exist, so it's not going to be able to remove it, but that's, of course, the expected outcome. And I do a CLab deploy. It's going to be creating not 4, but 5 containers. One of them being the new R3 that we just added. And when you do a container lab deploy command, you'll be able to see this new R3 pop up. And now what I'm going to do is I'm going to actually configure the link addressing. It's very hard to see on this image, sadly. It's came out way too small, so I will add it once again to this as a additional little text box. All right. So R3 will be 10.something.0.131/31, and the other one, the R1 side on ETH3 will be 10.x.0.130/31. Now, because we are quite short on time, we are going to jump ahead. We are going to use a bit of a shortcut here in the solved directory. We're going to step directly into step 3. and I will do the ID equals 50 in my case, prepare.sh. So please do this going into .solved/step 3. But before you do that, please just destroy the lab as is. So clab destroy. ID equals 50, or your ID here, and prepare.sh. If you look inside riplab.clab.yaml, you will see that this is now parameterized properly with your ID in it. And is there anyone who received an ID that's over 100? You received an ID that's over 100. Yeah. So in your case, you will have to go into config r3.conf, and here you will see this router BGP, because we'll be playing around with BGP in a bit. This was designed for IDs 0 to 99, and you will see that it's going to be an issue that when you have more than 3 digits. So please do 65,000 plus your ID here for BGP. And for the neighbor, it's 65,100 plus your ID. And change that in r1.conf as well. Was that instruction clear? So the local one is 65,000 plus your ID. And for the neighbor, it's 65,100 plus the ID. So if it's 123, then it's going to be a 65,223. Yeah. All right. And please also change this in r1.conf as well. This goes to the gentleman over there, not a generic instruction. Now, if we start this in step 3, after we have parameterized it with the prepare.sh, if we do a vtysh, we will be able to see a running BGP neighborship. Between R3 and R1. Now, we have our little autonomous system over here, which is on R3. It's going to be 65,000 plus your ID. That's fun so far, right? Like you're playing around with BGP. It wouldn't be a RIPE workshop without BGP. So essentially, this is the topology over here that we have. You can see 65,000 plus ID and 65,100 plus ID. And if we verify the BGP neighbors, we see them. And if we check the BGP route table on R3, which we'll do right now over here, we'll be able to see 10.50/16 being advertised from the R1. And as a reminder, this was your IP prefix that was given to you. And why did I give you all separate IDs? Why am I making sure that nobody is doing overlapping subnets and you add your ID to the AS number? That is because in the next task, we're going to be spinning up an internet exchange of our own. R3 is going to be our IX router and needs a new interface to connect to this new virtual IX. And since we are going from step 3, you don't have to do the saving, but you will have to change after you destroy the topology, after taking a look at it. You'll have to add a new endpoint. And I will do that just now. I will go into this riplab.clab.yaml. And I will add a new endpoint to R3, which is going to be ETH2. And I'm going to add a new endpoint on the host. And this is a special keyword in Container Lab that tells it to create the endpoint straight on the Linux host. I'm going to call it R3-ext. This is going to be the external interface of this. If I do a CLAB deploy, if I do an IP link, I will be able to see this new interface created directly on the Container Lab host. And what we are going to do is we are going to connect to my little VXLAN hub, I like to call it, using the Container Lab tools VXLAN create command. It's a very long command, I know. Hopefully everyone will be able to see it even from the furthest row. And what we're going to do here is I will make this window scooch over. I'm going to type this command, CLAB tools VXLAN create. I'm going to specify the remote as this little IP address of a server I previously spun up. I will specify the VXLAN VNI, which is going to be 91.91.91. I will specify the link that this needs to be created on top of, which is going to be called R3-ext. And I will also specify the source port, which is going to be 14,789. For those versed in VXLAN, you might recognize that 4,789 is the VXLAN port. However, some cloud providers do block it from ingressing into their network. And I will also specify the destination port to be 14,789. And with that, I have created a VXLAN tunnel going from this R3-ext interface to this remote VTAP, which stands for VXLAN tunnel endpoint. This is going to serve as our IX fabric. Now, sadly, we don't have much time left, and I'm really, really sad about this because this is the coolest part of the workshop, I think. We are going to be running a BGP connect. We are going to connect to the route server running on the IX under 10.255.0.254. And it's going to be AS6500 that's there. And to number our interface, so R3's ETH2 interface, we'll be using again your ID, where the ID will be the last octet, and it will be 10.255.0.id/24. So I'm going to do just that. Okay. And now if we run a ping, I'm really hoping this works. 254. Okay, do. Please, please, please. Hang on. I need to. All right, might have to kick the route server. Yeah, this is the most dangerous part. Anyone else already connected to the IX, perhaps? Oh my God, he can ping me. Let me just kick the route server and see if we can get it working, okay? No, this desktop, please. Okay, hang on. Oh, I think I know what the issue might be. Okay. Okay. All right. We're kind of running out of time here, and I do apologize. So, but, All right. Oh, I think I see the issue. Yes, I see the issue. Yeah. Let me just fix that. My bad. Okay. Delete, destroy, and finally we can change the configuration to rs.conf. I'll cut off. Hang on. uh, yes, yes, yes. And there we go. Now in 2 minutes, and I promise it's going to be 2 minutes, we are even going to be setting up here some BGP. Step 4. We are going to be doing this. So conf t router BGP 65,050. No, BGP requires eBGP requires policy neighbor 10.255.0.254 remote AS 65,000 and no neighbor 10.255.0.254 enforce first AS because of course this is a route server. Show BGP summary and we have into conf t and ETH2 IP address 10.255.0.4 and please, it's idle. All right. I'm afraid this is all the time we have, but socket not connected. Huh. That's interesting. Should be fine though. But these VMs will be running for 1 more hour from now, and after that they will be terminated. So please save your work. And thank you again for being so patient. And thank you again for checking out this tutorial. I am sorry that in the end we weren't able to connect to the IX. There was a minor hiccup on Quay's side and also in the configuration side that I was using for the route server, but that kind of eluded my attention till the last moment. But I hope you enjoyed. I hope you learned a lot about Container Lab. And again, please do get in touch with us on the Discord and check out our documentation. And thank you again for your attention.
Hello, everyone. This is the RIPE 91 newcomers tutorial. Welcome, everyone. Oh my God, you're sitting all the way at the ends there. It's going to be difficult for me to address you all. It's a very awkward room. Don't be shy. You can also move to the middle. So I think we have to start because we have quite a packed agenda. We have a number of speakers lined up and hopefully give you a good impression of what to expect from a RIPE meeting and make it a bit less kind of, secretive. Well, again, this is your first RIPE meeting. This is RIPE 91. The first one was in Amsterdam. We started in Amsterdam many, many years ago. All the RIPE meetings are actually recorded, or there's information about all of the meetings online, so you can go back and find some interesting history there. And of course, all the more recent RIPE meetings are also recorded, and all the presentations are archived and so forth. So you can dive in there. I'm going to introduce myself in a second. I just want to set the stage here because I'm the chair of the RIPE community. And for those of you who are not familiar with this concept, we actually have a formal RIPE chair team. So it's the RIPE chair and the vice chair. They are selected by a nominating committee who select the RIPE chair and the vice chair based on community feedback. And the main task of the RIPE chair and the vice chair is to ensure that the RIPE community functions well. That's pretty much all it says in that RIPE document that defines the role of the RIPE chair. It then goes into some examples, this could mean this and this and that and the other. But overall, that's my task, to be here to make sure you all feel welcome, you feel included, you feel comfortable, this is useful for you, and to make sure everything works well, all the processes are documented and understandable and so forth. And so, yes, I'm Miriam Kühne. I am the RIPE chair. I've just been reselected for another 5-year term by the NOMCOM earlier this year. I'm originally from Berlin, from Germany. I studied computer science in Berlin many, many moons ago. And then I worked a little bit at the RIPE NCC, and then I worked also for the Internet Society, did some more projects at the RIPE NCC until then I was also very much supporting the previous RIPE chair, so I kind of got an idea how this all puts together and how this works. And so then I was selected RIPE chair in 2020 for the first time, and now I do a second term. Thank you. Thank you. Well, thank you all for putting the trust in me. I'm really, really honored to do this. I love this job, but I love working with you all here. Then we also had Neil O'Reilly, who's here, who is the vice chair who was selected 5 years ago for a 5-year term, and this is going to be his last week. So just a few words about Neil. I mean, he's been in RIPE, as you can see, for even longer than I have, and he used to work at the university in Dublin. He also chaired a working group in RIPE, which is closed, or is it dormant or inactive, I think it's called, for a while. And I don't know if you want to say a few words about yourself. You wanted to promote some of the socials, I think. I don't know if there's a microphone. There's a microphone. Use the microphone. Use the microphone.
Sorry. And I'm supposed to say my name, and this is something everybody's supposed to do during the week. So do remember, if you come to the mic, I'm Neil O'Reilly. I'm the RIPE vice chair for the time being until my successor takes over during the meeting. And the one thing I always plug at the newcomers event is that if any of the newcomers are interested in rock climbing, we try to make an excursion to a climbing gym, usually on the Wednesday. So talk to me about it. We have a mailing list to keep in touch between RIPE meetings. Otherwise, you know what the working groups are, you know what you're interested in. If you're confused, find me or Miriam or the meet and greet people. There are lots of people to support you during the week. It's not just all over after the newcomers session and the newcomers lunch.
Thanks, Neil. And then we'll also have Anna Wilson here, who is who's been selected by the recent NOMCOM chair as the next vice chair. kind of taking things over from Neil during the week. So we'll have kind of an extended VIBE chair team here this week, which is great, I feel very, very supported. And I'm sure, you will have a, a good VIBE chair team, solid VIBE chair team here during the week. Anna has also been a long-term VIBE participant and has been chairing a couple of working groups. Actually, I had to look that up. I didn't remember the Net News working group that we have back in the day. It doesn't exist anymore. But you've also co-chaired the IPv6 working group for some time after that, I heard. And in her day job, Anna is working at HEN at the NREN, the National Research and Education Network in Ireland. And the official handover we'll do kind of during the week. And just great to have you both here. I don't know if you want to add anything. No, good. Right, now let's get started. This is just a bit of a blast from the past. I mean, I'm not going to talk about this box on the left. Actually, I never really had one of those. I was more like an Atari person, but you did, okay. But more interesting, I always find the map on the right, which is, you don't have to read all the labels, but this was basically the internet in Europe in, what does it say, on 1980s, something, I can't remember, I can't read this, but 1990, thank you. Okay, this was actually also produced by a VIBE working group at the time. There was a connectivity working group, I think it was called, and they would produce those maps and would find out, what new network has been connected to the internet, to the whole infrastructure in Europe. If you dive into this, I mean, they're mostly academic networks, and that's really also how it started. This was kind of born out of mostly NVENs and academic networks. They all connected, and they started using TCP/IP, and then also many of them were the founders of the VIBE community. And at some point, the map grew a little bit too big, so the working group, it was not scalable anymore to continue publishing those, and then the working group also closed. But they're all published. I believe they even published as VIBE documents. So if you want to go back, you can find the history there. I should have asked you at the beginning if you're connected to Meet Echo, and also, of course, those of you who are online, you are connected to Meet Echo, because we'll have a question for you, or a poll. You can use a poll, the poll function in your Meet Echo app. You got a link to the Meet Echo. This is a good exercise for you newcomers here to use the Meet Echo application that you got a link this morning, I believe, or yesterday, this morning, I think. You have an individual link to the Meet Echo application that we use here for remote participation, and there you can chat with people there. You can find the agenda. You can participate. You can ask questions. Of course, we like you to ask questions here in the room if you're in the room, but if you're remote, obviously that you can also participate through the tool. So I want to ask you, and there's a poll, and somebody is going to run it for me. Do I have to click the button, or are you going to do it, Xavier? Click one more. Okay. That's it. Do you know the difference between VIBE and the VIBE NCC? And you can also raise your hand if you're here in the room. Yes, some do, but you're not exactly newcomers. But yeah, there's a few more hands, not that many. I don't know how it is online. If you want to show the results, I have to click one more, or... Okay, okay, more people knew the difference than not. All right, anyway, I'll see. You can test, your knowledge, see if you actually, know the difference between VIBE and the VIBE NCC. I just want to make this point here at the beginning of the meeting also, and we're going to have a presenter from the VIBE NCC later on, going more into detail of the VIBE NCC. But just in a nutshell, the VIBE community, as I said earlier, was mostly founded by academic networks at the time in the early 90s. Actually, in 1989, the first VIBE participants came together and founded this community to coordinate certain technical aspects of the network, how to find each other, how to communicate with each other, who's using what IP address, how do we, what needs to be registered in the database, and things like that. It's been always open. VIBE has never been a legal entity. It's always an open community. Anybody can participate who's interested in running IP networks, it's still pretty much the same. It's for information exchange, best current practices, technical coordination, and also one aspect is the policy development. basically developing policies on how to distribute IP addresses, what's registered in the database, what kind of contact information do we need to have, things like that, which then gets to, we hand over to the RIPE NCC to implement. So at the other hand, we have the RIPE NCC, which actually started as the secretariat for the RIPE community. So RIPE was first, as you see, in 1989, and then all the work was done by volunteers. So there were all people like, okay, I'll run the instance of the database in my server. I'll maintain the working groups and the mailing lists. I'll organize the meeting here in our university. And so after a while, they felt like, this is getting a little, too much work for an engineer. And so they set up the secretariat and the RIPE NCC, the Network Coordination Center. RIPE, by the way, stands for Réseau IP Européen, European IP Network. And so the RIPE NCC, as a secretariat of RIPE, was founded in 1992, and then they took over the kind of coordination and administrative, the logistics, basically, for the RIPE community. And then only later on, because the RIPE NCC already existed, it also took on the role of the IP registry, the regional IP registry here in the service region, because the community and the membership of the NCC already trusted this organization, and they trusted them to also take on that important task. So the RIPE NCC is a legal entity, it's a membership association. The members elect the board, and there's staff, and there's a CEO, managing director, and the RIPE NCC provides services to the members, but also to the larger community. And yes, there's a link, there's a lot of, and we'll hear more about this, there is an important link there between the policy development and the policy implementation the RIPE NCC does. So coming back to the RIPE community here, we have a bunch of working groups that you'll see later during the week. This is the list of working groups right now. I'm not going to go through them all. Some are more obvious, related to this technical coordination that I mentioned earlier. Others are, a bit different, like IoT, or maybe cooperation is an interesting case where we have the technical community and the like regulatory and government, representatives come together and talk about their topics. So you'll see more of those working groups later during the week. And every working group has a mailing list, and so you can subscribe to the mailing list. It's used mostly for announcements, or also discussions of certain topics. And then the main list here actually is the RIPE list. Well, not the main. We have also a list for the entire community, the RIPE list, and then you see information there about generic kind of information relevant for the entire community, not specific to one working group. And yeah, just as a starter here, and then let's dive a little bit more into this specific meeting. You can see on the website, or also in your Meet Echo, to try to pronounce this properly in the proper Italian way. It is hard. The meeting plan here, you can see that, and it's interactive, so you can click on the sessions and you'll see the agendas of each of the sessions. So there's a lot going on every day. I'm not going to go through everything, just to maybe highlight a few things here today. There is a birds of a feather meeting, and what does that mean? It's basically a more informal session. It's not attached to any of the working groups. It's actually something the program committee reviews and agrees on to have that on the program. And in this case, we have 3 birds of a feather session. There's like usually one-off kind of topical discussions that's open to anybody. Today is one on a discussion on the second draft of an RIR governance document. So it's a bit meta, but it's important. It's important for this community also to make sure our regional internet registry and the entire RIR system is stable, and also stable and future-proof. So that's happening today. And there are, I thought I had a slide for the other BOFs as well. I'll be going chronologically. I'm sorry. Tomorrow is no BOF, but there is a diversity in tech session, or DEI session, in the afternoon, which I'm really looking forward to. We have some interesting topics there. It's different every time, and it highlights various aspects of diversity and inclusion that's relevant also for our community here. Then on Thursday, Wednesday, we also have sessions. You can find that. I mean, they're kind of regular plenary and working group sessions. And on Thursday, we have another two BOFs. They're also relevant. One very technical and one more strategic. One is organized by the RIPE NCC to talk about the next 5-year strategy, and one is about kind of encryption in the DNS. So very different topics. Here's some tips on how to participate during the week. As I said earlier, you can use the Meetecho app for that. There's also, you can find the attendees list. There's a chat. You can use the Q&A facility, or you can come to the microphone. And as Neil pointed out, we'd like to hear who you are when you come to the microphone. So, we get to know each other a bit better. Yeah, this is something we promoted a few meetings ago. This time we only have one, but we have local hubs. I'm not sure they're already online. They're usually they're only like a few days during the week, but it's basically people getting together in their local country or city or university and kind of participate in the RIPE meeting together rather than everybody individually at home. So we like that and we promote that. Well, you already have figured out why you're here and why you want to participate, but just to summarize this, I mean, it's a great way for you, I think, to engage with this community and kind of shape the future, if you will, of the internet infrastructure of the internet in this region. Find peers, build your career, and basically, yeah, be part of this. This community with it's quite diverse actually. It's not only technical, it's also other topics, and we need all of you to participate there. Quick overview: the program committee, lots of faces there. You'll see more faces during the week. Just to give you an idea, these are the people who are responsible for the program for the plenary slots, and there are some elections going on this week, so we're still looking for candidates at 2 slots, I believe. And you can also, the program committee and also the working group chairs, they'd like you to rate the talks so that they get some feedback and what you like, what they could do better in the future. So you can rate you can see that also on the website and in the app, every talk you can rate. And then where it says network here, it means actually like social network more, again, how you participate and how you feel more included in this community. I already mentioned this, the Meetecho app and the attendees list. Just for completeness here, it's another link, you can find it there. And of course, we have social events. So they are, unfortunately, here on site, so not for you online. We experimented with online social events during the COVID period, but it just wasn't the same. So we kind of, for those who are here, and they have the advantage of also participating in these social events. There's a welcome reception today. There's another kind of networking event tomorrow evening, and then the traditional RIPE dinner on Thursday. Yeah, almost coming to the end of my part. So we want to hear from you, share your experience with us. There are some ways where you can do that. And then I have a few tips for you if you need support. There's a tech team here, also the technical staff, some of them sitting there, but they also have a desk where you can find them, and there's you can reach them under this email address. There are 2 email addresses, but it's probably easier to just find people there at the registration desk. They can point you in the right direction. But you can, of course, always send email as well. And of course, the best place to go for questions is the meet and greet team. I don't know if you have any red t-shirts here in the room right now. I don't see any. Yeah, I know. Salome has 2 hats on. She's also on the meet and greet team. She works at the RIPE NCC, and she's actually there on the right-hand side. So they're hard to miss. They are at the very prominent place there. And I think that's when I'm handing it over to Sebastian, and they're all hovering around there, which is basically the Code of Conduct team. And Sebastian is going to introduce the Code of Conduct team from the Code of Conduct team, so I don't have to do that. Thank you.
Okay, yeah, there's a Code of Conduct. You basically saw that maybe in the registration process. That's very important for us because you should have a really great experience here, a positive one. So it should be a respectful get together. No one should be harmed or in any way intimidated. It's about tolerance and respect. And this is be excellent to each other. That's very important. And also you as a newcomer, you can come to us if you have anything to report. That's very important, or because you are new, you're not allowed to come to us, because that was one of the last times feedback we got. People thought, I'm the first time here, can I complain? You can. If you have a bad experience, you can come to us. We hopefully can solve it for you, or at least mediate and make the experience you have here a great one. This is a code of conduct team. Please, the other guys in the team that are on site, please stand up for a short time. You see 3 others, me. You will see some others on site. Not everyone is here, but also on the online part, you can come to us. You can either go to individual persons, or you have that mailing address where you address all of us. Please use it if it's necessary. Lastly, there's a survey also about the experience you have, also with the code of conduct. If you have something, please do it after the meeting. Obviously, you need to have the experience of the meeting to do the survey. And that's basically it from my side. So please be excellent to each other. Have a great time.
Thank you very much. And yes, next up, I was going to introduce you, but you're already on the slide, is Angela Dallara, the policy officer of the RIPE NCC, who's going to tell you a bit more how to participate in this policy development process that I mentioned earlier.
Good morning, everybody. Of course, welcome to the newcomers. And yeah, I'm a policy officer. So you heard the community makes the policies, RIPE NCC implements them. And in between, there is a whole process to, let's say, make a proposal, discuss it, eventually change it, accept it, withdraw it, what can be done. This is a bit your task now, if you're new to the community. During this meeting, you will have the opportunity to hear the discussion about 3 new policy proposals that are in discussion in the Address Policy Working Group. For the old comers also, this time is going to be on Thursday instead of Wednesday. Traditionally, it was always on Wednesday, so old comers don't make mistakes and come on Thursday. My role is to, let's say, assist with the whole process, to keep the timeline, to communicate to the community what has been decided, when there is a new proposal, when a proposal changes phase in the policy development process. But especially for now, for this week, I'm here for you to answer your questions. And if you want to know more about the policies, what are they regarding, what are they going to change, how is the current policy, and which are the changes that are proposed, I'm here for you. You will see also me with the red jacket in the meet and greet booth. And I would like to really encourage you to make questions, because through questions also the proposers can understand if their proposal is not clear, if there is something that has to be explained in a different way or more deeply. And don't be afraid, don't be shy, because everybody started in this community and everybody was a bit afraid to go into a club that was already formed by people with more experience. But you can always bring something new, a new point of view, because times are changing. You know, the policies that were applicable years ago might be not applicable to the new technologies, to new implementations that are needed nowadays. So that's why all new policies or the modification of an existing one is proposed. So my invitation for you is be part of this process, because you decide what the RIPE NCC has to do. Then how RIPE NCC is going to do it is going to be related to the means and the possibilities that RIPE NCC has internally to apply systems, to use staff, and so on. But the needs, how can I say, the new policies are coming from network operators. So I wish you to have a nice experience here, and welcome to the policy development process, and come to me if you want any information.
Thank you, Angela. And then next, and I think last speaker, you have plenty of time, is Hans-Peter Holland, the Managing Director of the RIPE NCC, who will dive into a bit more into the other side of that slide, the RIPE NCC and the Secretariat for the Community, and what their role is here in this meeting.
Thank you, Miriam. So I realized that 10 years ago, there was a RIPE meeting here as well, and then I was standing here as RIPE chair. So since then, 5 years ago, I became the managing director or CEO of the RIPE NCC. And yeah, we're here to help the community make this meeting and the interaction in the community the greatest experience ever. So Miriam already told you about the RIPE community. There were like 16, 17 people meeting in '89 to solve all issues of internet in Europe. And we're still meeting. So after a while, they figured out we need a secretariat, somebody to make lunch and make sure there is a room and so on. My first couple of RIPE meetings was in the NICF building, and we never knew whether there would be lunch in the cantina or what we would do. It was quite different level of what we were doing today. As for taking part in the community, I was put immediately into action and volunteered as a scribe of the database working group at my first very meeting. We didn't really have staff taking the minutes and stuff back then. So, you know, just raising your hand in the wrong point in time, you know, you may end up actually doing some really interesting works over the years. RIPE NCC is a membership organization, more than 20,000 members across Europe, Middle East, and Central Asia. So like 72, 74 countries. But we also have members outside the service region. It's as any membership organization, there is a board elected by the members, and they hire a managing director to run the organization. And I'm in charge of like 190 staff who actually does the work. And we provide services not only to the members, but also to the community as large, and we're the secretariat of the community. And since Angela already told you about the policies, well, we implement the policies that you guys are forming. So we have a strategy, a 5-year strategy that comes to the end next year, and we're currently working on the next year's strategy. So there's going to be a BOF on that on Thursday. So if you're interested in looking at what should the RIPE NCC look like in 2031, please come there. We were set up by the community, for the community, as I said, and then a bit later, the community decided that wouldn't it be great to have an IP address registry in Europe? We didn't have the concept of regional internet address registries then. It was IANA and it was Internic handling IP addresses in the US and for the world, because the internet or ARPANET grew out of the US. Great to have it in Europe, same time zone, easier to deal with, so the registry was set up. But then when the organization was formed, the founders figured out that in order to attract good people and have you know, a center of knowledge other than just keeping a book of numbers, there were other activities written into the bylaw. So from the very beginning, it's been clear that the RIPE NCC should also do other activities. I already mentioned Secretariat for the community, but also research, measurement projects, and so on. And in order to do all this, we do this so that you as our members, as you as community engineers working in internet providers or other companies that rely on internet services, we give you tools to make sure that you can operate a secure and stable internet. And for us to do this, we need a stable organization. We have a board overseeing me and my work. We need proper funding, so we have a charging scheme that will be in depth discussed together with the strategy in May, but we're looking at that now as a result of the charging scheme task force that has put some work into establishing principles for that. And none of this is possible without engaged and competent staff. And we have quite a diverse staff. It used to be 42 nationalities. 42 is one of my favorite numbers, of course. But now we're up to, I think, 46. So it's, it's a very interesting organization to work in. It should be easy to connect from all over our service region. The registry, we maintain the RIPE database. All of our information, or almost all of our information, is publicly available to network engineers, law enforcement agencies, copyright holders, end users that want to know who is using or who has the registered right to this IP address. And you can register other information in that database as well, like routing policies. And there is even an object for poems, so you may find limericks or haikus in there as well. So not everything is deadly serious here. There are also humorous sides of what's happening. Investigation into hijacks and policy violations, that's part of our mandate. Support and facilitate the policy development process, as you've already heard. And we're working on a system called RPKI, and I'll come back to that later, that allows you to secure the routing system. Other services, information services, we have measurement services, we have RIPE-STAT, which is a looking glass into the data collected by not only Atlas, RIS, we have an IP map to look into that, and you will hear in a couple of presentations that we've now released a couple of new tools that visualize the data that's available here. We operate one of the root name servers, the so-called K-roots, and for those who wonder why K, you can look up the founder of the RIPE NCC, Daniel Karenberg, and then you can guess why it's a K. And then we also operate the reverse zones for the internet, and that's something that not many people know about, but if you have a domain name and want to connect to the server, you look it up in the DNS and you get the IP address. But you can also put in the IP address, and then there is a reverse lookup where you as operators actually need to maintain that lookup, and we delegate that access to you. So while we're saying we only do numbers and not names, that's not entirely true. We do some name stuff as well. RIPE database provides accurate registration information of internet number resources, publishing routing policies by network operators, facilitates coordination between network operators, provisions of reverse domain name systems and enum delegations. Anyone here knows what enum is? 2, 3, yeah, oh no, the people woke up, yeah. We were actually quite wondering now, is that still in use? So if somebody wants to research project, that could be an interesting one. For those who don't know, it's a way of registering where to go from a telephony number service to a SIP gateway into that system. So you could route around the big telcos that would want money for your voice calls. But I guess nobody uses voice telephony anymore. It's now all different kind of apps, right? And we do research, and you can see quite some presentations along research, either from my colleagues doing that or from researchers from other places using the data that we make freely available. We have an LIR portal that you can use as a member, as a local internet registry, to log in to manage your registry data and make queries to our registrations department and so on. You can make requests for numbers. You can have AS numbers, which is the number that identifies your network or your autonomous system that has this distinct routing policy. IPv6 numbers, we have plenty of them, or you can get on a waiting list to maybe sometimes in the future get a tiny bit of IPv4 space. Open tickets, view billing and membership information, and secure your routing with RPKI. So RPKI, I mentioned that a couple of times. If you know your basic BGP, it's basically that your router announces to its neighbors, please send traffic to these addresses to my AS number, to my router. Now, there is very little security involved in that. Therefore, RPKI was put in place so that you can digitally sign a statement saying that this AS number is authorized to receive traffic for these IP addresses. So you have a possibility to make that statement with a digital signature to the rest of the world. No, that isn't enough, because we have 5 regional internet registries, and can we actually sign everything? Well, because of transfers, we all have the ability to sign everything. So now we're working on a system where we would digitally sign the transfers between ourselves and have an authoritative source where you can verify that this signature actually comes from the right RIR. So that's another level of complication on top of this. And then there is also an AS security on AS numbers that is work in progress now, and that RIPE NCC is about to implement together with other RIRs, where you can sign that a statement saying that, yeah, but I'm only interconnecting with these AS numbers, so if anybody else announces my AS numbers through them, that's not the path you should listen to. So there is more and more security added here, and it's really, if you're into cryptography and stuff like that, it's fun to listen to some of those presentations. Community and engagement. All of this is, for you, by you. So we organize RIPE meetings like this twice a year, so you can meet and interact. We offer training courses, e-learning, and professional certifications. So you not only take a course, but you actually get a certificate that you passed an exam. You can take those exams here if you want to. We contribute to public policy and internet governance discussions in other places. We take part in ICANN meetings, we take part in various ITU meetings, and we know even this year engaged with the Internet Governance Forum and in the US VISIS, because the governments are discussing how shall we govern internet in the future. So we try to be present there in order to make sure that we tell all the governments that we have a very well-functioning system, bottom-up, fully open for anybody to participate, and that's what we're doing here. We publish articles on RIPE Labs, so if you have some interesting stuff to share, you can publish that on RIPE Labs. And we run the RIPE Fellowship Program and RACI Program, and we just have revamped the Fellowship Program now, so that's a new one that is not just about the meeting, but also try to get you to stay in the community and be here in the future. So I'm really curious to see how that works out. Executive team, you see a picture of my teams here. 2 of my managers are unfortunately not here this time. Gabor is watching from remote, and Felipe, my CTO, is unfortunately sick this week. But we have a lot of their managers around here, so if you want to talk to somebody from the registry, all of the other registry managers are here, and a lot of the colleagues from technology also. The executive board is also here. Do we have any executive board members in the room? No. So yes, Randy is here, and Sander. Excellent. So if you have questions or things that you want to discuss about what the RIPE NCC should look like in the future, or about how I run the organization, you can go to this gentleman and discuss that with them. And in May there is also elections for board members, because they have 3-year terms, and you can then, with some experience, put yourself forward to actually govern this organization. There is a support help desk, so if all of this went over your head and you have questions, go and talk to my colleagues at the support help desk. There is a general meeting, so if you're a member and wants to participate in that, you can make sure that you register properly for that, because it requires a separate registration, and it's on Wednesday afternoon. There is an open part of that in the beginning in the services working group, where we will present our activity plan and budget for next year, and we will discuss the use of potential use of artificial intelligence in the future, which is something that we haven't really made firm plans about yet, but we really want to hear from you guys what you think we should do there. It's not often that we sit down and very openly discuss, hey, what do you think we should do? So this is a really interesting first trial that we do that. There is a user research hub here. We have Pedro, who is a UX designer, mainly working on our training courses, and we have Antonella, who is working into quite some interesting things now on assisted registry checks, the LIR portal, and AS PA systems and so on. And they're here with two people from the development department, Fallon and Adonis, and have some user testing so you can sit down with them and look at, what should this self-service interface look like in the future. Keep in touch. You can follow the mailing list. We have an online forum where you can discuss, and we're happy to answer any questions. There is a newcomers lunch today, I believe. So you can join together there. There are tables there with my first RIPE meetings. And then I made this extra long since you said that I had a lot of time this time, but then I'm done.
Thank you. Yeah, before you go to lunch, actually it's not even time for lunch yet, so we'll still have to entertain you for a little while. I want to ask you, are there any questions? And this was a lot of information on your first RIPE meeting day. Please feel free to ask any questions now. Are there any online? No, don't see any. Well, in that case, we have questions for you. We have a little quiz. And it's usually fun. So there's probably a voice coming from the off right now. Is he ready?
I'm ready.
There you go. Take it away.
Let me share my screen first. And then we'll get this running. Okay, do you see the screen?
No. Yes. Now it's coming.
Yeah. Okay. So let's get this party started.
Ladies and gentlemen, step right up. It's time for the RIPE Meeting Newcomers Quiz. Get your thinking caps on, don't be shy. Join the quiz now, let your knowledge fly. Questions ring and laughter will ensue. Newcomers, test your wits, made for you. Join the fun, let's test your wits. Come on down, it's time for quiz hits.
Yeah, that's how far I got the AI to do anything. Welcome, everybody. Welcome to our RIPE 91 Kahoot quiz. My name is Gerardo Vivier, and I am your quiz master. Broadcasting from the heart of the community, buzzing, constructive hive activity where policies forged, standards are shared, and the only thing more complex with BGP is finding the correct power adapter. The high activity level is confirmed by several minor routing anomalies. Specifically, a set of legacy IPv4 prefixes have spontaneously decided to deaggregate and are now loudly demanding an immediate buyout and a life and leisure in a remote AS. So this quiz is your chance to prove that you've been paying attention. The winners will achieve eternal fame, well, at least until the next quiz. And your nickname will echo through the halls of RIPE 91, whispered with awe and admiration. So the topic of the quiz is, of course, RIPE, what you may or may not know. Now, let me explain how to play this game. No. So I'm going to show a couple of questions, and you're going to have 4 answers. The person to answer the correct answer fastest gets the most points. The rest to answer it correctly will get a bit less. And you have about 12 questions to answer. So I see there's about 65 people already signed up. I'm going to let you sign up a bit more. And then I'll start counting down in about 3, 2, 1. Let's go. So you're going to see the questions popping up. And then you're going to have just a few seconds to answer. So be quick. First question is, who is the RIPE chair? Oh, yeah! So is it Miriam Kuhne? Is it Niall O'Reilly? Is it the RIPE chair team? Or is it Hans-Peter Holland?
Wait. Gerardo.
Yep.
We don't see the screen.
No?
It says click to full screen. Click to exit full screen.
Yeah, that same thing. Let's see, exit to full screen. How's that?
Yes, that's better.
Okay, I'm not changing anything. Okay, you all know the RIPE chair is Miriam Kuhne. And the next question, Scoreboard is AWS outage at the top, Yuri, Trix, IPv5, and Fufu. Question number 2. What does the RIPE PC do?
Are you crazy?
No, I'm not crazy. Do they select the working group chairs? Do they ensure that there are parties and celebrations at each RIPE meeting? Do they choose the presentations for the RIPE meeting plenary sessions, or do they choose the presentations for the working group sessions? 4 of these 4 answers. Which one is the right one? Selecting no. The right answer is, of course, choose the presentation for the RIPE meeting plenary sessions. They do a great job of going through all the presentations and choosing the best ones for you. The scoreboard says IDBS is out of the leaderboard. IPv5 at the top. Andreas, Trix, Danko, and Lala. Next question. Who makes RIPE policies? Is it the IETF? Is it the RIPE NCC? Is it RIPE? Or the question nobody wants to hear? Why should I care? Is it ITF, RIPE NCC, RIPE? Or why should you care? Yeah, and that is the sound you'll hear if you press that button. And I think somebody just pressed it blindly. RIPE, of course, makes the RIPE policies. RIPE NCC does something else. So, scoreboard says IPv5 at the top, Andreas, Trix, Joske, and Lala. Or is it iOS XE? Well, I don't know. Next question. Who implements RIPE policies? Is it the RIPE NCC? Is it RIPE? Is it the RIPE chair? Or is it everybody? So, who implements the RIPE policies? If RIPE makes the policies, who implements them? That is so easy to answer. Is it RIPE NCC, everybody, or the RIPE chair? And of course, it is the RIPE NCC. It's the task of the RIPE NCC to put into motion what RIPE decides. Scoreboard is IPv5, Trix, Andreas, iOS XE, and Lala. So, question number 5. You need to become a member to join.
Are you crazy?
No, still not crazy. You need to become a member to join the RIPE community, the RIPE NCC, the RIPE meeting, or my fan club. So my fan club is open to everybody, just like the RIPE community. Only you won't get so much in return from joining my fan club. I promise you that. So the right answer is, of course, you need to become a member of the RIPE NCC. Anybody can join the RIPE community. Anybody can join my fan club. And anybody can join the RIPE meeting. Scoreboard is IPv5 at the top, Andreas, iOS XE, Trix, and Lala. Question number 6.
Good luck.
You will need that. Working groups discuss RIPE policies on mailing lists. Is that true or is that false? True or false? There's only 2 choices here. Working groups discuss RIPE policies on mailing lists. True or false? So, make a pick, and the right answer is, of course, true. All the RIPE policies are discussed on mailing lists. Scoreboard says Andreas taking the lead. Trix, next, iOS XE, IPv5, and Lala. Question number 7. Which of these is not a RIPE working group? Is it the DNS, the IoT, the open source, or the AI? If you've been paying attention, if you've seen that slide, you'll know that one of these is not a real RIPE working group.
Oh, no!
That's right. One of these is a faker trying to blend itself in somewhere. And the right answer is, of course, AI. There is no AI RIPE working group yet. Scoreboard says IPv5 at the top, Trix, Andreas, Livio, and iOS XE. Question number 8. Which of these came first? So if you know your history, you'll know this one right away. Was it the first working World Wide Web browser? Was it the fall of the Berlin Wall? Was it the Voyager to closest to Neptune? Or was it RIPE 1? Which of these happened actually first?
Surprise!
It'll be a surprise when you figure it out. These all happened in 1989, but only RIPE 1 happened before every one of these other historic events. So RIPE 1 was first. Scoreboard says iOS XE at the top, IPv5 coming in second, Joe IPv3 making its appearance, and Trix. Question number 9. Does RIPE have a secret working group?
Why not?
Yeah, why not? Now the quizmaster has to die, of course, for revealing the secret. Then the other option is there are no secrets because there is no working group. If it's a secret, we would never tell you, of course. And the last option is what is a working group? And the right answer is it's a secret we would never tell. On to the scoreboard. IPv5, Livio, Trix, Lala, and iOS XE. Question number 10, and you only have 3 more questions. Where can you find the RIPE NCC support desk? So if you need some help, if you need something to do with a ticket or with a request, where can you find all these people? On WhatsApp, on the coffee break area, on Facebook, or nowhere? No. So the 4 options are very easy, and you can, of course, find them in the coffee break area. Go have a coffee, go talk to them. They are very friendly and ready to talk to you. Scoreboard says IPv5 still at the top. Livio, Trix, Lala, and iOS XE. Question number 11. Which organization was the first regional internet registry? So was it the RIPE NCC? Was it ICANN? Was it APNIC? Or was it Internet? Magically transport yourself to the back of time. Oh, that's wrong. I'm talking like some president out there. Magically transport yourself back in time and answer the right answer. The right answer is, of course, RIPE NCC. It was the first regional internet registry. Scoreboard says IPv5 still taking the lead. Trix, Lala, Windows 10, and Joe. And of course, last question. What does NCC stand for? Is it the Nerds Computer Club? Is it Network Coordination Center? Is it the Nordic Construction Company? Or is it the Networked Carbon Copy? So NCC can stand for so many things, but in this context, it only stands for one thing.
Are you sure?
Yeah, I'm completely sure it is Network Coordination Center. Of course, some people think it's the Nerds Computer Club, and I'd guess why. Don't know why. And of course, the leaderboard says at stage number 3, Joe. At stage number 2, Trix. And number 1, IPv5 winning over everything. Everybody, thank you for participating. We hope you had fun and learned something new. Enjoy RIPE 91. The day where you didn't learn anything is a day that you have lost. Bye-bye, and see you next time.
Thanks, Gerardo. That was fun as always. And thank you all for participating. Actually, what is always interesting in here is not kind of it's also, of course, for you to test your knowledge, but also for us to remember what to explain better next time. Because some things I think maybe we didn't explain well enough, so you got the wrong answers. But that's it for now for the newcomers tutorial. Thank you all for coming and for participating, and we'll see you around during the week. Next up is lunch, and as I think Hans-Peter said earlier in this presentation, there are some tables, so you're not in a separate room, but there are some tables that have a sign, for newcomers, so you don't have to just sit with each other, but hopefully others will join you and you get to know each other, but also others in the community. Yeah, have a great week, and then see you during lunch.
dragă, treabă n-am, dar cale-mi fac. Iar la cel și mi-ai urât, treabă am, dar numai cu cu gura dolce de 3 ori când sunt marș doce, dar la 6 nu-i pe plac. Ești pe la poartă, nu-i cap. Toți ies la mi-i dragă, treabă n-am, dar cale-mi fac. Iar la cel și mi-ai urât, treabă la
Yeah. No. Sono andato a prendere il microfono. Li faccio, ma non vedo un tasto, non si vede, però li faccio per chiudere temporaneamente. Ma quando mi metto giù li devo spegnere con loro. No. Ok, va bene. Ma veramente, cioè, guardandomi no. Okay. Hello.
Wow. So all kinds of surprises being prepared here. I don't know anything about that. Well, welcome, come in, find a seat. I just noticed that we got our lift music back. I know a lot of you missed our intermission lift music over the last few meetings, but a popular demand, apparently it's back. So yeah, here there's quite a diverse opinion on that music. Yeah, please come in, find a seat. Welcome to RIPE 91. I'm Miriam Kühne. I'm the chair of the RIPE community, and we have two vice chairs here for this week. It's such a pleasure. We have Neil O'Reilly, vice chair, until Thursday, and then and then we also have Anna Wilson here, who is going to be the vice chair as of this meeting. Yeah, we're doing a proper handover ceremony on Thursday. Yes, Neil?
You'll notice, of course, that the Irish mafia is still in control.
I couldn't do it without an Irish person on my side, no. All right. Of course. Right, let's dive into it. People are still coming in, but yeah, please find your seat. We have a packed agenda, so I want to start. As of now, we have 322 people checked in here. I saw also quite a number of people online, also during the newcomer session, which is great. We have people from 48 countries at the moment, and quite a big delegation from Romania, which is fantastic. I mean, that's why we're coming to your country, so to allow you to participate. And we have this time one local hub in Poland. We're always promoting local hubs, and the RIPE NCC is helping also. We have facilitated. So if you're interested next time to get together in your home country, maybe in Romania next time, have a local hub to participate in the RIPE meetings together, but remotely, I'll be happy to help you out there. Yeah, as I said, we've been here before. Well, have I said it? I don't know, but we've been here before, actually 10 years ago, like 20 meetings ago, in this exact hotel. That church wasn't there then. I remember when I looked out of the window, there was this big square and then the palace on the other side. So now there is this beautiful church in the middle. So we've looked at the minutes or the meeting reports from back then. We found a few nuggets there. You see there on the, you can't see it really, but on the slide on top, there is the then RIPE chair presenting and standing there where I'm standing now. This was Hans-Peter Holland at the time. And then at the bottom picture, we had elections for the NRO Numbers Council. We still were using paper ballots and a paper box at the time. We also are going to have NRO NC elections this time. It's got a bit more sophisticated, but we need a whole presentation for this. We'll have a presentation later on to explain you how to vote. And then we had a few quotes there. There was actually a discussion on how to move forward with the IPv6 only network during RIPE meetings. So it was considered the most important goal. And then also Jeff Houston was here and gave a typically entertaining presentation. And at the time he predicted that we won't have more than 5 laptops in the room by 2020 because everybody's going to be on other portable devices. Now I still see quite a number of laptops in here. But it's always fun to look back at people predicting the future. Right, so we have a code of conduct, as you know. You can find it online. I mean, bottom line is please treat each other with respect. You can find all the details online. We have a great code of conduct team here on site. I'm really happy to report that we also have new members on the team. I'm always very pleased to see people volunteering for this important community task. So they're going to be here in the corridors. You know, they have also a separate room. You can find them there, and also, of course, online and by email. The RIPE Code of Conduct team also issued a survey. They wrote a RIPE Labs article some time ago with a link to a survey, and they would really like to hear from you. You know, especially like if you want to report something, or maybe if you don't report, why don't you report something? You know, what you feel as your, you know, your voice there and for the Code of Conduct team. And also if you're a newcomer to this meeting, we would also like to hear from you, but please maybe at the end of the meeting. So after you've made the experience here for one meeting at least, but we definitely like to hear your voice as well. So please don't be shy, and I think the Code of Conduct team would really like to hear you know, your experience with them and with this community. Some more faces here. This is the program committee for this meeting. They are responsible for the plenary program. I think they put together a fantastic program. It's going to start right after this opening plenary, diving right into some technical talks there, and it's going on throughout the week. They are, and I think I have a slide on that. There are elections also for the program committee. So if you're interested in that, please go talk to any of those friendly faces here on the slides. And then more faces, well, you're not going to see them all, I recognize them all, but these are all the working group chairs for this meeting. There are some working groups who will have selections going on at the moment, so at the end of the week this might have changed slightly, but those people are responsible for the content, and of course you are responsible, telling the right working group chairs what you like to discuss in these working groups. And coming to some sad news, I don't know, not many of you will remember Stefano Trumpi, but he died earlier this month. And most relevant for us in this community is actually that Stefano was a chair of EARN, which was the European Academic and Research Network here in this region very early on. They then later merged with RARE, the also academic association, and became Terena. And Stefano was on the board there and was very supportive of setting up the RIPE NCC. And he urged the academic community also to chime in and contribute financially to the RIPE NCC. So he was a big supporter of us, especially early on. So yeah, those of you who remember him, it's sad news that he died. Another person who most of you probably do know, and this is our community, we also found out that he died earlier this month, is Fergus Mackay, who was actually at the last RIPE meeting in Lisbon, and then we heard like a few weeks ago that he died suddenly. So he was very active in this community. He's been a working group chair for many years, and he was also a very supportive, specifically of local network operators groups, like all over the world. And so yeah, I was very sad when I heard that he passed away. And we have actually a book and a photo there for Fergus on the registration desk if you would like to leave a memory or some words that you remember about the Fergus, and we'll give that book to his family and friends after the meeting. Right, so it's hard to move on from this to the daily business. As I mentioned earlier, that we do have a number of elections and RIPE governance related topics during this week. So there's a program committee elections, 2 seats I think they're up, and they're looking for candidates. So if you're interested, please think about it and talk to the program committee, and maybe find out what the task entails. There are also some working group chair selections. I mentioned this in these working groups. They will be announcing the results during their sessions. There will be the NRO&C elections. We'll get to that in more detail. There's also a consultation later on in the BOF here today in the Birds of a Feather session about the second version of this RIR governance document, or also called the ICP2, plus document. And it's important for us as a community to also provide our feedback there and make sure we'll get the RIR and the RIR system that we need. So they have another BOF to tell you about the second document. And yes, as mentioned earlier, we'll have a kind of a handover session on Thursday. This meeting is the transition handover meeting from one RIPE chair team to the next RIPE chair team. This is the meeting plan. Well, you've all seen it probably online or in your app. There are a couple of changes. The Address Policy Working Group is meeting on Thursday instead of Wednesday today. And yeah, we'll have 1 BOF today and 2 BOFs on Thursday. The rest, I think, is pretty much the same. Yeah, as I said today, just now, this is the BOF that we have today. So it's important to follow that. And then we'll have 2 BOFs on Thursday, 1 more technical about DNS encryption, and then 1 more strategic, and that's the RIPE NCC organizes this one, and that's really important also, not only for the membership, but also for us as a community to provide input to the RIPE NCC's strategy plan over the next 5 years. So they would like to hear from us all. And then tomorrow afternoon, we'll have, again, a diversity session. It's this time chaired by Dinesh Mavuta, and we have some really interesting talks there. Actually, over the last few meetings, I think we had some really good widespread of kind of focusing on various aspects of diversity and relevant to our industry. And so we'll have this time again lined up a number of interesting speakers and topics. And last but not least, of course, this wouldn't be a meeting without long enough coffee breaks. You know, as our former vice chair also mentioned, this is a feature. We have long coffee breaks, long lunch breaks, and these social events where you get to talk to each other, get to know each other better. So we have a welcome reception today. Excuse me. And then a networking social tomorrow. Please bring your badge, but other than that, it's for free. It's hosted by the local host here in Romania. And then on Thursday, we have the traditional dinner, and there you will have to buy a ticket. And then at the end, I mean, we couldn't do this without our sponsors. So I would like to thank our host, Interlan, and RIPE NCC as a diamond sponsor, AWS as platinum sponsor, and all the other sponsors who are helping us to put up the network here and organize the meeting. So a big applause. And with that, that's my short opening. And I've been told there would be a surprise by the local host now, so I'll make space. Thank you so much. That was something different for a right meeting. So, well, maybe an inspiration for the next host, who knows? I would like to ask Eric, who actually represents the local host here from Interland IXP, to say a few words.
Thank you, Miriam. I'm Eric from Interland Internet Exchange. We are the host, and we are welcoming you back in Bucharest after 10 years. If you remember, we had the RIPE 71 here in Romania, and now after 10 years, we have RIPE 91. Bucharest is what it was first attested in 1459. It's a city with more than 2 million population. It's almost 10% of the population of Romania. And it's also the 8th city in European Union in terms of number of population. And also it shares 25% of the Romanian economy. And also Bucharest is, according to OCLA, in September 2025, it's the 5th city in the world for fixed broadband speeds. So it's we have a very fast connection for internet connection here. Interland Association of Romanian Internet Service Providers. It was founded in 2005. It's a not-for-profit organization, and its mission is to promote collaboration, knowledge sharing, and internet infrastructure development in Romania. We have 55 members, internet service providers based in Romania, local internet service providers. And also the Interland Association operates the Interland Internet Exchange, which is Romania's largest internet exchange platform. Interland Internet Exchange has 140 networks connected, out of which 90 networks are from Romania, are local ASNs. It operates a distributed infrastructure across 15 points of presence in major Romanian cities, and of course in Bucharest and in most important cities in Romania. And also we have 2 international points of presence in Frankfurt and in Sofia. Besides peering, one of the most important services in our Internet Exchange platform is the TV Exchange service, which allows TV channels to deliver their streams to the TV cable providers. We also have 6 DNS root server instances in Interland Internet Exchange, of course, including K-root from RIPE-NCC. And recently we implemented an mRoot node, which is the second mRoot node in Europe after Paris. And of course, we have route collectors and the OTDNS service from RIPE-NCC. Our daily peak traffic is 800 gigabits, and we have ports, a very large range of ports available, starting 1G up to 400G. This is our team here at RIPE 91. I will ask my colleagues to stand up. So please, my colleagues. So, if you need anything, if you want to ask anything about the Romanian market, about Interan, about Bucharest, about Romania, you can find them here at the RIPE 71. Well, this was my short presentation. Thank you very much, and enjoy.
Thank you. Next up, we'll have a presentation by Hans-Peter Hollen, the Managing Director of the RIPE NCC, who is the diamond sponsor, I believe you are, with this meeting, and also Hans-Peter is going to explain some of the logistics for the meeting here.
Thank you very much, Miriam. Yeah, so for those that wonder, diamond sponsor means that we pick up the rest of the bill, right? So I'm Hans-Peter Hollen, Managing Director or CEO, if you want, of the RIPE NCC. 10 years ago, I stood here as RIPE Chair, but 5 years ago, I was convinced to take this job. So there you go. RIPE Community, as Miriam is sharing, was formed in 1989 to solve all problems of internet in Europe. And they required a couple of meetings for that. Well, we're still going on, 91 meetings later. Then RIPE NCC was set up as a secretariat for the community, a membership organization run by RIPE NCC staff and an executive board. And we provide services and we implement policies. So since I'm here, I'm expected to tell you about the logistics for the meetings. Well, if you're remote, you already know that you use MeetEcho, or you can watch the live stream. If you're in the room, you may also want to use MeetEcho, the webback on the phone, so that you can get yourself in line or see the chat or the questions and so on. So that's a very useful way to interact even if you're in the room. And all the sessions will be recorded and posted publicly afterwards. So if you have the MeetEcho interface in front of you, here are the cues that you need to know, the icons for audio and video queue if you want to speak, the Q&A or the chat or the stenography. So we have stenographers here as well. And sometimes they also write down what I should have said, not only what I say. So that can sometimes be interesting. Badge is important, so if you wonder what the Wi-Fi password is and other things, it's all on the back here, so have a look at that. And there are QR codes to scan for the social events. Photography and yellow lanyards. Well, there is a photographer. I think he's following me in particular this time, so if you don't want to get your picture taken, don't stand next to me. Or put on a yellow lanyard, then he will try to respect your privacy, and we will definitely not publish your picture. Meeting support, there is a meeting organization team, there is a tech team here, there is a support desk. You can get your registry checked by an assisted registry check. And please talk to any RIPE staff. You can recognize us by the black lanyards. And you can also take a professional, certified professionals exam if you want to. We have the facilities to do that here. Or participate in our user testing. Because we know before we implement stuff, actually bringing it here so that you can have a look at the ideas we have and give feedback on the prototypes before we put them in production. RIPE NCC, speak to us, I said. You can see the pictures here of my colleagues, Leah, Pedro, Antonella, Stephen, Fallon, and Adonis. And as I mentioned, you can here come and give feedback on Academy, assisted registry checks, ASPA, RPKI, the LIR portal, and RIPE Atlas. General meeting. There is also a members meeting here on Wednesday. You need to register specifically for that one because only members get in. So you can do that in the LIR portal, and then you need to pick up a special badge that you get on your name tag to be let in. If you don't register and don't have, you will not be let into general meeting. Strategy. We're working on a next 5-year strategy from 27 to 31. It's still being discussed. Please join the BOF on Thursday to discuss what we have published so far, and there is a survey. Please take the survey. So I expect everybody to take out their phones now and take this QR code. Nobody's listening to me today. It's not a malicious link, I promise, or at least I think. 30 years of training. We will celebrate 30 years of training here at RIPE 91. Our first training course was in 95. Actually, it's my 30 years anniversary as a participant in RIPE meetings as well, by accident. So yeah. And thanks to everybody. There will be a celebration then on Thursday. Any questions or comments? I don't think we have time to that now because you want to see the next presentation, right?
There's always time for questions, of course. I don't see any. No, it's okay. I don't see any. Anyone? No. So next up, we will have another presentation by Ulka Atale, RIPE NCC communications staff, about the NRO NC elections that I mentioned earlier.
Hi, everyone. My name is Ulka Atle. I'm part of the RIPE NCC communications team. This is a highly administrative presentation. Apologies in advance. So the NRO-NC stands for the Number Resource Organization, Number Council, which serves as the address supporting organization, Address Council at ICANN. There might be a quiz. We have 3 members. 2 are elected. 1 is appointed by the RIPE NCC Executive Board. The election we're having here is to fill 1 seat for a 3-year term starting in January 26, ending in December 2028. We have 3 representatives currently, Hervé Clément, who's appointed by the board, Constance Berger and Andrei Robashevsky. They're in the room here today, I think, some of them. They're at RIPE 91 anyway, and it's Constance's seat that's up for election. We have 3 candidates running in this election, Constance Berger, Alexander Timokin, and Tiago Felipe Gonçalves. You can find all the information about the nominees, including their bios. They've all made videos explaining their motivation and the expressions of support that members of the community have submitted on our website. In order to be eligible to vote, there are some criteria. We updated these a couple of years ago. You need to have registered for RIPE 91 and selected the option to vote in the NRO-NC election. Additionally, you need to have attended any 1 out of the previous 8 RIPE meetings. So not regional meetings or general meetings, but specifically RIPE meetings. And by attended, we mean you must have registered and checked in, even if you're an online participant. So for this election, it's RIPE 83 to RIPE 90. And additionally, you need to check in for RIPE 91 before the deadline. If you've forgotten to register to vote, if you're on site, you can go to the registration desk. You can also do exactly what the online participants can do, which is to use your personal options link. You received it this morning in the email from the meeting team, and select the option to vote in the election. And if you're participating online, please remember to click on the check-in button. You will automatically be disqualified if you have not been checked in. I'm repeating this a lot because that's typically what people forget. Yeah, so you can go to the reg desk. How do you know you've been checked in? Go to the attendee list. If you see the nice green tick mark next to your name, you've been checked in. Normally, this is what the registration staff do when they hand you your badge, but please just double check. And if you don't see the tick mark, you might not be checked in. If you're not eligible to vote, you get an email from the election team informing you that you're not eligible. If you think we've made a mistake, you can ask for a review using the form. The review team reviews your information, and then we'll send you the decision. The deadline to request a review is Wednesday, the 22nd of October at 2 p.m. UTC +3. That's local time in Bucharest. Voting is quite simple. You receive 2 emails from Assembly Voting. One contains your voting code 1, which should be pre-filled unless you're using Safari. And the other contains your one-time PIN code. You need both codes. You select the candidate of your choice and submit your vote. If you abstain, we count that we count you as a voter, but your vote doesn't count. By that I mean your vote does not count towards the result. This is what the first email looks like. Click on Vote Now. See, this is what the second voter code email looks like with your voter code. It will not be 123456. Please copy paste that in. If you're on Safari, I repeat, you might need to copy paste voting code 1 as well. You can, oh, did I skip this? Yeah, there are 3 candidates. Select the candidate of your choice, or you can also choose to abstain. The platform also allows you to verify that your vote has been registered accurately. And some deadlines, because it's not administration. If you don't have deadlines, we'd be doing it wrong. Tuesday, that's tomorrow, is at 2 p.m., 1400 UTC plus 3. That's the deadline to register to vote. That's also the deadline to check in to be eligible to vote. Voting opens tomorrow at 5 p.m. and voting closes on Friday at 9 a.m. And the results will be announced in the closing plenary. If you need help, my colleague Boris is supporting the election online. You can send an email to nominations@ripe.net. Ilka and I are here on site. It's confusing, Ulka and Ilka, but we're both here. And if you need any help, the registration desk will find me, and I'll come to the reg desk and help you out. And that's it. If you're celebrating Diwali this week, a very happy Diwali to you. Thank you.
Thank you, Ulka. And last but not least, as part of this opening presentation, opening session, we'll have Max Stuckey, the chair of the program committee, who's going to present you something about the program committee and then also take it over straight away into the PC-owned plenary session. So, go on.
Okay, thank you, Miriam. So, good afternoon, everyone. I'm Max from the RIPE Program Committee. I'm chairing it. What do? We basically get submissions, we review them, and we prepare the agenda based on that. So we not only we look at what's incoming and review it and give it yes or no, but we started also providing small reviews for people to understand what they could improve in their presentation. So based on that, then we prepare the agenda, we chair the sessions. You will see some of the members of the program committee chairing the sessions during the week. And we make sure everything runs on time, or we at least try for it, because we're actually late now in the agenda. But that's fine. We can live with that. So, who is on the RIPE PC? Miriam already presented this, so there's a different order here. The change from previous meetings, actually not from the last presentation I did, which was 2 meetings ago, is that we now have a different MENOG representative, which is Osama. And I would ask Osama to stand together with the rest of the PC members that are here. Jan, Antonio, where is Osama? So if you see... And then we have a new member also. Thank you, everyone. We have a new member, Amedeo, which is not here. He will arrive later in the week. The rest are members that have been on for a few meetings as well. We have 2 seats that are open for election. I'll say it later as well, but keep in mind your picture could be here in one of the next meetings. So what are the acceptance rates for the talks? We have, you can see that for the plenary talks, we have about 50%. We had 31 submissions and we accepted 15 because that's the number of slots we have available. 4 submissions for BOFs and we accepted 3. One of them we suggested that it would be integrated into another BOF as part of it because the 2 topics overlapped. And then tutorials, we only had 2 submissions. One is the one you saw this morning. And then for lightning talks, we had 8 submissions. And so far, we have accepted 3, although this is a reminder for the program committee members to go and rate those that have been submitted recently. The 5 that are still in the not accepted stage, to give us more data to do that. And it should be, in the end, we have 9 slots for lightning talks, so there's still space, and that's why there's an asterisk next to it. So, as I said, lightning talks, we're still accepting them. We accept them until Wednesday. So if you have an idea for a talk that's about 7 minutes with 3 minutes for questions and answers, please talk to one of us and even submit that. One important thing is, when you submit, please give us at least a bit of draft slides so we get an idea of what your talk would be about. They don't have to be the final ones, but at least give us an idea, because we're interested in understanding how you would present that as well, not just the idea. And what other change we have from RIPE 90? We moved to a new submission system, pre-talks, and that meant changing some of the ways we worked. And that created a few bumps in the road, because you have to adapt. For example, when we do our online meetings to decide which talks are accepted or not, it changed the workflow for us, because we moved to pre-talks. It changed the way the talks need to be submitted. So you now need a RIPE and CC Access account, and then you need to go through a different procedure. But it's nothing too complicated. And then if you need any help, there is the tech team that has a table outside, and then you can go and ask for information. But we tried to adapt our procedures to new pre-talks. It went generally smoothly, but we did have some bumps in the road. So if you've had any issue dealing with the program committee for this meeting, I apologize. But we were also in a learning curve. So we also use pre-talks for generating the agenda, which is something we didn't do in previous times. So that also changed how we can do changes to the agenda as we get closer to the meeting. Then one thing that we still continue to do, though, is to provide feedback. So we always have 2 submission deadlines. And if you submit at the first deadline, then what you do is, if your talk gets rejected, we give you a reason for it. We spend a bit of time. It's not an academic review. We tend to write a couple of paragraphs about the reasons. And maybe we can help you also resubmit, improve your presentation, resubmit it, and then in the following session, the following deadline, maybe that could be accepted, which is something that happened to a couple of talks in this session. They did a submission initially. We suggested some improvements. They went back, did some changes to the presentation, and then in the second deadline, after the second deadline, it was accepted. So we've seen that this brings some positive returns to what we do. So it's nice that we spend time doing that. Last but not least, we have PC elections coming up. We have 2 seats. You can nominate yourself until 3:30 tomorrow. And if you would like to understand what kind of work it involves being on the PC, just approach one of us. It's not it's not too much work. We tend to only do a relatively low number of meetings for every RIPE meeting we tend to organize. So we do 2, maybe 3, and the rest is time that you have to spend reviewing the submissions. Then, if you want to know more, we have a charter, RIPE 829. You can go and have a look at what the RIPE PC is supposed to be doing, and then maybe come to us and tell us that we're not doing the job right for now. After this, if there are any questions, I'm happy to take them, but I know we are also a bit late, so happy to take any question if you have, or you can approach us later in the, Miriam.
I'm sorry, I don't have a question for you, but I just using that opportunity, I was asked
to mention to you that in the chocolates that were just handed out, there's rum. So some of you might not want or might especially want them. It's up to you. But this is a little warning because it's not clear on the label, I think. There's alcohol in the chocolates.
Okay. Well, thank you. Okay. Then I would move on to the ownership now of the session from the PC side. And I would introduce you to the first talk of this meeting that is from Yoshinobu Matsuzaka from IIJ. And he will talk to us about scanning IPv6. So, give a big applause.
Hi, everybody. This is Yoshinobu Matsuzaki, or Mats, if it's easier for you. Daily life, I'm working for an ISP as an engineer named an IIJ. Also, I'm serving the executive council of EPINIC. It's basically board member of EPINIC. And then today I'll talk about a short story, A Day in the Life of IPv6 Scanning. So it's a story about how people scan, how I observe, and sometimes how we get scanned. Let's start with where we are today. So here we have familiar diagrams. So IP adoption is slowly but gradually increasing. It's around 48% globally. So congratulations so far. So it's getting popular and popular nowadays. We have many IPv6 hosts in the internet. The IPv6 addresses are long, 128 bits. So the 128 bits divided into a prefix and then interface ID. Usually, /64 is assigned to each subnet. So legacy IPv4 space is very small compared to IPv6, right? Scanning all of IPv6 space, it's like trying to find like a one cat in the right region. It's very tough, very challenging thing. IPv6 hosts configure themselves using DHCPv6 or Slack. And with Slack, the host generates the last 64 bits, the IID. That IID can tell you a lot about the host, depending on how it's made. For example, old EUI64-based IID reveals the MAC address. It fits within the 48 bits range, or even a smaller range if the vendor is considered. Modern ones, the red ones, RFC 7217 or RFC 8981, more privacy-friendly, harder to scan. Some implementation, like your MacBooks, have already adopted the privacy-conscious IID methods, but many devices, including the latest gaming console, still use EUI64-based IID, unfortunately. The scanning all of IPv6 network is almost impossible, almost. Technically, it's feasible, but actually, even if you send one packet per microsecond, it will take large amount of time. So to scan the IPv6 network, you need some clue beforehand. We have DNS name, we have TLS certificates, or public measurement, like Live Atlas. These hints help scanners assume which addresses are alive or in use. Right? researchers studied target generation algorithms, TGA, to generate smart guesses. There are a bunch of different studies. Maybe it's a good topic for students or PhD candidates, right? These methods take a list of known reachable IPv6 hosts as input, and from there, guess other IPv6 hosts. The goal is to find IPv6 hosts and make scanning more efficient. Most of them use the IPv6 hit list as their input. The IPv6 hit list is basically a list of reachable IPv6 hosts, currently around 3.6 billion addresses in the list. So if you are online and responding, there's a good chance you are already on the list. So that's a theory. I decided to use my hobby network to see what's actually coming to my network. I prefer to use open source projects, so here's my choice. PF and NF tables to observe those scanning packets. Both are widely used packet processing implementations. Here's my setup. I use PF for layer 3 routing segment and NF tables for layer 2 bridge segment. So actually my router is BSD and L2 bridge is a Linux box. So I set some processing there to monitor the incoming packet. At layer 2, I can only see packets to existing host. Packet to unused addresses don't even reach you. The router on the segment drops them after NDP fails, right? So you have a very limited visibility on the layer 2 bridging. At layer 3, I see more, including packets to unused network or non-existing address, if routed, right? The routing is matter here. Here's my configuration. Because this is material for the record, it's a bit on the safer side. If applied as is, it will quietly blocking most of the scanning, so you will not see that much. If you want to see scanning packets, you need to configure the system to respond to all probes to attract scanning traffic. Right. And this is the PF configuration. So the result. When I compared what I saw to the IPv6 hit list on the layer 2 observation, actually I found one host is actually listed on the hit list, but I didn't see the packet to this host. Instead, I saw a packet for hosts. One is an Atlas probe in my network. Another two were hosts with TLS certificates. And the last one, this is a bit interesting. And I newly installed an Ubuntu host in my network. And after installing some packages and updating the system, the host started to receive packets from the internet. I don't know why. Just I installed, then it received the packet from the internet. No idea. Could be, or DNS, could be. I don't know. On the layer 3, 9 hosts are actually listed, and 8 out of the 9 were receiving packets. Atlas Probe is one of those, and others as well. As I mentioned before, I observed many packets to non-existing hosts as well on layer 3 observation. Again, you need to respond to probe packets to be scanned, right? This side? Yeah. What do people scan for? Mostly TCP, as you can see, especially web-related port numbers. A few UDP packets like SNMP, DNS, IPsec, NTP. And I saw some anomaly on the ICMPv6. That's a story of its own. One host from faraway cloud kept pinging my host every 2 seconds. Don't know why. Likely someone forgot to stop a ping command. I imagine their terminal still open somewhere, but I don't know the intention here. And this is an observation by layer 3. The result is almost the same. Those destination port trends are pretty much similar to the IPv4s, right? So they are scanning a bunch of defined port numbers once they decided to scan, right? I also looked at the destination IID patterns. Many were EUI64 based, right? Or had the simple patterns like colon A, colon A, colon 2, or colon A0, colon A0, colon 2, right? As such. Some were totally random, but not many. So scanners often start with obvious addresses. Prefixes that have never been reachable get almost no traffic. So in IPv6 at this moment, if nobody knows you exist, you are invisible. In IPv4, you could receive a scanning packet just by announcing the prefix by BGP, right? However, that does not work in IPv6. So the old style IPv4 darknet method to observe those scanning packets doesn't work anymore. I also saw some interesting packets. Sometimes I saw ICMPv6 packet 2-bit messages with embedded like an SSH style port number but in UDP inside, or tunnel probes like GRE or IPv6 in IPv6. Some of the scanning packet had a distinctive IPv6 header structure, like lack of IPv6 flow label. The sources, mostly from measurement-related entity like universities, research project, or cloud providers. Maybe they are using cloud system to scan your network. Scanning often comes from a specific host, but then sometimes the same scanning pattern came from different /64 segments. Maybe they are load sharing among the networks, or maybe just creative scanning style. If your host replies to probes, it's added to the IPv6 hit list. Okay. If your host stays silent, it's eventually removed from the list, usually after 2 weeks. So if you want to disappear from the list, just go quiet. But some scanners are very patient. Even though I removed the host from the network, after 1 year, still I observing the packet toward this non-existent address. They still keep scanning the address. Wow. very patient. If you want to be scanned for some reason, like, for example, to study scanners' behavior, like me, I want to have more scanning packet toward my hobby network to monitor their behavior. Here's how. Make your /64 look alive or in use. Issue TLS certificates using host name. Publish quadray record in DNS and put an URL on some website. Use UI64-based IIDs. Then sit back, wait. You'll soon have many new friends from the internet, right? But most people want the opposite, not to be scanned. So here's how. Don't list sensitive hosts publicly. Segment your prefixes based on your needs or based on your purpose. Don't respond to unknown probes. And if you are on the hit list, make it silent for 2 weeks, right? This usually works. So to summarize, IPv6 scanning is already happening actively. The IPv6 hit list is widely used by researchers and companies. Being unreachable may cause your neighboring address to be scanned too. IPv4 style darknet method doesn't work anymore, as I said. And above all, access control still matters. And if you subscribe to shadow server's notification, you should be getting reports about IPv6 hosts in your network. Daily basis. IPv6 may be huge, right? But then someone, somewhere is always watching. Scanners are trying to tell success from whether there's a response or not. This is my thing, but what if we change the problem? For example, if every IPv6 address responded, but then only a few are real hosts, what methods would the scanners need to use? I hope someone will try it and share the result here in the future. Thank you very much. That's my talk.
Thank you, Mas. Thank you very much for this talk. Are there any questions? Yeah, please.
Yes. Oops, Matthias Wieler from TU Dresden. Thank you for the talk. Not a question, but a comment. If you want to attract attention of scanners, you can also announce more specific prefixes in BGP. So we have a study that will be published at Conext that shows exactly this. So scanners do not only monitor hit lists, but also BGP announcements.
Thank you very much.
Tom Strix, Cloudflare. Really interesting talk. Thanks for that. I was wondering if you kept like a time frame list of how long it takes for an IPv6 host to become alive, and then how long it takes to get scanning traffic. Because that's one of the things that you notice very extensively with V4 hosts, right? It's like you bring a V4 host online, and then 30 minutes later, you get scan traffic. Do you have an idea of the time frame that it is for IPv6?
Sorry, I don't have here the number, but as I said, and I have the newly installed Ubuntu host, and it's immediately scanned after upgrading the system. So somehow it could get a scan packet immediately, like an IPv4, but sometimes you don't get any scanning packet at all. Sometimes it totally depends.
Okay, thank you.
All right, any more questions? Tom, don't go far. Okay. Thank you, Mas.
Thank you very much.
And Tom, you're going to talk about SNMP
and GNMI.
GNMI. Thank you very much. The floor is yours.
Good afternoon, everyone. It's great to be back in Bucharest. It's been 10 years. I think it was definitely up for a next one. So I'm here to talk to you about GNMI, SNMP, and everything around it. Maybe talk a bit about, the implementations and methods that you as an operator or as a network person can run GNMI at your, there we go, at your network. So who am I? I've done a couple of RIPE talks at this point, so I hope that some of you at least recognize or know who I am. For those of you that don't, I'm a principal engineer at Cloudflare. I think the easiest way to describe my job is I'm a professional shitposter for the most part. You can find me on Blue Sky at ecmp.network. I am genuinely surprised that I managed to get that DNS name. I was pretty late with the .network side of things, and yet here we are. So what am I going to talk about? Like I said, it's going to be about GNMI. Basic introduction to GNMI, right? GNMI 101, what is it? What does it do? What does the name stand for? Talk a bit about GNMI versus SNMP. SNMP, everyone knows what SNMP is, or at least I hope that you all know what SNMP is. Compare the two a bit, talk about the upsides, the downsides of both the protocols, and then the way that we've implemented GNMI at Cloudflare, how we're using it internally, how we're using it to make numbers go burr. So first of all, right, GNMI 101, why do I need to pay attention to Tom ramble on about for 30 minutes about a protocol you don't know about? Very simple, GNMI is the gRPC remote network management interface. What does RPC stand for remote procedure calling? It stands for G. It used to be Google, but then Google made it public or made it open source or kind of got it going into a more community-based side of things. So the G no longer stands for Google. The G now stands for gRPC. Network engineers are bad at naming things. So what is a network management interface? Basically, three core components here is that it allows you to retrieve configuration, it allows you to modify configuration, and it pushes telemetry. The rest of the conversation, the rest of the talk here is primarily about telemetry. We don't use it for retrieving configuration or modifying of configuration. For that, netconf exists, and netconf is entirely sufficient because it's XML and it doesn't make me want to kill myself. So base component, super important for GNMI, for everything, is it relies heavily on OpenConfig. What is OpenConfig? OpenConfig is a cross-vendor unified data models in Yang. For those of you that don't know what that means, I'll go into what Yang is in a bit. But OpenConfig is basically you have a group of people, primarily Google engineers. There's a theme here. Primarily Google engineers that will dictate or will kind of agree upon a standardized set of models on how do we talk about network configuration. That can range from how do we define a DHCP client, how do we define a DHCP server, how do we define a BGP speaker, those kind of things. Those all get standardized, and these are the components or the attributes that sets configuration needs to have, and that gets published in the OpenConfig organization as OpenConfig models. As we progress in our automation journey, for network engineers, you'll see more and more vendors supporting OpenConfig models. Some of them are going to be the open source ones. Some of them are going to be vendor-specific ones. Arguably, the worst thing that exists is the open source models, but not fully, which is dreadful to work with, because then for 90%, they'll work with all of your vendors, and then for the 10% of subset, they don't work with any of them except one. So what's Yang? It's yet another next generation. That's what it stands for. As I said, network engineers are dreadful at naming things. This is what it looks like. It's very simple, right? It's basically a dictionary side of things with a bunch of metadata up top here, including what the revision time is, a namespace. This is the XML namespace annotation, and then
at the end of the day, kind of what your dictionary looks like. That's it, right? It's very simple. It's pretty trivial to work with. And this is the modeling language that's used for OpenConfig to define all of the models that we have. So like I said, it's basically just a very simple modeling language for network management. So back to like the agenda, back to that initial point of GNMI. I just told you what GNMI is, right? Let's talk about what GNMI versus SNMP is. What's SNMP? Very simple. It's old and slow. It is primarily insecure, at least if you run SNMP v1 or SNMP v2. SNMP v3 does support encryption and authentication, but it's a mare to set up. And here we are. Also, I don't think anyone really uses it in production all that much. We do, but it's not fun. Also, last but not least, it uses ASN1 extensively, and ASN1 is insanity as a language. It is dreadful to use. It is completely incomprehensible for those for the people that don't use it on a day-to-day basis. And you just need translation layers upon translation layers upon translation layers to make it make sense in any way or form. The biggest problem that we ran into and why we started exploring our GNMI kind of journey is the old and slow component, specifically the slow component. BGP is also old, and that seems to be working pretty well, but unfortunately SNMP not as much. Specifically what you're seeing here is one of our most heavily loaded routers that we have in our network. You see all of these gaps in the SNMP polling here. So what's happening here is that the way that SNMP is implemented on the majority of vendors is it's polling, or it's getting all of the counters for all of the interfaces, dumping that through your control plane, and then from your control plane you punt that to whatever monitoring system that you have. If you have too many interfaces, that polling is going to take a very long time. And if you're scraping faster or trying to scrape faster than that your router is going to return your data, you get gaps, which is suboptimal, because if there's any congestion events in these gaps, then we wouldn't know about it, because if you don't have the visibility, you can't say whether or not something's congesting. And unfortunately or fortunately, our customers seem to care about uncongested paths. So very quick comparison, right, of GNMI versus SNMP. GNMI is pretty simple. It's standardized resource path, all using OpenConfig with protobuf encoding. It's secure by default. TLS is required. You can't even spin up a GNMI server or GNMI client without running MTLS. So that's pretty neat. It's using HTTP2 by default, and it's a publish subscribe architecture. What that means is SNMP is primarily used for pool-based counterfetching. Sorry, mind blanked a bit. So pool-based counterfetching, you can do push with traps, but again, it's a bit of a niche use case. What you do with PubSub is that as a client that is interested in metrics or is interested in configuration, I will tell the router, it's like, hey, you can send me data to this endpoint, and that router will then start sending you data at either a specified interval or just a one-off or whatever. But it's publish subscribe. So you basically just publish the intent or publish the interest in metrics, and then the router will keep sending you kind of refreshes all the time. SNMP, instead of protobuf, we get OIDs. At one point or another, when I did this talk as a trial at Net London, Ben was nice enough to remind me that protobuf in this specific use case is basically just new OIDs. So it's like Yang, but worse. So it's OIDs everywhere, right? The fun thing of setting up an SNMP scraping host is first figuring out which MIBs do I need, and which Debian package do I need to download to get all of the MIBs, and are any of them conflicting, and does it even work? Good times. It's plain text by default, like I said, right? V1 and V2 is plain text. You can run V3 with encryption and authentication on top of it, but it's entirely optional, right? It's not something that's mandated. It's not something that's encoded or hard-coded in the protocol spec. It's also pure UDP. And the joys of UDP are infinite, I'm sure, but the bigger problem here is if you have MTU mismatches, for example, really good time in trying to figure out why the hell you're not getting the data that you should be getting. So not good fun. Now let's talk about the elephant in the room, right? Like just purely from that kind of comparison, surely GNMI is the superior monitoring system, yet we're not there, right? I think for the mass majority of you folks here, let's do a raise of hands. How many of you have heard of GNMI, and then later, how many of you run GNMI in prod? There we go. That's about 5% of the room, I would say, give or take. So we're not there yet, right? And there's a wide variety of reasons why that's not the case. One of the things is, if it works, don't fix it, right? And then SNMP for the majority of us just kind of works, and it just does the job, right? GNMI also has its own problems. Vendor adoption is a pretty big one. Your fridge probably runs SNMP. Your oven probably does as well. Whether you want to or not is obviously a different conversation, but it's not going to start running GNMI anytime soon. Or at least that's what I'd hope. I'm not sure how visible this is, but the vendor consistency in GNMI is dreadful. The key component here that I'm indicating is here we have underscores to delineate kind of the individual words. So you have laser underscore RX underscore power underscore low underscore whatever. And then we have carrier dash transitions. The consistency is just not there, which also means that certain vendors will do carrier dash transitions. Okay, because I think, if I remember right, that is the correct OpenConfig annotation. And then other vendors will do carrier underscore transitions. At the same point, depending on which kind of GNMI consumer that you're using, that's going to turn into a different metric, which is not great if you want to compare different devices or compare different network traffic. Also, last but not least, SNMP is incredibly well documented. There is a multi-varietal ecosystem available of SNMP clients and SNMP servers. All of them are pretty well documented. The MIBs, for the most part, are pretty well documented. GNMI, not as much. One good example here is from a specific vendor that may or may not have been acquired last year by a even bigger vendor. Has, their documentation for the majority of their GNMI counters are not available on their website. It's actually available on this PDF, and that PDF is basically 300 pages of, here's counters, do something with it. And it's dreadful because that also means, because it's a PDF, you can't search it on the web, right? You need to find the PDF, download the PDF, and start searching through it. And then last but not least, they did this delightful thing of, here's our documentation all the way up to 23.2 R1, because if you want to use anything after 23.2 R1, here's a different web page that contains all of the documentation. Why they did this, I don't know. It just means I now have 2 web pages bookmarked instead of 1. It works, I guess. Like I said earlier, protobuf OID it's basically the same thing. We replaced one pain in the ass with another. We swapped out ASN.1 with protobufs. Fine, I guess. gRPC kind of mandates the use of protobuf, so that's okay. It's not the easiest thing to read. Just like ASN.1, if you find a protobuf on the wire, good luck trying to understand or decode or figure out what you're looking at. That's not happening, but that's the same thing with ASN.1, so that's not really a big change anyway. A really cool thing, or an addition they added to the GNMI spec after the initial GNMI specification came out, was GNMI extensions. In the same way that SNMP allows vendors to get reservations on arbitrary OIDs, GNMI has a similar concept. It is GNMI extensions. What does an extension look like? It's basically this. It allows a vendor to put arbitrary metadata on top of any given path that you want. This is specifically from Juniper. They're also, as far as I know, the only ones that have currently a registered extension identifier, which is also why their ID of their register extension is 1. But yeah, you can put arbitrary metadata in that path. That's actually quite helpful. To make that work, you do need an arbitrary protobuf. So what the vendor is supposed to do, in the same way that we have vendor MIBs, it's vendor protobufs now. It's same but different. I'm not going to say one or the other is better. At least the MIBs I can download through my operating system. That's not the case with the protobufs yet. So let's talk a bit about how can you get GNMI data from your network devices into something that you care about, right? Like a metrics pipeline in one way or another. There's a variety of tools available. Not all of them are as well maintained or as available. The first one, I think this was kind of the original gangster of the GNMI tools out there. It's GNMI Gateway. It was developed by Netflix in I think the late 2010s. It's now owned by the OpenConfig group. Like I mentioned earlier, the OpenConfig group is basically just a ragtag, a group of folks that kind of go about OpenConfig side of things. Quite a bit of Google folks in there, but there's a bunch of other folks in there as well. It is no longer maintained. I think the last push I saw on the public repo was from 2020, 2021. So it's not seen active development for a while. It works though, for the most part. If your vendor does anything weird or anything specific, like JSON encoding everything that it dumps out, it's not going to work. But other than that, it's fine. Right, it's a good kind of initial avenue into I want to get some metrics or I want to get some data out of my router. How do I make that work? The GNMI gateway is definitely a good option. Second component here is the XRing streaming telemetry exporter. It's a smaller scope than the GNMI gateway. It doesn't try to support everything. It doesn't try to support all of the things. It's very nichely or tightly scoped to just getting metrics for a specific thing. As far as I know, it's also not maintained, but just like the GNMI exporter, it works though for the most part. And now on to kind of two of the actively maintained GNMI exporters that you can use. The first one is Telegraph. Telegraph is kind of fits within the InfluxDB ecosystem. So if you already have a metrics collection pipeline or metrics pipeline that uses InfluxDB as your time series database, then the only thing I would recommend is, run Telegraph. It's the easiest, basically plug and play component out there. The really cool thing with Telegraph is it's a MIMO architecture. So it's multiple inputs, multiple outputs, and it supports plugins. For the most part, if it exists, there's a plugin for it, which is pretty neat. It's even the case for GNMI. There's a plugin for it. It also has active Juniper contributions for the GNMI extension, which is primarily in thanks to for David Roy. So thank you, David, because that's been really helpful to kind of get us off the ground. Cloudflare is a Juniper-ish shop, so that's kind of where we're at. But yeah, if you already have InfluxDB in your environment, Telegraph, obviously, it's the easiest choice. And then you have GNMI-C. It's developed by the good folks at Nokia. It is now also owned by the OpenConfig group. Just like Telegraph, it's a MIMO architecture, so it's multiple inputs, multiple outputs. You can have multiple routers, just kind of go to a single GNMI-C stream, but GNMI-C can also collect from other GNMI-C exporters. So you can have this like very neatly chained together architecture. You can dump things onto Kafka and stuff like that. It's pretty great. It's also, just like Telegraph, it's actively maintained, and there's active code contributions happening there. So that's kind of what the ecosystem looks like. I'm aware of two very actively, pretty widespread, good community maintained implementations. That's good, right? I prefer to have a third. Variety is the spice of life, and variety makes the ecosystem healthy. But we're at two, and that's pretty decent. So now to the fun bit, is productions, like making numbers go brr. So how do we at Cloudflare use GNMI? This is our production architecture. The tiny bits here aren't super relevant, so don't try to decode any of this as much. But what we have here is per data center, we have multiple metrics collection nodes. all of these metric collection nodes will subscribe to the exact same data monitoring paths of the router. Be mindful, most vendor implementations will have a limit to the amount of subscribers they support. Juniper specifically supports 5 subscribers at a maximum, which means that if you run 6 metrics nodes or 6 GNOMIC clients, that 6th entity is just not going to get anything. It's just going to get a 403 from the collecting agent and just tell it to go away. What we then run on top of our GNOMIC deployments is a built-in tool or in-house tool that we developed. It's called NetWatcher. NetWatcher is, for all intents and purposes, is a metrics rewriter or a metrics proxy. That metrics proxy is then scraped by Prometheus, and Prometheus is our go-to time series database. So that's what we use. The main reason why we went for GNOMIC instead of Telegraph is the existence of the GNOMIC processors. Processors allow you to kind of data mangle your metrics before they even get inserted into your time series database. It's really neat. It has a bunch of available options that you can use, including a subset of Python or Python dialect. The name escapes me, but it's a Python dialect that allows you to basically run Python functions across your metrics to skew them in the way that you want them to. One of the example of this one, it's pure YAML. I know it's not great, but here we are. I think we've decided as an industry that YAML is our chosen anything, but here we are. So what this does is it allows me to drop any of the interface metrics for a bunch of the interfaces I am not interested in. Like I'm not interested in GRE interfaces, not interested in the management interface or the IP or any of this. So I can just drop those. There's some unused sub-interfaces on a Juniper box that get exported as well that I'm not interested in. And I can also replace or change some of the tags on the metrics that are being exported. And I can all do that within config of GNOMIC very easily, just using YAML or Python if I want to be a bit more advanced. So I talked about the GNMI extensions earlier. So there is a internal fork that we use of GNMIC that we're trying to upstream into the public code base, but I need to have time more than anything else. But you can find the pull request on GitHub on implementing this. But what this allows us to do is it allows us to specify a protobuf at runtime to decode the protobuf messages that we get from the GNMI extensions. For the vast majority, for those of you not familiar with kind of developing with protobufs, most of the time you use protobuf to do code generation, and then that code generation goes into your program or your tool or your system. But you can't really do that with GNMI extensions because depending on the vendor, you might have different protobufs that you need, and you don't want to have to recompile GNMIC every single time that a protobuf changes, things like that. So what this PR with that GitHub pull request does is allows you to define a protofile at runtime, and it uses the self-reflection capabilities of Golang to make that work. It is absolutely dreadful. Please don't judge me on that quality of the code, but it works. So that's the only thing that mattered. And then NetWatcher, I mentioned, it's basically an in-house built data processor and aggregation layer. It allows us to do some fun things like aggregating everything for an IRB interface. And removing contributors. I'll explain why we need to do that now, basically. But this is what it looked like for us. It allowed us to make our numbers go brr. I built an entire dashboard, which was a replication of our SNMP dashboard using GNMI metrics. It worked perfectly. This is for the Singapore router that wasn't showing metrics when I wanted it to, and it's working delightfully so. With GNOMIC, so that was a great choice. Unfortunately, this wasn't hurdles. There were definitely some problems, primarily because GNMI isn't always the most mature protocol, or the implementations aren't the most mature. Specifically, what we were seeing was that our IRB interface was doing petabits worth of traffic. We're not, as an industry, we're not at petabit scale individual routers yet. So me seeing like an IRB on a single chassis doing, I think it was 3 petabit per second worth of traffic is usually an indicator that something has gone wrong pretty badly. And the thing that we then start looking at is, okay, what is the actual counter that I'm deploying my rate on? And I saw this thing, which is a sawtooth pattern on a byte counter. Counters are supposed to go up, not down. So when you see a counter go down, you know that something's gone horribly wrong. So why is this? How did that happen? Very quick detour, because I also have 8 seconds left. So I'm sorry, Max. This is the GNMI architecture, very, very briefly. GNMI architecture on a Juniper box. You have a GNMI subscribe that goes to the routing engine. The routing engine then goes to the MQTT topic for a subscribe, and then you should get MQTT messages for whatever thing that you're subscribed to. MQTT is a message bus protocol. It's heavily used in Internet of Things kind of architectures. It is pretty low weight, low anything, but it mostly just works. So what you can get in a chassis-based switch or chassis-based router, you have multiple line cards. With that routing engine subscribed to the MQTT topic, you get MQTT messages from all of your line cards. That just goes back to the routing engine, and the routing engine then just punts that back as a GNMI subscribe response. So what we were seeing with this sawtooth pattern was an IRB interface on a Juniper box can be sharded across multiple line cards. So what we were seeing was the top line was line card 0, and the bottom line was line card 1, and you had a race condition, where the metric was basically identical for line card 1 and line card 0. So the GNMI deduper will just kind of go, it's like, well, whichever arrives first is the one that I'm going to report on. So you get a race between line card 1 and line card 0 and trying to report that IRB metric, which is why you got that sawtooth pattern. Specifically within Prometheus, what it does for the counter is it needs to monotonically increase in value. If it doesn't, it adjusts for it automatically. What that means, or what Prometheus specifically will do, is it will assume that the counter has reset, and it will sum the previous value with the current value. So that's why we got petabits worth of traffic, is basically because Prometheus is trying to compensate for what it thinks is a counter reset. So that's where we're at. The way that we fixed this problem, by the way, is by using the GNMI extensions. The GNMI extensions added the line card metadata, which was sufficient for us in deduplicating the duplicate metadata or the duplicate counters. And that was sufficient for us to kind of prevent that problem or make that problem go away. So I want to apologize for putting this on you. You're now cursed with knowledge. Such as the bane of the network engineer. But if you have any further questions, I'm more than happy to answer them.
Okay, Tom.
Questions. I'll try and be quick. Thank you very much, Tom. You've actually brought back several flashbacks. For me. Yeah, no, it's been fun. I had a question, 2 questions, I think, in particular. In terms of intervals, how are you handling the kind of replacement for SNMP traps?
So we get, we do a 15-second interval GNMI subscribe. So that means that every 15 seconds we get counter updates from the router. And we do a scrape from Prometheus every 7.5 seconds. Because basic sampling theorem, we need to get 2 for whatever value. And that works pretty well. The routers seem to be able to keep up with that pretty well. And for us, that is like that 15-second-ish delay is perfectly fine.
Perhaps a bigger question then. That's quite interesting. Thank you. The bigger question then is, there are obviously a lot of problems with vendors implementing open models with their own flair, or just deciding to use their own models and coming up with random stuff. You know, difference in sending a counter out that's got bytes versus one that's got megabytes in it, and all of these things. Versioning, one of my biggest bugbears about this whole problem. How are you handling versioning of modules? Are you doing normalization?
Yeah, so that's kind of where the network tree component comes into play. Is mostly that normalization bit. The main reason why we have it in the first place is, let's see if I can So one of the things that we have is obviously kind of the default metrics that are produced by GNMI or GNMIC specifically are very verbose, and they didn't map to the metrics that we had for SNMP. To be able to do kind of an inline replacement of our metrics, we have alerting and everything else kind of set up. We needed to do swap overs, and that's where Networker comes into play. It will rewrite those metrics. It will give them the same standardized naming to make sure that everything is correct. From a versioning perspective, we rely quite heavily on GNMIC in having the protobufs and being there and working. So if that's not working, then I get to do some spelunking and figure out which code bit isn't generated properly. The GNMI extensions are kind of there as a fix. I've just not really seen vendors implement them besides Juniper. Arista is nice enough to just stick to the OpenConfig models. I've not had the pleasure or the pain of dealing it with Cisco yet, but that's coming soon. So ask me again in 6 months.
Oh, don't worry, we're going to have a conversation.
Yeah,
Thank you. Cheers.
Okay, can I ask you to be quick because we're already
You
over
can.
time?
I'm
sorry.
Hi, Tom. John Linkova, someone who's been spending some time on OpenConfig recently. Thank you very much. Regarding your point about fridges not running GNMI, from my experience, no vendor ever implements anything until a customer asks, right? So I'm wondering if you can share or just confirm my suspicion that when you started, your feature parity between SNMP and OpenConfig path was much worse than it's now, right? So I guess you as an early adopter helped everyone in the room who is not yet running GNMI to start thinking about it, right?
Yes, 100%. It's like if your vendor does not have a GNMI implementation, go yell at them, grab their throats, strangle them until they actually agree to do this. Please, dear God. It's like, I want to get rid of my SNMP implementations. 100%.
Hello, Andrzej Zajček, bear developer. I first think I looked at Google for the GNMI RFC, and I don't find any. It's not standardized.
So it's not an IETF standard.
Yeah,
it's
so why
within
should
OpenConfig. They have their own kind of working group,
Exactly.
and that's.
So
But
why
it's a standard.
So why should I use proprietary solution instead of standardized?
It is not a proprietary solution,
Yeah.
right? Like the OpenConfig group is an open source community in the same way that we have a vast majority of other open source communities out here. It's just that the protocol itself is not standardized through the IETF, but there is a standardization system in place for GNMI that works within the OpenConfig group.
Hi, I'm Ramsey from Meta. So thank you for bringing more love to GNMI. Yeah, we are on the same path. So I'm actually curious how hard and difficult it was to change from SNMP to GNMI at the moment. And is the road finished yet?
So I used to have luscious brown hair. It is now luscious brown and gray hair. I think that is indicative enough. Yeah, it's a pain. There is massive upsides, right? There is significantly more metrics that we can get out of GNMI than we can get out of SNMP. It's just the consistency isn't there yet. We're heavily trying. We're not finished. We're slowly rolling things over. But what we're doing is when we're rolling over, we're also immediately adding a bunch of new counters in GNMI that we weren't getting out of SNMP. So it's a multi-prong effort in trying to get things going, but I suspect that's going to be at least another year or two before we can get rid of SNMP entirely.
Yeah, same. See ya.
Rüdiger Volk, retired.
Okay.
Who is that? When did you start to use GNMI?
So we did a first eval of GNMI in 2019. It was not mature enough at that point in time as an ecosystem to use it. We then started reevaluating it in 2023, which is when we noticed that there was significantly more kind of options and community support out there. And that's when we decided to pick it up and actively start engaging with the community and engaging with GNMI as a solution.
My understanding is that, well, okay, the part that was used in the MIPS, OIDs, and so on, is essentially replaced by young models when you are using it.
Yeah.
Kind of the IETF thinking, about progress away from SNMP, which started very much 20 years ago in RFC 3535, was actually first do the access protocol part, which means netconf and restconf later. And kind of the young part actually came later. I wonder whether you can make any explanation of what you are looking for or not on the netconf part, because that has been evolved over the past few years a lot. And my understanding is that when you started to use GNMI, actually netconf and restconf were actually already quite solid.
Yeah, I mean, netconf is very solid. We use it extensively, especially for the configuration side of things. It's just that I wasn't involved in the developing of GNMI, given that my employer wasn't Google and they built it. So why they picked Yang instead of netconf, I can't answer. The big thing with Yang that you don't have with netconf is standardization on what something should look like. Netconf does not prescribe you what BGP configuration needs to look like, for example, right? That's kind of entirely separate from netconf. Netconf is your communication protocol.
Rudiger.
Yeah, well,
Rudiger.
netconf does not define the model. The model is done in Yang, and that is kind of a pretty hard thing. Yeah. And will take some time, but I'm sure it will deliver.
Oh yeah, we'll get there. It's just going to take 20 years easily, but you know, that's fine. Like it's like IPv6 adoption.
Yeah, we have a quick question here from.
Yeah, so there is a question for Said Najib. Is the all vendors are support to work with this protocol?
So the major vendors out there, right, from the big four, big three, they all support GNMI in one way or another. Like I said, Juniper is the only one that I know that does GNMI extensions. MikroTik, I don't know, and I know that's an important platform, so I don't know if they support GNMI. If there's anyone, there we go. The answer is no. But you know, if there's anyone from MikroTik around, please implement GNMI. That'd be appreciated. But yeah, like the vendor support is significantly lower than SNMP. Like I said, fridges support SNMP, and they're not going to be doing GNMI anytime soon.
Okay, thank you, Tom. We're way over time, but this was interesting. Oh, it's okay. Now, before going to the break, please remember to rate the talks, because that's your way to let us know if you liked this or if you didn't, and give us a way to improve for the next meetings. So at the top of the hour, there's the next session. See you then. So let's bring these back.
Okay. Can I? Yes. Please. Let's get started with this session, please. Everyone come in, find your chairs. We have plenty chairs. Doors will close any second. Dirk is the first one, right? Dirk is the first one, right? Yes. Excellent. Okay, come in, come in, come in. And I suggest we start on time so we can actually get out on time again. So, welcome to day one, to the afternoon plenary session of RIPE 91. I am Franziska, and together with Antonio, we will chair this session for you. We will have 2 full presentations and 3 lightning talks for you today. So I hope you enjoy it. And without further ado, our first speaker is Dirk from Randburg University and IDN Labs. And he will talk to us about how we're going to pave the way for post-quantum cryptography for RPKI. Dirk.
Hi everyone, my name is Dirk. I recently did my master's thesis at Radboud University and with the people of SIDN Labs. Right. So the topic is post-quantum crypto for the RPKI. Let's get started with a quick introduction or recap of what the RPKI is. So the RPKI is a hierarchy of CAs, resource certificates, that are owned by resource holders. So these contain statements like this company can control the following internet resources. At the leaves of this hierarchy are then assigned objects, such as ROAs, that are verifiable statements about what some company wants to happen in routing. These certificates and signed objects are then published in the repository and downloaded by all verifying validators that verify them, and then expose the verified results to routers that make secure routing decisions based on this data. So all of the signatures in the RPKI are currently RSA signatures, and this goes for certificates, for the signatures on signed objects, as well as for the communication between CAs and between CAs and their repositories. So there's been this fear that RSA, of course, will be broken by sufficiently powerful quantum computers. And as a consequence, people have been trying to prepare to switch to post-quantum cryptography. In some applications where confidentiality is important, there's good progress on this. So for example, TLS encryption can already use post-quantum crypto. And in these applications, it's very urgent because someone could store encrypted data right now, then wait for 5 or 10 or even 50 years, and then finally decrypt this data and then get to your secrets. Other applications don't need confidentiality, but integrity. Some examples of this are DNSSEC and TLS, or at least TLS authentication. So this is much less urgent, but still there's some progress going on because these are not simple protocols to change. And for the RPKI, that's one more example where integrity matters and confidentiality does not, but there are nothing until now has been done. So some of you might wonder, and some have even already asked, why should we worry about the RPKI right now? And the simple answer is because migrating will take years, many years. And we know this from experience. So for example, in DNSSEC, there's this graph chart from my supervisor, Moritz, about how long it took to introduce elliptic curve crypto for DNSSEC. So you can see it takes roughly 5 years between the initial draft and the first elliptic curve signed domains popping up. So if we assume that, for example, it takes 10 years before we need post-quantum crypto in the RPKI, then now seems like about the right time to start actually thinking about that. Second, there's this interesting difference between applications like DNSSEC or TLS authentication and the RPKI. So in many applications, if you can forge signatures, that means you can drop one layer of protection. So in DNSSEC, if you forge a signature, that means that you can essentially downgrade to plain DNS. Whereas in the RPKI, we will see that it can actually be much worse than this, which makes it more important to think about this. So let's assume for a minute that someone can actually create forgeries. Then the obvious attack would be you can forge a ROA that allows some malicious BGP announcement. So with making one ROA, you can make your malicious BGP announcement ROV valid, so then it can bypass route origin validation. But actually, there's a worse attack that you can do, which is using revocation. So by forging a certificate revocation list that revokes legitimate ROAs or even entire CAs, you can actually make all current announcements, legitimate announcements, become ROV invalid. And then making your own ROA that allows your malicious announcement, you can have this announcement be the only option that's considered, so it doesn't even have to compete with legitimate paths anymore. So this way you can actually weaponize the RPKI when the crypto is broken to be worse than BGP without the RPKI. And of course, something similar can be done where you don't make a ROA for your legitimate, your malicious route, but an A0 ROA to make everything unroutable. And similar attacks can be done using ASPA. This thing keeps skipping 2 pages. So we've assumed that making a forgery is possible, but actually forging a signature does not guarantee that you can also get your forged objects to be validated by relying parties. So how do you make this happen? There's 4 ways that are listed here, essentially in order of how easy they are. So first, there's the option to make a forgery of an RFC 6492 message. This is essentially a certificate signing request, which is used between a CA and its parent. So if you can forge one of those, then you can actually request your parent, such as RIPE, to make a certificate that gives your malicious key the resources of your victim CA. So this is a simple way where in a single signature, you can take over an entire CA. Next, if this doesn't work, you can forge actual RPKI objects and then get them published in a CA by attacking RFC 8181. So similar protocol for messages from a CA to its repository. So this is somewhat harder, but it can still work. Then an entirely different attack is by attacking a web interface, such as RIPE's RPKI dashboard. Of course, if you can steal a session there, it's quite easy to make ROAs for whatever you want without actually needing to forge RSA signatures at all. And finally, the hardest way, which is forging RPKI objects by hand and then not injecting them in a repository, but injecting them in the traffic from a repository to a relying party. So for example, you could try to downgrade this connection from RDP to rsync. Rsync then is not encrypted, so there it's reasonably easy to inject something. But keep in mind, you would have to do this on the traffic to many relying parties to actually make an attack work. So it's not as easy as it sounds. So now to my thesis, how can we protect against this? So first, this attack that works by attacking the web interfaces of, for example, RIPE. I leave it out of scope. There's very smart people that are figuring out how to secure TLS, for example. It needs to happen, but I don't focus on it. What I worked on is actually RPKI objects themselves, so the RSA signatures. And finally, there's the RFC 183 protocol, which essentially manages the authentication of messages between CAs. This is somewhat easier to replace than the signatures in the RPKI itself, because it's only local. But there's still something missing there, which is a way to replace the trust anchors that are used between these parties in band. And this is an issue that Tim Bruinseels has already brought up at the IETF a couple of years ago. So as part of my thesis, there's 4 topics that I go into. First, what signature algorithm can you use to replace RSA? And similarly, what is the performance impact of making this change? Then I propose a way to mitigate a large part of this performance impact. And finally, there's the question of how do you actually do an algorithm migration in the RPKI. So first off, let's see what post-quantum algorithm would be suitable. NIST has done a competition that where 3 signature algorithms were standardized. And there's a second competition for additional candidates that also has some more options. These options all come in 5 different security levels. And it turns out that the level 1, the lowest of them all, is actually sufficient for the RPKI because it's still stronger than RSA. To be safe, if one of these new algorithms turns out to be broken, it's a good idea to still use a hybrid. So combining traditional crypto with post-quantum ones. And then we're on to the most interesting part, which is performance. So there's 2 criteria. There's the size of both signatures and public keys, and verification speed. For size, it's good to keep in mind that post-quantum signatures are almost always much larger than their traditional counterparts. And the RPKI consists of many, many signatures and also many public keys that are all downloaded by every single relying party. So increasing the signature size by a little bit actually amounts to quite a lot of data that has to be downloaded. So to get an idea of how big the impact of this change would be for a given algorithm, I did a baseline measurement of how long it actually takes to download all of this data. So when using Routinator, when you measure only the amount of time it takes to download RDP snapshots, so only the snapshots, that excludes a lot of constant delays like setting up sessions or waiting for repositories that will actually time out. Then I got to roughly 14.5 seconds from a Dutch data center. So this is a somewhat optimistic thing, but the idea is that if the size doubles, then the time spent is 14.5 seconds would also double. Similarly, for verification speed, every single validator will periodically verify every single signature. So this you could also measure. Again, in Routinator, this turned out to take roughly 13 CPU seconds. And again, if signature verification for a single signature becomes twice as slow, then we expect it to also become twice as slow for the whole bunch. Now, keep in mind these 13 and 14.5 seconds are not comparable to each other. This 13 seconds is single core CPU time, so you can parallelize it somewhat easily, whereas downloading time is much harder to do. And also, these numbers don't reflect every single relying party. So when you apply these baselines to post-quantum algorithms, then this is what we get. So this shows the total size that the RPKI would get if you use these signatures, the estimated download time, the estimated verification CPU time. And the conclusion from this table is essentially that Falcon 512 is probably the best option. It's one of the initial winners of NIST's first competition, which means that it will be standardized much sooner than some of the options further down this list, if they even get standardized at all. So they will also be available in software implementations and hardware security modules much sooner than the others. And in size and verification speed, it just performs quite well. Yeah, so I said we should use a hybrid. The hybrid component is not included in this list, but keep in mind there would be some extra overhead for using a hybrid. There's just no clear choice on what traditional components should be used there. And some of these options further down this list would also work, of course, but yeah, they're just less secure choices right now. So now that we see what impact we can expect, it turns out that there's actually a way to mitigate a large part of this, because many of the signatures in the RPKI don't actually really need to be there. So right now, every single signed object in the RPKI, which includes both ROAS, but also, for example, manifest, contain 2 signatures and 1 public key each. There's 1 signature from the CA on a certificate. This certificate then has a subject, a public key, for a one-time use key pair. And using this key pair, there's 1 signature made on the actual content of the object. So the total cost is 2 signatures and 1 public key. Whereas intuitively, you would assume that only 1 signature directly from the CA on the object should be enough. So you might wonder, why is this? The answer is revocation. So revocation in the RPKI uses revocation lists, particularly certificate revocation lists. So these are lists of certificates that have been revoked, and quite simply, they only contain certificates. Whereas this 1 signature would be a CMS signed data object, which is not a certificate. So this intermediate layer of an entity certificate that's only used once is only there to allow revocation. So that's not that efficient. So I was wondering, can we do this more efficiently? And indeed we can. The trick here is the null scheme, which is a specialized signature scheme I came up with that works essentially by still keeping an entity certificate in there. This subject public key of this certificate would, instead of an RSA public key, be the hash of the content to be signed. The signature we also still leave in there, but they can be empty. And verification is then simply comparing the signed object content with the hash that's in the public key field of the certificate. And the total cost of this per object is 1 signature and 1 hash, which is less than the 2 signatures and 1 public key. But structurally, signed objects remain the same, so we don't actually need any changes to the protocols, only an algorithm migration to the null scheme for these signed objects. So by introducing this, we can save quite a lot of size. So for example, in a medium-sized ROA, we can get rid of roughly 1/4 of the total size. When the size of signatures and public keys increases, then the savings also increase. So if we were to use, for example, a hybrid with Falcon and RSA, then we can save almost half of the size of a typical ROA. And similarly, for verification, we save a flat 35%, regardless of what algorithm is used. So clearly, when we introduce this together with post-quantum crypto, we can get the sizes quite close to what they were before or what they are right now. Over the summer, I've worked this out in more detail. So there's now an internet draft that you might have seen come by in the CDOPS mailing list. If you'd like to know more, then there's a code in the top right that will bring you to this draft. I've also implemented this in Krill to show that it actually works. So feel free to try it out, make it yourself, whatever. And then we are back to the actual main content. This is perhaps the most important part. How do we actually perform an algorithm migration? On first inspection, this is quite simple because there's an RFC that prescribes exactly how to do this, which is RFC 6916. The idea of this RFC is essentially that first we set a couple of milestone dates that are to be published in an RFC. Then we create an algorithm B version of the RPKI top-down. When that's done, so when every CA has made a copy of itself using algorithm B, then relying parties can actually switch from the A version to the B version. And eventually, when all of the relying parties have switched, the algorithm B tree can be removed. Now, this has never been used before, and I would say it's quite unattractive. I don't think it would work that well if we did try this. It has some downsides, which is, first of all, that it is top-down. This means that there needs to be a lot of coordination between every single CA here. So, for example, a member of RIPE can only migrate after RIPE itself has made its B version. This also means that the first relying parties can only switch when every single CA has also made its algorithm B version. So this coordination is just very complicated. There's also the parallel tree maintenance. So these two trees need to be kept synchronized, which is just pretty hard to do. Yeah, so all of these concerns have actually already been brought up back when this RFC was still a draft, but the whole discussion turned sour a little bit, and eventually it was published as is. Luckily, there is a quite easy alternative, which is using mixed trees. So in this scenario, an algorithm A CA can have an algorithm B child and the other way around as well, which simplifies a lot of things. So it works in essentially 3 steps. First of all, you would update relying party software. So publish updates to the software that can verify both algorithm A and algorithm B signatures. At the same time, it would be good if the trust anchors, such as RIPE, already publish the keys that they will end up using, even if they don't start using them just yet. This way, they can be packaged in the relying party update packages. And then there's a long phase of simply waiting. You have these updates published and just wait for everyone to start using these. That will take, of course, probably a couple of years, but that's fine. During this time, you can actually already start measuring whether relying parties have indeed updated. So you can see in the second little tree that there's already one CA using algorithm B. Now, this is CA wouldn't know for sure whether people will actually validate its products, but that way you can start measuring how relying parties are doing. And this is also nice for experimentation before we actually start migrating at all. So then finally, when all of the validators have updated, or at least sufficiently many, or when post-quantum crypto really becomes urgent, then every single CA can start rolling over individually, which is now just a local decision for a single CA. So they don't have to wait for their parent to go first, and they also don't have to wait for their children to go first. It's a strictly local change, which is done using only a simple key roll. So there's already a working procedure for key rollovers that is used a lot. So this makes it really easy for operators to actually do this change eventually. I've also implemented this in Krill using its already built-in key rollover procedure. So we actually know that it works quite easily, and yeah, it works like a charm. So this alternative approach has a couple of advantages compared to RC6916, which comes down to that it's just much easier for operators as a consequence of it not being top-down. So we don't have to maintain these two versions of the RPKI in parallel that both also need to contain the same data. Operators don't have to coordinate with their parents or their children to do the migration. We can already do experiments using an experimental CA even before the trust rankers like RIPE create their algorithm B version. So it's just much more flexible for operators, which is something I think operators will just appreciate and eventually would also make things move quicker. And finally, there's this nice feature that we can use this to introduce more than one scheme. So you could have, for example, Falcon as post-quantum scheme, but also some other option. so that if lattice-based crypto, which includes Falcon, turns out to be broken, there's still a different algorithm that you can quickly switch to. And similarly, you could choose to use stronger but less performant crypto for example, trust anchors or the business PKI that's used between CAs, because these are not performance critical, but much harder to replace than actual resource certificates. Wrapping those all up, I think there's a few steps we can do to prepare for post-quantum crypto in the RPI, which is first introducing the null scheme. I think that would be a really nice way to avoid much of the performance overhead that will inevitably be added by post-quantum signatures. As an alternative first step, we could also do elliptic curve crypto to try out the mixed tree migration procedure and also get some nice performance improvements in the meantime, although that will be lost when we actually need post-quantum signatures. Regarding the algorithm to pick, we should use Falcon 512 probably, just because it's one of the most performant options and also one of the most widely available ones for now. We can consider adding a fallback algorithm that's not lattice-based, or using this more secure but less performant signatures for trust anchors. And finally, when we actually do migrate, the first step should be updating relying party software, publishing the trust anchors that will be used later on, and then setting up experiments to monitor adoption of these new relying party versions. And the rest can wait for many years without any problem. That's it. So we should have some time for questions now.
Thank you, Dirk. I see there are questions. Jim?
Jim Reid, just some random guy that wandered in off the street. I think you're doing great work here. This is fascinating stuff, so please keep it up. I was a little bit alarmed, though, when you said it's taking of the order of 15 CPU seconds to validate a PQ signature. And I wonder how much that will actually translate into things in the real world. It seems to me that might be too much for an operator. Now, I'm not an operator, so I clearly don't know what I'm talking about here, but I wonder if you've got any indications from operators and the sort of requirements that they have for things like signature lengths and validations.
The second numbers I made are for verifying every single signature together. So it's not for 15 seconds for one signature.
Okay, thank you.
Although there are first and so hash-based signatures that would take 15 seconds individually, but I didn't consider those options at all.
Okay, thank you.
Hi, this is Unrea IC. So the problem with deployment, both the GNSSIG and the new post-quantum algorithms, isn't actually the standards. It's OpenSSL. It's stuff like Red Hat 8 having OpenSSL 1.1, and there's not even the provider for libOQS. So, so the reason why it took so long for ECDSA to get into DNSSEC was actually the OpenSSL, because it was so complicated to get the algorithm. And it's going to be a problem for PQC as well if we don't push OpenSSL to actually implement Falcon and other algorithms soon enough. Just look what happened with the Quick in OpenSSL. It's a complete disaster. Implementing Quick in any protocol is just impossible unless you just like bolt and glue and use a lot of duct tape, because there's no implementation in OpenSSL. It is the major implementation, and it is going to be the same problem with PQC if nothing happens in OpenSSL, because there will be no algorithm support, and the implementers will have a hard time to implement the PQC in their software.
I agree. I have to say, for like the implementations I did, there was no need to use OpenSSL at all. So there are alternatives, of course, at least for this more niche software. Yeah, I hope they do.
Franziska, we have a question.
Yes, we have a question from the chat. We are closing the queue for this one. And Michael Richardson from Sandelman Software Works asked, proposed IETF working group plans would merge CT, CL, and CRL signatures into Merkle tree. Will you look at whether this would help with RPKI?
That's tough. I have not.
Oh, you can find Michael online.
I expect
also.
that big changes to the RPKI are probably not realistic, which is also why this no scheme proposal, like it's not the most efficient, but it's easy to introduce. So I think simple is important.
Okay, last question, Marco.
Marco Ditri from CWeb. You are arguing that we need to start now using post-quantum crypto for RPKI because updating DNS resolvers takes a lot of time. But I think that this is an invalid assumption. Updating RPKI validators will take much less time because there is a really tiny number of validators, maybe 1,000 over the world. So I think that there is no hurry right now to use post-quantum crypto for RPKI, and we can maybe wait for more analysis and better standardization of the algorithms and better libraries. Thanks.
Yeah, so I would recommend indeed to wait for a little longer. I have seen some charts of how long it takes for new RPI validator software to get deployed. It's not actually that fast. So think a half-life of 2 years. So that's still a couple of years. You could hurry it, of course, but yeah.
Thank you. Thank you, Dirk. Okay, we have now BGP and DNS, our main topics for us, and also for Lefteris, I guess. My friend Lefteris, monitoring root DNS prefixes.
Hello, everyone. My name is Lefteris. I work for Cisco Thousand Eyes as an engineering technical leader. For the people who might not know our story, we are a group of researchers from Crete, Greece, that we dropped research in late 2020. We started a startup that did BGP monitoring, named Code BGP. And this startup got acquired by Cisco in August of 2023. This presentation contains a project we started while at Code BGP in January of 2023. And it's about monitoring root DNS prefixes. Before I delved into the topic, I need to speak a bit about BGP. BGP, as we say, is the glue that holds the internet together, but it's vulnerable to attacks due to various reasons. One reason is it's a specification that dates back to the late 80s, where the internet was comprised by research institutes, universities, and entities that essentially trusted each other. So there was no inherent need to embed security into the protocol. I mean, a lot of things have changed since then, of course. The advent of RPKI, ASPA, and many other things make BGP more secure, but we still have issues. And also, I need to say a few things about what are the root DNS servers. They are the authoritative name servers for the DNS root zone. Essentially, they are the core of the DNS system. And we have 13 such, 26 essentially, including the 6 prefixes that are being announced by 11 operators all over the world. One question is why monitoring them? There is one reason that I have not included in the slides. As I said, we were a small startup from Crete, and we wanted to detect events because we wanted some visibility. That was one reason. But also because it's critical internet infrastructure worth protecting. And also, since these prefixes are heavily anycasted due to the nature of DNS, we were expecting that any exact prefix hijacks would have limited impact on the data plane because due to the nature of BGP, like forwarding only hiding all the paths and showing only the best paths, only the area of the hijacker, of the exact prefix hijack, would be affected. That was our hunch. It's quite easy to alert on such events because essentially you identify the covering prefix of the IP address of each root DNS server IP, and then identify the ASN that announces it, and then you create a rule that says that if I see in the BGP updates as origin any other AES other than the AES that is supposed to announce this prefix, alert me. The only exception to this rule is VeriSign, because VeriSign uses a unique ASN per node. It is described in detail in RFC 6382, what they do. The reason they do it mainly is for more granular monitoring, because they know for each ASN where they use it in which location in the world. So if they see any hijacks, they know exactly where it happened. But this is quite interesting, and also it's interesting how the visualization of this announcement shows up in the Thighs on Dice platform. It looks like a mushroom, essentially, and I wanted to share it with you. On the left-hand side, we see the monitors that see the prefix of A root in this case. After a number of hops that are hidden in this view, we see the AES, which is the core AES of VeriSign, AES 7342. Right next, we have all the AESs that are used in all the nodes by VeriSign. And on the right side, we see the V4 prefix of A root. So now I'm going to start presenting the events that we detected. We started monitoring on January 15 on 2023. A few weeks later, AES 2424028 appeared as origin of the V6 prefix of the Internet Systems Consortium. I want to say that I have deliberately not included names of companies in the AES, only the AES numbers, because the goal here is not to name and shame. The goal is to raise awareness mainly. This event was visible only by one RIPE-RISC monitor residing in Singapore. And the reason I assume is that due to the fact that this V6 prefix is covered by AROA and RPK AROA, the propagation of this announcement was very limited. On February 25, 2023, we had an event that was slightly more interesting. AES 17639 appeared as origin of the V6 prefix of the Internet Systems Consortium again. On the same date, same timestamp, everything the same. The same AES also announced the V6 prefix of VRoot of NASA, and this event served as an experiment on the real internet on how RPKI can impact the propagation of announcements, because in the eRoot case, the blast radius of the event was 3 times larger compared to FRoot, and eRoot is not covered by AROA, FRoot is covered by AROA. On June 12, 2023, AES 201333 appeared as origin of the V4 prefix of RIPE NCC. I must say that for all these events, we were informing the network operators, the root DNS operators, that we have detected these events. In some cases, we didn't get an answer. In other cases, we got an answer. We're looking into it, but the issue was not resolved for hours or days. In the case of RIPE NCC, the good folks of RIPE NCC replied immediately. Essentially, this event was visible only in Italy. It had a local impact, and it was a misconfigured host stripping the AES of RIPE NCC and propagating the announcement. They withdraw the prefix from the specific host, and the issue was resolved. And on April 28, 2023, AES 137661, an Indian network, appeared as the origin of the V4 prefix of ICANN. We will focus on this event a bit more because it's quite interesting. The first thing is that this announcement has a very long AES path. It's 11 hops long. Due to the fact that one of the AESs is prepended 7 times. That's why, at the time of the detection, it was only being picked up by one monitor of code BGP back then. Nothing else. We were using the RIPE NCC monitors as well, the BGP monitors, the RIPE RIS dataset, and our own monitors. Only one monitor was picking it up. Also, the super prefix was being announced by the same AES. The super prefix of this specific prefix also belongs to ICANN, and it was being announced by the same AES, and it was not being picked up nor by RIS or our own monitors. I was only able to see it in looking glasses, such as the one of Aurelion that I have screenshotted here. So I started monitoring the AES itself to see exactly what they are doing, what they are announcing. So they were announcing various prefixes. The only prefixes that were prepended 7 times were the 2 prefixes of ICANN, which I found quite interesting. So this AES was announcing these 2 prefixes to their upstreams, They had 2 upstreams, another Indian network. This Indian network was propagating the announcement to AES 9498 to Bharti Airtel, one of the big networks from India. And Bharti was propagating the announcement to all their public peering points, essentially to all the locations where they had presence in IXPs. And here we can see a screenshot from Link's Alice looking glass. All the IXPs were propagating the announcement, and that's how I was picking it up, except from DECIX, because they were using essentially routing security hygiene, and they stopped the announcements that have illegal origins using IRRDB data. So I should mention, as a notable exception, that DECIX was not propagating that announcement. As I said, it was picked up only from our monitors initially, because later, throughout time, it was also picked up. It was also being picked up by a few RIPE RIS monitors, but initially was not being picked up by anything else other than the code BGP monitors. And this topic is a well-known research topic. Research has shown that carefully crafted hijacks to avoid detection by public sources is feasible. So we have had simulations in the paper that I mentioned in this slide, which was authored, by the way, by one of our master students. It is feasible, but this was shown only in simulations. We have not had examples on the real internet of such events, but apparently they exist. It's not just theory. And we stopped monitoring on August of 2023 because the company got acquired and the core BGP platform got decommissioned. We started monitoring again on the summer of 2024, and the event was still ongoing. This is how the visualization of AES paths for this event is visible in the Thousand Eyes platform. You see how the legitimate path is withdrawn in favor of the illegitimate one. And it was being picked up only by 2 monitors again who reside in India. No other monitor was able to see the event 1 year later. And also, now that we are with Thousand Eyes, one of the cool things, when we joined, we were thinking that and also before when we were at Core BGP, when we wanted to talk about data plane impact, we had no data because the Core BGP platform was a pure control plane platform. So, I mean, we were saying in blog posts that we assumed that the impact on the data plane would be negligible due to the anycast nature, blah, 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 of the announcements, since they have so low visibility. But now with Thousand Eyes, you can measure and see exactly what is the impact. In this case of this announcement, only 3 probes in India that belong to Thousand Eyes, 3 cloud agents as we call them, were forwarding queries via the offending ASN. So again, the impact of this event was limited only in India. And lastly, the last event we detected, it was on June 20 of this year, of 2025, whereas a Peruvian network, AES 3132, appeared as origin of the V4 prefix of ICANN. And we will delve more deeper on this event since we have more data now. The event was seen only again by 19 out of the many hundreds of BGP monitors. Therefore, the visibility of this event was also limited. And here we see again how the prefix is withdrawn, the one with the dots, the dotted line. The legitimate path essentially is withdrawn in favor of the illegitimate one on the timestamp of the event when it happened. In the BGP updates table that we have developed using the BMP protocol RFC 7854, we can see that the AES who is picking up and propagating the announcement is AES 3356 Lumen. And as I said, now we can measure the impact on the data plane. And since we're talking about DNS, root DNS server prefixes, the most suitable test is a DNS test. Essentially, you query a .org domain because LRoot serves, among other domains, .org domains. In this case, I use wikipedia.org, and select the LRoot IPs as lookup servers. And your goal is to create an alert rule and see of all the paths that you get from the 1,000 probes that we have, cloud agents we call them, all over the world, how many of them are impacted, how many of them forward traffic towards the LRoot v4 prefix through the illegitimate AES. And you might wonder, why do you care about this? I think most people would know that, I mean, we have no information on intention, but when it goes through an AES that it's not supposed to, this AES can eavesdrop, can manipulate DNS queries, especially since they're not encrypted in most cases. So it's not great, I would say. What we detected is that out of the 1,000, more than 1,000 probes that we have all over the world, 104 of them were forwarding DNS queries via the offending ASN. And let me go back a bit. Can I? I can't. In this case, I managed to speak with the ICANN people in ITF in Dublin. They identified the event. It was again a misconfiguration. With the withdraw the prefix from the host, the issue was resolved, and they told me that the actual impact on traffic, because they have traffic data, was 3%, was not 10%, and it was not a malicious event. Essentially, it was a misconfiguration, but in any case, I had to inform them. So to conclude, RIPE NCC has a very intuitive and easy to use interface for creating RPKI ROAS. It's very easy to do. For the people who have not done it yet, they must do it because, as I've shown, it protects a lot your prefixes. And also, I mean, in BGP, the more you look, the more you find, as we know, and there's need for quality BGP monitoring. Thank you very much for your attention, and I would love to hear your questions.
Thank you very much. And You can ask questions online via Miteco and in the room, and we start at the microphone here.
Rüdiger Volk. Hi, Lefteris. Let me first put a question and then actually comment on the question. Did I miss anything beyond detecting that an unexpected AS origin showed up in the roots for triggering your evaluation that there is a hijack?
No, you didn't miss anything, I would say.
Okay, so kind of one wonders how much, well, okay, how much that actually buys. That means that an attacker who actually wants to go under the radar of your system just has to fake the origin AS. And we know there is nothing that prevents fake ASs, fake origin ASs in the current routing system. Maybe when ASPA is around, kind of the faking of the origin can be not that easily subverted, but kind of any serious attacker quite obviously has a free way.
I mean, given the fact that not every network does BGP filtering and not every network does RPKI correctly, yes, you're right. There is a chance like this. That's why I mentioned that although security has made advances in BGP, we have a way to go.
Okay.
Shane Kerr, IBM. So we have a lot of technologies which can protect against the impacts of such hijacks, right? So DNSSEC will protect the data. QNAME minimization will protect the identity of the users from traffic. Potentially things like authoritative DNS over TLS could even break anyone who's hijacking and prevent them from using this stuff. So now you're looking at like RPKI. Where do you think the community should be focusing its efforts? Like, because we have the technologies to fix this.
I would speak on behalf of BGP because this is my area of expertise. To be safe, we need a combination of RPKI, ASPA, and BGP-SEC, which, I mean, I say it and many people get, get sick. I mean, we need protection both on the origin, on the first hop, and on the path, essentially. And I mean, BGP-SEC might not be the answer because I also have concerns, but this is what we need to do. And I'm not sure when we're going to be able to achieve it. Maybe it will take decades. Yeah, but until we do it, this is the current state.
Thank you.
Next microphone question.
Hi, Lars Lehmann from NetNode. I'm sorry that I missed the first part of your presentation due to an alarm system at home. Just one quick question and a comment. Quick question, have you seen any problems with the root servers who actually do have ROAS for their prefixes?
Yes, I have.
I suspected that, so thank you for confirming that. The second thing is that you have an old IP address for broot. It's changed. Broot has a new IP address since probably a year and a half back.
Yeah. This was a monitoring that took place in the early 2023 when broot had not made the change yet.
Thanks.
Okay. Any more questions? Do we have anything online? Okay. Then, thank you, Lefteris.
Thank you.
Okay, now we start with a round of 3 lightning talks. The first one is by Simone from MLab, and we've seen them here before. It's always interesting to follow development of a project that we see over a couple of years. And today we will get an update on host managed deployments.
Thank you. So my name is Simone. I've been collaborating and contributing with Measurement Lab as an external researcher for a long time, and recently I joined the team. So yeah, the topic today is basically first MLab, Measurement Lab in general, and then host managed deployments. What is it, and how it is a solution that can help us, and where you can contribute to the MLab platform in an easier way. So about MLab, we are an open source, non-commercial project, and we have this worldwide fleet of servers, and the objective is for researchers to deploy their internet measuring experiments on Measurement Lab. And the idea is basically that researchers write their clients, and clients measure towards the servers, application level traffic mainly, and then collect the data and publish it. And the code must be open source, and the data is published as open data. Now, there are several experiments on MLab. I actually, during my PhD, deployed one, but the most famous one is NDT, the network diagnostic tool. And NDT is a sort of a speed test plus, in the sense that it collects low-level data as part of the test, so you can correlate what you have seen at application level with packet headers and TCP info data. The success of NDT is also related to the fact that the client has been integrated by several organizations. The most popular integration is the Google search integration. So when you write how fast is my internet and then tap the blue button, you end up running an NDT test that collects MLab data. There are other integrations. Airbnb has integrated the client. UNICEF's Giga project has integrated the client. Uniprobe has integrated the client. Collectively, over the last year, all these integrations were running 3.5 million download tests per day, on the average. Now, the data is open data. I want to go through this slide really specifically. It's just know that you can access the data through BigQuery or directly through Google Cloud Storage. You can download it. And you can go through it if you're interested, and there are instructions and suggestions how you can inspect the data. Let's move on to the platform now. So we have here the geographic distribution of the MLab servers, the servers against which client test. We have more than 500 servers globally. We currently manage the servers, and this means we have deployed over the years servers in ISPs, IXPs, academic networks, transit providers, and cloud. And that's where we stand right now. But let's go towards host managed deployments. So we have coverage gaps. And those coverage gaps reflect the way in which MLab has grown. And so, for example, we have some gaps in Central Asia. We have some gaps in North Africa and in the Middle East. And this is where we started thinking, is there a way for us to scale faster? Is there a way for us to ask help to the potential community, including you in this room, to have more servers, so to have more capacity where we already have capacity, and to create capacity where we don't have capacity? And the answer is this host managed deployments project, where we tried to shift the model from us managing the servers, sending the hardware, and basically so managing the hardware and the operating system, to the organization that wants to contribute, that provide the servers, and we provide the software means to attach this server to Measurement Lab. The way in which it works is significantly simpler than the previous model. So the organization that wants to host a server registers and they get an API key. What they need to provide is a server, physical or virtual is good, IP addresses, obviously, a minimum of 1 gigabit per second, uplink, and then very kind of minimal, small specification for the hardware. And then by running a Docker container that we provide and an API key, this server becomes part of the platform. We started the pilot for this project in 2024 with RMP, which is the research network in Brazil. We are also now starting to experiment with host-managed deployments in India. Our goal is for next year to have this solution to be completely available. Before closing, I wanted to mention that beyond benefiting MLab itself, hosting a node benefits also the organization that has the node. And the reason is that the way in which MLab tests works is that they spray clients' traffic. Well, a client is going to test against one of the few servers near them. This means that on the other end, from the client side, so from the server side, the organization sees traffic not only from its own users, but from several users. And indirectly, this gives them information about how good their interconnections are. And my colleague Matt is working on an automated methodology to detect this at scale and provide this information. So with that said, this is basically the end. Here's my call for action. Help us scale MLab. Talk to me. I'm here today and tomorrow. And then I left their documentation in forms of a link and a QR link that you can use to inform yourself and know more about this project. And with that, I'm happy to take your questions.
Thank you, Simone. Any questions for Simone? Maybe online? No? Not yet. Okay. Thank you, Simone. Thank you. Now we have another lightning talk. Christoph on residential proxies, a double-edged sword for network research. The floor is yours.
Hi, yes, so my name is Christoph Visser. I am from IAJ Research Lab out in Japan. And today I'm going to talk, well, I guess it follows up quite nicely after Simone's talk about residential proxies and a little bit of what they are and how they could be very useful for network research. But there is some concerns about them in my point of view. So ideally for us as network researchers, operators, it would be great to have a perfect view of the internet. There are currently, so this is a couple of months ago now, but like 54,000-ish ripe atlas probes. However, only about 13,000 of them are connected. But you know, what if we could have 150 million plus vantage points all around the world in places such as Wallis and Futuna, North Korea, the Vatican, etc., and just have that available for us to give us a perfect idea of what the internet actually looks like. So this is just a dumb little meme to make that, you know, ripe atlas is over, same as MLab now, I guess, and things. And we should just use residential proxies instead. Surely, that with that many vantage points, how could you not? But we also started to have a thing like 150 million plus from one provider out of many. Where do these IPs come from? So with a ripe atlas probe or with the new MLab hosting things at home, you are required to have explicit consent. Like you need to actually install the probe and register it, etc. So there is a very explicit consent to that. These proxy providers are murky, to say the best. So there's kind of 3 layers that we put it in. So the first is through like mobile apps or on your TV. They incentivize people. So this would be, for instance, if you play a game, hey, if you want some extra lives, agree to this, and their terms is share your IP and some of your bandwidth to get access, or it removes ads. Or it can be on your smart TV to get multiple backgrounds of a fire burning log. So these are the ethical ones that on how they get consent for that. Some of the more gray area ones come bundled in with free VPNs or apps, and it's somewhere hidden in the terms of service. You don't actually know that these services are running at the back of it, but they're there. And then there is the more malicious ones. So these get spread through the likes of malware, botnet, very popular. There was for piracy content that was repackaged. They included some of these residential or these proxy clients there. And I'll get back to that one in a sec, because that comes from a real example and kind of a big thing that started this conversation. And I showed some of the examples from this is from the same YouTube video of the ethical IP. So this is kind of the interface that you're looking at to accept to be part of this. And one of the things that they actually highlight as part of the YouTube video is that people can agree to this, go out of your app and never use it again, and it will always be running on your device. And for the developers, they get passive income from there. But from the end user, they have no idea this is still going on. So those are, yeah, even the ethical ones have some questionable actions through that. And that's only from the ones I've been able to actually find out how they get these. But then the other issue is, do you actually know if there's any residential proxies in your network? Do you know if you have, this could be a residential proxy, this could be one. I don't know, because part of the way that these are implemented is they look like and act like normal user traffic. That makes it extremely difficult to single out. But for researchers, there's some nice benefits. This can be used because you've got real in-home point of views. You can use this to characterize like how CDNs are deployed, get a real-world network topology, and you can look at what internet censorship looks like between places. But the big place where they actually make their money is in the likes of enterprise. Most importantly, in the last couple of years especially, has been web scraping. Some people want to do price comparison or look at products, but AI training is definitely the biggest one there. Gets around all of your rate limits, etc. Or you can do it to make sure that if you've paid someone to show an ad, that the ad is actually showing where you say. Now on the right-hand side, this is kind of a reason for my talk because it came out of a discussion that was at NANOG earlier this year. And while it was not recorded, I highly recommend going to the link here to read more about the discussions there. It was about a 4-hour discussion. But they talked about this, this 911 S5 proxy service. So that was an illicit proxy service that was there, and it was being used to do account takeovers, credit card frauds, swatting, death threats, ransomware, illegal materials distribution, DDoS, etc. And it kind of brings up this question that if I can't verify this thing as a residential proxy, how can you say that? How can you link an ID or a person to an IP when they could be a victim of this? Now, luckily, the FBI did work on this, and so the people knew they were part of these proxies. But at the same time, with all of those addresses before, like you don't know if you can't even tell if there's one running in your network. So then it becomes to, I guess, like our researchers' dilemma: should we use them? And it's hard. I mean, there's pros. There's unique large data sets with millions of viewpoints all across the globe, and it's real world use cases. They have mobile proxies now. They've got them in, yeah, as I mentioned, small places that Wallace and Fortuna, for instance, that I mentioned, because I studied for the Pacific, there's a population of 11,000 people. Like having a couple of viewpoints there is massive. And so we get visibility into these hard to reach places. And they actually have, so these are from like some of the top ones there. They do have some programs, non-profits, to work with universities, and a lot of them do work with them. But then there's the con side. As I kind of just talked about before, is can you actually say with full confidence that the user has full consent that their device is being used in this way? The providers will say, yes, they are, it's all good and things. They have some certifications to say, but I've struggled to find any clear details on what those actually mean. And on the other side is, are we, by using these ourselves, are we enabling the bad actors to continue to work? But the same argument could be brought across for, say, VPNs. You can use that to access other areas, but VPNs could also be used for malicious work. So I don't really have a conclusion, so unfortunately. But I did want to mainly, and I'm actually really glad for the PC that this is at the start of the week, with us all being here. Researchers know of this to some extent. A lot of operators do not. Actually, none of these sites say they work with researchers and maybe data centers, but none of them had any ISPs or operators on there. So I don't know how many people even know about them. But I wanted to have a discussion with everyone. And I've got a survey here just to fill out, to get an idea of people's experiences and how familiar they are. Just asking, you know, are these considered ethical? Can we justify using these tools even though we can get new information in hard to reach places? However, we can't say that they're ethically sourced, even though other people will use that for web scraping otherwise. And can we, you know, how can we say that a network or traffic that you're seeing on your network, is that a normal user or is that a malicious actor using these proxies? And then lastly, of just what is our path forward? Like realistically, to give you an idea, these services charge you about $3 to $5 a gig to use their ones. So somebody just trying to circumvent a proxy restriction or like a geo-block is going to use minimal things, but it's really the AI web scraping that's funding these people. So what can we do about it? Do we need to ask for more transparency? Is there a way to have a platform of this size and scale and ethically? So yeah, so please answer the survey, and I guess for the rest of the week, I'm here and discuss with each other. Yeah, that's it for me.
Okay, open for questions. Start here over at the microphone.
I see Rudiger's in the queue, but he hasn't stood up.
No,
yet,
I
so.
think he hasn't lowered his hand from the previous round, correct?
Sure.
No.
Very simply, the first
Who
question.
are you, Tom?
Oh, sorry. I'm Tom. Tom Hill from British Telecom. Very simply, can we justify using these tools if we can't be 100% sure about their consent? No, we can't. We have, in the UK and Europe, we have laws on that define consent, end user consent. This is very, very clear in law. No, we can't.
Yep.
Not ethically. And I agree that these things are tempting because look at the data set, it's enormous. But the users, if you've buried something in the terms of service, none of us would like that to happen to us. So I don't think we can ever say that that's ethical.
Yeah. You actually touch another interesting point that we kind of discussed about, especially for here, is in a way, technically these users are leasing their IP to someone else. And that I know is more on the illegal side rather than the unethical side, but well, your customer is doing again, but they might also not be aware of it.
Well, they're subleasing their IP address then. But also IP addresses, at least in the UK Data Protection Act, are classed as personal data. So it comes back to the law generally.
Cool, thank you.
Okay, do we have anything online? Then back at the microphone.
Raffaele Sommesi, University of Penn. Hey, Chris. So very interesting presentation. One comment that I have is, even if we may agree that this is not ethical, we also need to argue that you can put really in a lot of danger people around the world by using this kind of service. Because if you try to connect, for example, to websites that are censored in a certain country, you can create a damage to the end users that don't even know what else is happening. And I mean, I remember discussing with people RIPE Atlas, one of the reasons why RIPE Atlas do not have HTTP fetch is exactly that. So by using this kind of service, you can really create damage to end users and should be aware of that.
Yes, I absolutely agree, especially when it comes to the really malicious or illegal content and stuff. Because if an operator can't pinpoint that it's a user, or it's going via residential proxy, it's a client that doesn't even know they had it that's going to be the victim here.
Yes, it is. Okay. Brian Nisbet, HEANet. We actually had this conversation with a number of the universities that use our network when they became aware of a number of them some point in the last year or so. And I mean, our answer was, so the user is one thing. It breaks our AUP to do this. It says very clearly, and we're running this public interest, academic, charitable network. You're not allowed to resell the services. You're not allowed to do any of this. So there's, and whatever about commercial ISPs, I'm, fumbling in the greasy till, sorry, etc. But from our point of view, it's like, no, I don't care what this is being used for. It is against the AUP. And also we would suggest that our users don't use them because who knows what they're doing. And even the most ethical ones in this day and age, someone might buy them, someone might change the code, someone might do a whole bunch of things. And it's very, very, very murky.
Cool, thank you. Yeah, no, I mean, that's exactly it. I want to start the conversation here.
Excellent. And we are online? Okay, then you have a week to gather more feedback.
Thank you much.
Okay, our last speaker for this session is Remco, who will finally help us say our goodbyes to ARP.
Well, it is a dream, isn't it? Hi, so everyone, my name is Remco Vermook, and this is a lightning talk about a dream. How can we use IPv6 to resolve our IPv4 gateways? But that's not a very nice title for a dream. It's very boring. So a farewell to ARPs, if you will, a single gateway. And to make sure we're all on the same page here, this is a tunnel-free presentation. We are not adding layers of encapsulation, no tunnels. Keep that in mind. What's the foundation of all of this? The foundation of modern networking, I'm sure some people in the room recognize it. Maybe some of you wrote this code. This is pseudocode derived from 4.2 BSD from 1983, I think, thereabouts, which has the AF INET socket and a connect, which is probably the most used API on the planet as of today still.
it's not going to go. It's not going to go away. Let me look at my notes. Software will be binding and connecting to IPv4 addresses for a very, very long time indeed still. But inside of your modern orchestrated multi-tenant network, what does that look like? A lot of this. Like a lot of this. Like a lot of this. Constant, noisy, broadcast-based discovery. Terrible word. So let's establish a premise for this dream. Dual stack means a lot of work. It's a lot of double work that we want to avoid if we can. Second of all, we're going to need to acknowledge that the need to communicate over IPv4 across the internet, specifically across the internet, is going to be there for a good while. And talking IPv4 to the internet is not necessarily the same thing as talking IPv4 locally. And it's going to be a very long time indeed before you have a router that, I mean, a packet walks into, an IPv4 packet walks into a router. The router doesn't know what it is. And discovery mechanisms like ARP, which actually even predates 4.2 BSD, it's just 1982 we're talking about now, is actually a very bad idea in a multi-tenant environment anyway. Your modern orchestrated network knows exactly where to send stuff. And your layer 2 network, your Ethernet network, knows fully well how to carry an IPv4 packet, you know, Ether type OX800. It's been there for a while. So the dream is how to have a network design that focuses solely on IPv6. And I never thought I'd say this. No IPv4 subnets, no ARP. You have automated, orchestrated addressing, prefix delegation. You have a design and routing fully based on IPv6. Hosts can have a public v4 address as a tag for your endpoint software to connect to your 4.2 BSDH code. The network will know how to move IPv4 traffic. We have RFC 8950, which has v6 next hops for v4 routes. There's one tricky thing about when you try to implement that across the board, though. Hosts don't really know how to send IPv4 traffic back to the internet if you try to do this. So if you distill that dream into a picture, there's a lot of good stuff going on here. And there's, of course, there's the red arrow and the question marks and the lightning bolt, because this is where stuff gets confused. And that makes it time to talk about the default gateway. The least used, most important IP address you've ever seen. In many cases on data center and ISP networks, it is the only other device that your host or CPE will talk to on a public subnet. The main function of the default gateway is nothing else than an identifier to do a MAC address lookup, ARP. And really, the value of that identifier does not matter at all, as long as the host knows which interface to use to send that request to. So what if we could have a better integrated approach? So what if we could tell hosts to simply use the same layer 2 resolution for IPv4 and IPv6, a single gateway, if you will. Have a default gateway IPv4 address that just means just go look at IPv6, right? I mean, find out what the default gateway for v6 is and just send your packet to the same layer 2. It'll be fine. And instead of everyone building their own little hacks to use this, let's just use one of the, we have a special registry that IANA maintains. So there's actually IPv4 address space that is not maintained by the RAR system. 192.0.0.0/24. So have a special purpose address that you can actually build into network stacks of operating systems to actually recognize this and say, oh, you mean this? Well, let's do this in that case. And as it just so happens, the next one available in that range is 192.0.0.11. Let's see if we can use that for that purpose. What does that do in terms of the solution? Well, it's the same picture, except that your host now has, 192.0.0.11. I know what that means. Goes talk to the IPv6 stack, and there he goes, and then off to the races. Now, a lot of you are going to come up screaming to a microphone and say, what about backwards compatibility? Of course, this is all very horribly broken, and none of this will ever work anywhere, anyway, which means that this will never happen. Actually, this already exists. Backward compatibility. Hosting providers are actually using this right now. You can use current DHCP, like Hetzner does this, which gives you a /32 IP address on an interface, gives you a host route for the default gateway, sets of course, the default gateway, and then on your router, you just configure 192.0.0.11 as a generic router face, universal single gateway IP, so it will send ARP replies. I am now out of time, so I would appreciate your thoughts. Thanks to Tobias, Phoebe, and Warren Kumari, and others so far for providing their input. There's some working code I have in the Linux user space. Any kernel from 5.2 upwards can do this, so it's been there for a while. Using RT-Netlink. This actually aligns with a lot of work that's currently ongoing in the IETF v4 via v6. Here's the GitHub, and questions, comments, let me know what you think. I'm really curious. Thank you.
Thank you. Okay, that was a race, I think. 1, 2, 3.
Okay, thank you. Lars Lehmann from NetNode jokingly, shouldn't we use 127.0.0.2 instead as the other end of myself? Never mind.
If you want to talk to yourself, you can use any address you like, Lehmann. It's fine. I don't judge.
Gerd Döring, I do like the way you're thinking, especially with it's just an identifier to look up the key bit. That will confuse the hell out of people, but it will work.
Yeah.
There's one small catch, and that is the IPv6 default gateway. Whatever is that, if you have multiple interfaces, routes, and all this stuff.
You can still do this. This works. And
it works if you have a /0 route or something that can be identified as
if you can figure out where to send IPv6 packets to the internet, you can figure out that you're going to want to use that same endpoint for v4.
Yeah, but there might be multiple ways, multiple interfaces. So
yes,
there's a fine print attached.
There's undoubtedly corner cases that you can find in very unique configurations where this won't work.
I'm not saying it won't work. I like it.
Good. Thank you.
Well, AS2613, I like it, and my question was his question. So
okay, well,
thank you very much.
In that case, I would very much look forward to all of your encouragement and positive feedback and comments on the GitHub, and let's see if we can. This is a draft, internet draft. I don't know if that's not a status. So I'm preparing this to go to the IETF. And once it's there, I would very much like to have the operators who are largely not very present in the IETF to hear what they think.
Okay, I think we have one final question. Tom, checking with you, you didn't lower your hand as well, right? Okay, Dimitri.
Yeah, Dimitri.
Closing the queue.
Yeah, thank you. One of the big IPv6 fans. That's the presentation I was waiting for. Quick question, is 11 referring to the 11th floor in a famous Scottish incident? Or should it maybe use 4
I mean, there's also a movie that basically dials it up to 11 and that makes it extra good. I don't know. You can find any reference you like.
I think
about
46, 11. Like 426 would be better, but that's my thought. Hey. Good luck.
I mean, thank you. I mean, I appreciate this. I mean, as it just so happens, .11 is actually easily memorized by people who are not deeply inside of technology as well. I don't know. We'll see.
We love numbers. This is going to be great. Okay, I think with that, we can close this test session. Thank you. And before everyone runs off, I would like to remind you, please rate the talks. Our new lovely submission system has a rating button. If you click on a presentation on the agenda and you are logged in with your NTC Access account, you can rate the presentation, you can leave comments. If they are within the code of conduct, we are actually forwarding them to the presenters so they get heard and appreciated. Please remember that you can volunteer yourself for the program committee until tomorrow, 3:30 Bucharest local time. Just send a mail with a picture and a short bio to pc@ripe.net. If you have questions regarding this, you can find the current members of the program committee all across the venue and just talk to us. And now we have a quick coffee break. And after that, in this room, we have a BOF about the current ICP2 document updates. Enjoy.
Good evening, everyone. It's 6 o'clock now. I am the impression to give a course at the university and to see if all the students are there. Because if they are too late, they are not allowed to enter the room after that.
It's not for dying.
I did that from the stage. Yes, but it was a stone floor and my feet were caught in the cable.
Wow.
That didn't end well.
So don't do that.
Everything switched on, switched off.
Okay, one more time. So good evening, everybody. So I think we can start. So you are here for both and with your favorite, I think, topic since now 2 years, which is the ICP2. Even me, before that period, I was absolutely not aware what an ICP was. And I did not know, sorry, it was an internet coordinated policy from the ICANN. And now I know. We are here because we are during the ongoing regional and ICANN consultation of ICP2. So we are here to listen from you regarding the current version of the document. We are. Just one thing I wanted to emphasize is that we are together. It's not because we are part of the NROEC that we are in one group and you are in the other group. We are all part of the community, of the internet community. And I think that we have the same goal to have an acceptable, more than acceptable document for everybody. We have a specific role as we are part of the NROEC, and we were given the task to update the initial ICP2 document, which was provided and accepted in 2001. And the other difference is that we are connected with the other regions. And so we have to converge in something which takes into account all the comments from the different regions as well. The idea, but I think some of you know what it is about. So we will have a short presentation, but not more than 20 minutes. And after, the idea is really to discuss, not us to ask a specific question or to complain about something, but really to discuss together. Thank you. Updating ICP2, that's the title of the both. So we are discussing, I have that there. On the second graph of this document is the second. So there have been 3 consultations. The first, it was regarding the 24 principles, as I can remember, about what could be this document, and 2 others consultation regarding the Regional Internet Registry Governance document. It is not called ICP2 anymore because I don't think that the final document which will be part of the series of the ICP. But just to say that in 2023, it's 2 years ago, only 2 years ago, or 2 years is a lot, I don't know what to think, but we have to converge with all the communities, so we need a little time to have something under consensus. And the NROEC, the set of the directors of the regional internet registries, ask us to update the ICP2 to strengthen, that's the idea, to strengthen the regional governance regarding the internet resource, internet number resources. Just a piece of timeline on the work we have performed. We need 1 year because there was a lot to read, a lot to discuss, to present the first document, which was the principal document, and there was a dedicated consultation between October and December 2024. After that, we review, of course, the community feedback on this principal document. And in February 2025, so at the beginning of this year, we published finally the result of the analysis we have performed. And in April 2025, the Council, the SOEC, published a draft of the Regional Internet Registry governance documents, and there was another consultation. And after this consultation, there was another part of analysis of the outputs, and we were able to, in August 2025, to publish the current document you can read currently, and which is under consultation till the 7th of November. To see all the documents I talk about, the principal consultation report, you can reach via the left QR code, the first draft of governance document via the right QR code, and you can read the current document using this QR code. We belong to a numeric world, so we use QR very fashion code to do that. And to help you to read the current document, we have prepared 3 supporting documents. The first one is a red line of change, so you can see the differences between this document and the last document. It's something like that with the new wording in blue, the deleted wording in red, so it's something very easy. You know. You have also a rational document explaining why we added some improvement and why we didn't take into account some of the comments because it was out of scope of the document. And there is a frequent asked question document as well. And the rational document is something which is like that, and it explains what we added as a notion of recognition in the document, for instance. The idea, of course, is for you to read the document and to share your input. Simply, your input can be, I am very happy with the document you share, I support. So, okay, and we are happy to read that because so we can see that finally we reach a certain goal, acceptable. But you can say also I don't agree with that, or I think it could include that also. And your feedback is vital for that because the document will be legitimate if it agrees on reach consensus within the community. One more time. So you have the QR code one more time to read the document, and there is the original document, but also at the same time an icon open consultation also. And with that, I will give the floor to Constance, who will talk about the main changes regarding, so compared to the last document. Thank you.
Thank you. Oh, thank you. Thank you. It's a small overview about the revised points in the new document. But first of all, we wanted to thank you, the community, for all the inputs we got and all the comments. And I can make sure, we made sure we worked with all comments. We have a really huge Excel sheet and we put all the comments together and we clustered and prioritized all the comments, and then we put in the new rear area governance document, the new inputs. So what we did in the revised area governance document, we have some key changes. That first of all, the title, you see this, area governance document. We changed the preamble. We had an expand of the preamble. We explaining the goals of the document and we explaining what the document not stands for. It's very important. Implementation procedures, a reference to separate implementation procedures, the document that may provide further implementation details on any obligation. So next slide. So we have key changes in the recognition and derecognition procedures. The audits and proposals for the audits, and emergency continuity. In detail is my colleague acting and providing the solutions and the new states in the following presentation. The key issue, and this is what I want to figure out, is the role of ICANN. Many people from the community concerned about the role, as too strong role of ICANN. And this I can explain now. ICANN cannot unilaterally recognize or derecognize an area or initiate emergency continuity procedures. So what ICANN is ICANN is able to trigger a proposal for a derecognition or of an audit or ad hoc audits. So this is the topic and the role of ICANN, and now we go in the detail, and this is the part of Andre.
Thank you, Constance. Yeah, let's dig a little bit into the detail. I will not go too deep to come back to you, but you can see all the details. We showed the reference to this rational summary and rational document, which contains all the details of feedback, how feedback got into the document and why, and which feedback didn't make it to the document and why. The title. It's maybe a minor change, but because it's in the title, we highlight it here. So we thought operation is actually more adequate term for how you sort of operate, not maintain the registry. So that title was changed in the document. More important change probably is a rational. In the previous version, it was a very sort of skinny rational, basically explaining what the document talks about, but it didn't set the context. And, you know, it's very tricky context. If you look at the area system, you may be confused and think that this is a top-down hierarchical system, but it's not. The authority comes from the community, right? And areas are acting independently pretty much. And I think that was one of the very strong things we heard at the last BOF in Lisbon. So we expanded this preamble. We talked about the nature of the area system. We talked about the goals, what this document is trying to achieve and what it doesn't. So please read rational and this preamble and see if it sort of sets the right context under which you can look at the document. Because for a purely hierarchical system, and you may be confused again if you look at the TLD space, for instance, at ICANN, some of the processes can be much more simplified. So some of the complexity that we see in this recognition, derecognition processes, they are related to the nature of the system. So we thought it's very important to explain that it's not complexity for the sake of complexity, but it's a necessity because of the nature of the system. There was a lot of feedback on, well, we need more detail and even suggestions on some of the details of be it an audit or be it some of the criterias. And we felt that the document should stay in a higher level. The document should provide boundary conditions for future developments, what we call implementation procedures. And in this document, we clearly mentioned those implementation procedures that have to be developed. They have to sort of flesh out the details, how certain things will be done within the boundary conditions set by this document. So we don't need to, come back and start the whole process again when we change slightly and we realize maybe some things do not work as expected. Again, read the document and see if we did the right judgment on the level of detail that is present in the document. Okay, now a recognition and recognition. So picture says more than 1,000 words. So here's the flow diagram. It's pretty sort of normal. I mean, it was in the previous version of the document. Approval is unanimous at this stage, and well, rejection as well. Or rejection doesn't need to be unanimous, of course. So if it's not unanimous approval, then it's rejection. But several people raised concerns about unanimity of that decision, both from the point of view that unanimity is hard to reach because some of the areas may have more vested interest in sort of maintaining status quo, making the system really closed. But also from the point of view, well, what if an area is unable to make a decision or make recommendation? I have to say, although I don't, maybe that doesn't make a material difference, there is no voting here. If you look at the procedures, each area independently evaluates the proposal and submits recommendation. So the sum of recommendations, it forms the decision. So if all recommendations are in favor, that's what we call unanimous. So there is no like voting at the table in a closed room here. Now, for this, the procedure was amended, and that's what we call reconsideration review. So there is a provision where an area can be recognized with less than unanimous support. And less than unanimous support, there might be one dissenting view from one area. And we're considering a scenario where, for instance, significant part of the membership of the existing area goes to another area, so there might be a vested interest. And for this, there might be a situation where maybe judgment may be affected by this thing. There was also, and yeah, let me show another picture with this consideration, recognition, review phase. That maybe employing a third party, independent third party, is a good thing to review sort of this assessment of the area. So if there is one dissenting area, there will be an independent commission that will review the judgment, and if there is a material error or unfair judgment, then there will be a reconsideration phase. And after that, there might be a rejection. So there might be a reversal when the opinion of dissenting area, if there are material errors or unfair judgment, can be overridden, and therefore recognition can be made with -1 area. So that's the proposal for the new, more complicated process that will allow some dissent. I have to say, before I go to this recognition thing, that you might think, yeah, well, it's not that easy to become an area, right? But I don't think we want to make it easy to become an area, because there is a huge cost of this coordination, of cooperation, keeping this global system, collaborative and cooperative and acting as one single. So we need to think of this cost and really sort of set the threshold pretty high. So not totally closing this up, but setting this high. So really, then there's real necessity, then the area can be created and club can be extended. Oh, sorry. I hope you saw the picture. I can't go back for some reason. So that's the recognition proposal. There's not much change there. We left the unanimous decision because it's a big decision, of course. So, well, apart from the area that is being derecognized, all other areas need to make a unanimous decision on derecognition. What was added here is that well, minimum requirements for the recognition proposal, that they should be rational. It can be just, well, I would like to de-recognize, so they should be rational, and this should be public. Response, there should be an opportunity for area to public response to that proposal, and transparency. So when decision is made, all rational should be public. So we want to make this process as much transparent as possible, so community, where the authority comes from, can actually independently review whether those decisions were made and how. Also, what was added, that there is a new threshold for members for initiating the recognition proposal. Now, membership of an area can initiate the recognition proposal against this area. And there is 2 thresholds, 2,000 to 25%. Why is that? Because different areas have different membership structures, and member definition of a member is different in different areas. So to sort of make a more fair comparison, we made these two thresholds for that process, for this trigger. It also allows ICANN to initiate the recognition process. That was also a request from the community that in some situations there may be some impasse or inability for areas to trigger that proposal for whatever reason, so maybe ICANN should do this. Now, I have to be very clear that here we're not talking about the derecognition by ICANN, we're talking about the triggering of the whole process, so the sort of this out left of the diagram that I very briefly showed to you. Audits, that's another thing that was added. And there are two types of audit. There are regular audits and there are ad hoc audits. And I think they're a very important component for the whole thing, because we don't want to get to the derecognition. We want to capture problems as early as possible and be able to rectify them. So periodic audits, so there is a certain cadence of audits that areas should do. I think it's 3 years now. At least one every 3 years, so pretty frequently. Yeah, so we can maybe capture this earlier, the problems are identified early on. There is a possibility for ad hoc audits. They're not built in the recognition process, but it's pretty clear that maybe ad hoc audit will be requested for that if necessary. So there might be other areas that can request an ad hoc audit. Again, the same thresholds, 2,000 to 25% of the members of the area can request the audit of this area, and ICANN can request an ad hoc audit. And why we did this? Because really, well, ad hoc audit can be, it's not cheap maybe, but we don't want to raise the threshold of triggering this audit too hard, because it's counterproductive. We want to detect errors as early as possible, right? So if there is a reason to believe that, yeah, there is something wrong going with this area, I think we want to have this ad hoc audit. So there's a possibility, we haven't passed the point of no return, so to say. Emergency continuity, that's a completely new thing that was also recommended by some feedback from the community. And this is not to be confused with any derecognition. This is more of a force majeure situation when we talk about business continuity, operational continuity of the global registry system. And so there are mechanisms in place to quickly transfer operation of an area to another designated emergency operator in urgent situations. And of course, well, urgent situations you have to prepare beforehand, not when the urgent situation happens. So there are some provisions in the document that say, well, who is the emergency operator and what it needs to perform. Now, there's some safeguards, so it's not a capture or not takeover by other areas. For instance, they request unanimous agreement of areas and ICANN, that has to happen. It must be time limited, it's 90 days, which can be extended, but again, there is a discussion around that and should be public. And publicly justified and followed by community consultation. Right, so those safeguards, it's a continuation of the previous slide. They ensure that it cannot become a substitute for derecognition or takeover of other areas. Yeah, 90 days and post-mortem lessons learned of what happened and how we should avoid that. And there are also other things, not less important, but we couldn't group them in one particular category. Rectification, there was some, well, again, there were different feedback. People were suggesting certain grace periods when areas have to bring their backyard in order with whatever potential amendments, or with this document, when this document is ratified as well. So what is specified here is that it depends. It depends on the amendment, really. Some amendments can be rectified in a month. Some of them take longer. So that's why when amendment is proposed, part of the amendment is actually the grace period. How much time is given for the areas to become compliant with this new amended document. For the migration from ICP2 to this document, right, that's the same thing. And that's a change, and that's case in point. A 3-year grace period is specified. So areas are given 3 years to be fully compliant with this new area governance document. Dispute resolution, that's one thing that, I mean, the area should have a dispute resolution process that allows their members not to, go ballistic, but maybe resolve the conflict with more peaceful, by more peaceful means. Good faith. Well, that's very important. But the whole proposal is, assumes good faith, that areas are acting in good faith, and it is describing the system where areas are cooperative, right? Where the system is actually operating on collaboration. It's not hostile. It's not competitive. My personal opinion is that if those principles, they change and there is no good faith, we'll need another document. This document may not work. Right, I think that's all the sort of highlights of the changes. Again, please read the document itself or the summary and rationale. And there are a few reminders. So the consultation period is open till the 7th of November. So please submit your feedback on the mailing list. Now, here soon as well. And yeah, with that, I think I'm done with my...
Thank you, Constance and Andre. Just 2 or 3 things so before coming to the discussion, so you can go behind the mic if you want to ask your question or to say something. So regarding what we presented, and there could be online question as well. Just to thank what is called the CCG, which is so the communication team from the regions, who help us a lot about drafting the document, helping gathering all the comments. So you have Ulka, for instance, here. Thank you. Also, thank you because we have a lot of legal questions. So something we are not legal. Some of the members of the council can be legal, but personally, I am not. So we have the support of the legal team. So you have Atina and Michael, for instance, Michael from the Arin region, who help us. They don't decide. Be sure. It's just a support regarding that. And another thing, there has been recently a change. You know that there have been elections within the Afrinic region. The Afrinic has now an executive board, was quorum, and we hope very soon to have 1, 2, or 3 people from the Afrinic coming to the NRO-NC, so they won't have this issue of not having completely the absence of the Afrinic there, so which will be a very, very good thing. I see Jim behind the mic, and after Jim, perhaps we can go to online, perhaps we can balance.
Thank you, Hervé. Jim Reid speaking purely for myself. I have no organisation behind me. I have 2 points or observations, an easy one and one that's maybe not so easy. So the easy one is I understand you and your colleagues have done a fantastic job, have had some legal advice about the proposals you're putting forward. Would it be possible for that information to be made public? One of my concerns around this stuff is that parts of these documents smells a little bit too much of a cartel, anti-competitive in some respects, even though we're all supposed to be collaborative and working together. From the outside, it might look as the existing RIRs are acting in a form that says, we get to decide whether you can join our club or not, and that might not stand up to a legal challenge. So if there's some legal advice around that, I'd appreciate it if it could be made public. I realise there might be some discussions with lawyers around that, but hopefully that could be solved out. The more difficult issue I have is on this question of unanimity. And as I have made comments on the list and also privately to yourselves, is we could have a situation where an RIR is unable to express an opinion or make a recommendation on the formation, the creation or removal of an RIR for whatever reason. Not necessarily because of a situation where an RIR hasn't got a functional board. It could be joined with some kind of legal action or whatever. But if we're in a situation where one of the existing RIRs cannot express an opinion, then you don't have unanimity. Therefore, you cannot make a decision about anything. You're effectively stalemated at that point. I think this problem really needs to be fixed. Now, from what Andrew just said a moment or 2 ago, he was talking about, I might have misunderstood, as being suggesting that unanimity could just be the RIRs who expressed an opinion. Well, that's not the legal definition or the dictionary definition of unanimity. It's essentially those who voted, even though we're really not talking about voting here. That's not the same thing. So I think we need to solve this in another way. My preference would be to do this through consensus, because that's what we do in the internet everywhere. We make decisions by consensus. And I understand there's a problem there because some RIRs don't have a definition of consensus, or they don't have a common definition of consensus. So one way might be to define consensus in a very simple way, which is lack of sustained reasonable opposition. Now, if we can't make that fly for whatever reason, I think the other possibility then is to have some kind of supermajority. Let's say 2/3 of the existing RIRs rounded up to the nearest whole number, expressing a recommendation would be enough to give the strong sense that yes, there's a recognition from the existing community that an RIR could be created or removed on that basis, but not unanimity in the sense of where all of the existing RIRs have to make that decision. I think that needs to be tackled. And now that I've finished ranting and saying my piece, I just want to repeat once again, I'm very, very grateful to you and your colleagues for all your hard work you're doing here. This is an important job and it's important to get it right. And I'm very glad you're doing it because in some ways it's almost a thankless task. So keep at it, and I very much appreciate all your persistence in all this. Keep it up.
Just a few words, perhaps. So I don't know. Perhaps my colleagues want to answer because we know this discussion, and I don't know if you are behind the mic. Perhaps for other things or the same thing, Atina.
I would just like to address the first question you posed, if I may. Yes, like indeed, these concerns came in our minds like very early in the process. And that's why we had external, actually legal advice on the matter. The preliminary outcome of this advice actually is very positive. According to that, the RIR activities fell out of the scope of competition law, at least from the EU perspective, EU competition law perspective. And even if one suggests that no, actually, they do fall within the scope, we fall also under an exemption. So we feel that the concerns are addressed, and we're looking into having like a solid final opinion on the matter that we can also publish for the rest of the community.
That would be fantastic. Thanks, Athena.
Thank you.
And after, so regarding consensus one more time, so your comments are very rich, and so we can spend a lot of time about that. And for information, so we will meet 3 days in Montevideo in November, which is a LACNIC legal place, to discuss all that. So you saw that there was a chance regarding the consensus process compared to the previous document, but there is a lot, and you say that also that if we go to a consensus, something could be difficult also because the definitions are not the same. So that's my preamble, I will say, so copying the document. I don't know if Andre or Constance, you want to complete what I say, because so there is a lot, one more time, to do, and we really appreciate so the comment.
Just I can add your concerns about anonymity. So we take this with us, and so we discuss this in the team. And so this is very, very good question. Yes.
Thank you.
There is no. Desiree?
Yeah, Desiree Milosevic speaking as a member of a community. So first of all, thank you so much for this work, for trying to tighten up the governance model and adding the auditing for every 3 years. I think it's a good improvement, but glad also that Jim spoke before me, because of what he raised was that aiming for unanimity in the vote is especially difficult, especially if one RI is in question. Therefore, you won't be able to achieve much. I'm in favor of this 2/3 or removing the body that is being, questioned or triggered, or otherwise the document reads completely differently. That the one who has been challenged could also participate in the vote. So thank you for looking into that. Thank you.
Thank you, Desiree. And I think so we'll spare perhaps half a day in Montevideo to discuss this question. perhaps we can go there. No?
C'est moi?
Neil, c'est toi.
Okay, it's Neil O'Reilly, and I see I'm going to talk about something I don't really have any qualification to talk about, but ignorance has never stopped me before. I think the question is still important. There are two aspects to the outcome from this. One is the new processes which would be adopted, and that has been made that looks to be very clear and probably to be converging. And the effort, as Jim already said, of the NRONC in doing this work, and from my point of view, particularly for the delegates from the RIPE region, is something I'm very grateful for. But the second aspect of the outcome is the community narrative, the documentary history of the process. And what's not clear to me is whether this will be a new document in the ICP series with a new number, whether it will be a first document in a new series or something else. But I think it's important that ICP2 will be frozen like an insect in amber as part of the record of the status quo ante. It's what I see in the RIPE community, in the IETF. An old document is never hidden. It's kept, it's marked obsolete, it's superseded by a new document, and this supports the narrative continuity of the community. And I think that's a very important aspect which shouldn't be lost. And I'm wondering what the end point of the documentary history will be. And yeah.
And so we totally, of course, we accept your question of comments. And so it was not the good word, but we are very happy you asked this question. Why? Because we discussed that no later than this afternoon and in your specific words. So you are totally in line when specifying that. And I see Hans-Peter behind the mic because I know that you have so answers or something to say about that, I would say.
Yeah, I wish I had the answer. The answer is an idea. Hans-Peter Holing, chair of the NRO-EC. ICP2 was a document series that was started by ICANN in the early days, and it got to number 3 or 4 and has since been disbanded. So the successor document will not be in that document series because it's a non-existent document series. Now, most of the other ICANN SOACs that we like to compare ourselves with, like SAC and RSAC, have at some point, actually quite a bit back, figured out that it would be very good to have a document series that we number the numbers in. So SAC at an early stage said that, okay, we have published these documents, let's number them and then continue this series. RSAC did a slightly different flavors. They do version of documents, so that's a bit so. Creating a new document series for the ASO NRO space along those principles, like your RIPE document series, RFCs in that spirit, is kind of on my idea block to propose to the NRO-EC and the NRO-NC. It's kind of like, should it be the NRO series, should it be the ASO series, and then should we retrospectively number everything that we have here so we have a record for the future. So yes, I'm in favor of that, but the exact proposal isn't really on the table yet, but hopefully it is before we have consensus on this document. So if you have ideas, Neil, then just come here and we can.
Sure, but what I wanted to do today was simply to give input from the community that this was a matter of concern. And if you need sort of documentary input from me, you know where to find me.
Of course. And thank you, Neil. And when speaking about the ICANN, I realized that there are great guys I didn't thank because so there is also the ICANN under consultation. There is the ICANN community. Is the ICANN which is a great support. So we have Carlos and Andrew there. I want to thank you also.
Hello, thank you. Tom Hill from BT. I'm minded to think at the moment about abuse of this policy and in the way that people may contort the language that we ultimately write down. I recognize from the summary document that there has been a lot of questions raised in the past about whether or not RARs, new RARs, could overlap with another service area. It's good that that's been clarified. I've been wondering about what the role that the NIRs play in this situation, representing communities, countries, potentially multiple countries banded together. Have we given thought to the idea that a group of NIRs, or an NIR that represents multiple nations, could potentially put forth a proposal to seed from an RAR and form their own regional internet registry? Do we want to call that out explicitly? Do we want to deal with that, or do we want to say that's normal, that's fine?
I will have, thank you very much first. I will have a first answer, and I will let my dear colleagues to complete. For that, so regarding the national internet registries, it was not decided, but so the purpose of the document is to say that it's up to the registries to deal by themselves how they deal finally the management of resources internally. So we are not against, I would say we have not a strong opinion about the presence or not of national internet registries. But if so the condition to have national internet registries is there won't be an impossibility to fulfill for the regional internet registry to fulfill finally the principle raised in the document. That's the first thing. After, so I let you if you want.
Sure. Yeah. No. Yeah. I think if you ask me, that would be the most natural way of a new area to appear, right? You already demonstrated community support. You already operated in this space. Whether that should be explicitly stated in the document, that's another question. That's again the balance between the level of detail. Maybe that's a recommendation. Maybe that's an implementation procedures. I think embedding this in the document may not be very productive. Like if you look at how LACNIC or AFRINIC were created, they were created before, well, LACNIC was really created de facto before ICP2 was in place. Like it was already operating. So I would wonder if absence of this explicit statement that NIR can sort of progress into the area would impede an NIR to submit such proposal. In my opinion, it would not. Putting this in the document creates some, I think, conditions that might not work in the future, or maybe sort of be compared with other conditions when there are no NIR. Does it say that not being an NIR prevents you from becoming an area? So you see, the thing is, and that's what we also heard from some of the community members, keep it as simple as possible, right? We tried to do this. We didn't succeed fully. I mean, if you read this document, I would say that the simplest document you can read, but we tried.
Yeah, so Hans-Peter Holing, this time CEO of RIPE NCC. Be aware that we do not have national internet registries in the RIPE NCC service region, and I don't see an easy way of forming that. So, you know, I would not be in favor of introducing global policy-like documents that describes national internet registries. That's a regional issue. So I would try to stay on a common denominator. And since we don't have national internet registries, I would prefer not have to deal with that and potentially have the pressure to establish some.
I realize there are none in the RIPE NCC region today, at the very least. I think what I'm getting at is if there becomes a recipe for gaining your own RAR through the use of NIRs, perhaps what should only be called out, if it is called out, is that having formed an official NIR does not give you any greater claim to a service region. Perhaps.
And while that is an interesting perspective, another interesting perspective is that if you today, as part of the RIPE NCC service region, are contemplating changing the structure, the only other option you have is to form a new RIR. There is no option to form an NIR, right? So.
Okay, thank you.
Thank you.
Okay. So, hi, my name is Danko Jevtovic, a community member, but I'm coming here from .rs Serbian country code. So I was there at ICANN where this document began to be discussed. And now looking at that, I think the progress is great. I also think that positioning, how it's done now of ICANN is appropriate. In a way, it's also bottom-up organization, so we should give it some trust, but obviously the way how RIRs have the decision power is good. I think my thinking goes into this discussion about level of this document. So you mentioned this is quite a high level document and the implementation details will be separate. But I think we have a significant problem there. I think we need to put more teeth into this document. And I think that if we try to stress test the document, even with the problems we have them today, we see that there is nothing in the document that will really help us with the situation. The problem that I see is the document does not mention what is happening with the currently assigned resources, meaning IP blocks to the entities that have been assigned to. So if we have a derecognition, a recognition of the new regional internet registry, what will happen? Probably some new policies will happen. So I think that we cannot leave that to the implementation document. I think we need some sort of high-level government guidance here now. So when I try to be creative, because I was a bit detached from the process, I have kind of thinking anew from the side. Maybe it was all discussed, but maybe we can grandfather the allocated blocks. Maybe we can prohibit transfers. Maybe we can even give some period and then the assignments have to be assigned with a new policy or return or something like that. And bottom line here is this stress testing and teeth. If we have document now that is not really helping with the current problems, then the question is why we are doing that. It's good to have it. But probably I think that we need to make, for how to say it, theoretical RI that has structural problems, we need to make this document worse and more pain than fixing the structural problems. That's something that will really help the community. If this discussion is taking a long time, we saw the timeline. So if you leave that to another layer of discussion for an implementation document, it will take another many years. So it's better, maybe, in my opinion, to bring this key problem back into this discussion and start, putting that into open. Thank you.
And thank you one more time. And it's really an ongoing discussion we have, and we have it since, I would say, since the beginning. So thinking of the level of details we have to that. So you stress the problem of assignment of resources, but there are other problems that can be discussed and solved. So that was, so we answer. So from now to say, so it will be in a separated document. But we know that this document on these details one day will exist. So we are sure about that. So the question is, so do we have to deal with that now or later? But we have that in mind.
Yes, and you are right. We have that current problems. Yeah. But we have to care a long-term stability. That's the way we go forward. That's the first. And we actually try to care about the current problems. So we invite you to support us, to give us your ideas, take part in the sessions, and so we can meet us in this term. And so you're invited to give advices how we can go forward.
Yeah, there is a question there, and then to Randy.
Yep. Mic on? Yeah. Thank you. We have an online question from Andrew Campling. Andrew says, excellent work and outstanding focus on consultation. Regarding acting in good faith, how and by whom is this determined? Who or what decides what process applies in the event that it is determined that one or more RIRs is not acting in good faith?
I will say, that's a good question. That's that's right. That's the reason why. So we introduce in the process third parties. But so if we come back to so the details on operational process, so it's something so we can answer. That's why also on the definitely we agree that that's something that must be impartial or so independent, of course. But we have to define also this term of independence.
Yeah, I would think that might go into the implementation procedures for auditing, right? Where you really sort of detail what kind of parameters you look and how you determine, for instance, good faith as well. But again, and I think that that's back to the previous session, whether we want to sort of go and embed this in this document, or whether we should rely on sort of, community wisdom, that when situation arises, we can sort of discuss and create those procedures. The thing is, going back to LACNIC, for instance, creation, I think if you look at this document as a sort of instruction how to create or recognize or derecognize area, yeah, it raises all this type of questions. But in fact, what it sets the boundary conditions, in my view, and all this kind of nitty-gritty details, they were agreed by LACNIC before the ICP2 was in existence even, right? So LACNIC was de facto operating before ICP2 was adopted. So that's why ICP2 doesn't go into this nitty-gritty detail. It does, but in the form of discussion. It says, well, it can go this way, or it can go this way, right? In this document, we have chosen a different approach. We do not show options, right? It's not an implementation guide. It's more a, sort of policy, a framework that sets the boundary conditions, leaving to the communities or to the, I don't know.
I yield to Athena.
Ability to develop those implementation details.
Yes, thank you very much. I realize I did not introduce myself the previous time I went on the mic. My name is Athena Fraguli, Chief Legal Officer of RIPE NCC. I appreciate a lot the question that was made about the good faith. Yes, it's a very it's a term that is used in the legal language, and it's up for interpretation every time. It takes into account various circumstances on a case-by-case basis and so on. However, in this particular case, in the provision 2.8 good faith, we try to focus a little bit on the following. We say all actions required under this document shall be undertaken promptly and within reasonable timelines, ensuring that processes are not unduly delayed. So when we talk about good faith, we focus a little bit on responding on a timely manner and giving opinions in a timely manner, on acting on a timely manner. And if this is not the case, then there might be reasons to claim that an RIR does not act in good faith. Thank you.
Thank you, Athena. Randy.
Randy Bush, RGNet, ARCUS, IIJ, Research. And Jim, I mention these not because I represent them, but because I want you to know my biases. Okay. So it's just good manners that I do so. If you want complexity, the IETF meets next month. And I really dislike complexity. The first time I gave a talk, and I believe it was at RIPE, on how just at the time, this is the late 90s, just 3 RIRs were driving me crazy because of the different procedures, the different, I don't have to go, many of us experienced this, the lack of real progress on coordination with the current number of 5 RIRs does not make me want more RIRs. It makes me want to work on the problems of making the whole community work together. And for those others in this room who do global scale operations, we all feel this pain. So I do see the downsides of the unanimity point. I also see the upsides. I'm an engineer. I'm less worried about the process of whatever we're calling it, to turn off an RIR, than the fact that the actual engineering cases we've had is a failure of an RIR, not the community deciding to eliminate that RIR. So I want to deal with the real problems we have, not the corner cases that we can imagine. If we want to imagine corner cases and do complexity, as I said, IETF meets next month.
Thank you, Randy. I don't have the exact words in the document which is under consultation now, but we have something who meets so what to say in terms that so regarding the number of potential regional territories, we just say that so it has not to impinge easy way to work. I would say it's not exactly like that, but it meets what you say. Yeah. 5 minutes. 4 now. 3.
Evening, everyone. Alexander Timokhin, speak for myself as a member of community. Well, thank you all for coming, and thank you for the splendid work that you've done. Is it perfect? Most likely it's not. Does it cover everything? I think it doesn't. But the most crucial question is it better than the current document? And my answer to this, yes, it's definitely better. And that's what all you need. You cannot always get it perfect 100% on the first try, but it doesn't stop us to improve. So, thank you.
Thank you very much. Two minutes left. Time for one question.
Well, Wolfgang Zenker.de, speaking for myself. More a comment than a question. My impression is that most of the technical community is not really working a lot in the governance area of stuff. So what I think would help a lot to get more input from the technical community is if you presented a walkthrough through the process, starting from what goals you want to reach, why you want to reach them, and then walk through the draft, explaining we choose to use this text with the goal of implementing these top-level goals. Yeah.
Well noted.
Didn't you just do that?
Thank you. We have. It's so. If not, thank you, Sander. So if not, we really thank you to have spent time to be with us. Yeah. Yes. Yeah. And of course, as Andre records, we are here all the week. You can talk with us during the break at noon. There will be presentation during, and there will be outputs on the resume of the outputs of this discussion on Thursday during the plenary session also. Thank you.
Thank you.